we can safely protect them.
You're listening to the Curious About Cannabis podcast. So cannabis contains a lot of different chemicals. Depending on what research paper you read, there could be anywhere from 400 to over 500 compounds that have been characterized in cannabis so far. But some researchers think there are likely far more chemicals in cannabis.
You know, the idea that there's only 400 compounds in cannabis, I think is super naive as well.
That's Kevin Spellman, a molecular biologist and phytochemist that's dedicated his entire professional career to trying to understand why plants affect the body the way they do. And lately, he's had his eyes on cannabis.
If you look at corn and you look at wheat, respectively, they have found 3,000 and 5,000 different compounds in there. And these are probably the most studied plants, right, analytically. Yeah. And so I can tell you with certain clarity that there's at least 1,000 compounds in probably every single plant.
So despite what the scientific literature may say, there very well may be 1,000 or more chemicals found in herbal cannabis alone. But when cannabis is burned, however...
Smoke is really complex, obviously. There's thousands and thousands of compounds in smoke.
That's Justin Fischetic, a natural products researcher that once burned cannabis joints to see what was in the smoke. Of course, all for science.
Yeah, it's kind of funny. We quite literally would take joints and burn them with a pump that would suck the smoke into a solvent, which was kind of somewhat, it was in a fume hood and whatever. You know, we never started any fires doing that. But yeah, we had students whose job it was to basically light the joint and have the pump was on a timer, and the pump would like imitate somebody inhaling for a certain period of time. And we just collect that's the vapor into the solvent or the smoke into the solvent and analyze that. Smoke is really complex, obviously. There's thousands and thousands of compounds in smoke, and you can't analyze them all necessarily just using GC. But cannabis smoke has been well characterized in the past, mainly to show how dangerous it could be. But like burning any plant material, you're going to make lots of toxic compounds. But yeah, we worry. There are still terpenes in cannabis smoke. I'm sure there are all kinds of side reactions that happen with them, but we couldn't identify all that stuff. It wasn't really worth our effort. But that also happens with the cannabinoids too. There's a bunch of side reactions that happen and all kinds of new cannabinoids are formed. But for the most part, it's still the major ingredient, THC.
Cannabinoids like THC or CBD are by far the most abundant compounds found in the resins that surround the female cannabis flowers, which if you didn't know, that's really what most cannabis users are after, are those resins. Now, THC and CBD actually appear in the cannabis plant as slightly different molecules, as THCA or CBDA, and when they're heated up, they change into their well-known counterparts, THC and CBD. So to start our journey of trying to understand just how toxic some of these compounds in cannabis might be, it makes sense to start with some of these primary active constituents of the cannabis plant, THC and CBD. In one now pretty much infamous study that was done in 1973, dogs were given THC orally in escalating doses, all the way up to 9 grams of THC per kilogram of body weight, all in an attempt to try to find a lethal dose. To put that into perspective, it's not uncommon for a lot of dogs to weigh somewhere between 20 and 30 pounds. So in kilograms, that would be like 9 to around 14 kilograms. So let's go on the low side and assume a 9 kilogram dog. This study would have administered around 80 grams of THC in a single dose orally to that dog. And even at dosages that high, they weren't able to get a lethal response. Now, if you want to think about this in terms of cannabis joints or cannabis cigarettes, consider a joint. Let's assume a joint has around a gram of cannabis in it, and let's say that cannabis contains 20% THC. That'd be 200 milligrams per gram of THC in the cannabis, which would mean that there'd be 200 milligrams of THC in the joint if the joint has a full gram of cannabis in it. And so to get the same kind of dosage that these dogs were getting, you'd have to consume like 400, 500 joints at once. And that still would probably not kill you. Now let's jump forward from 1973 to 1988. there was a petition to try to reclassify the legal status of cannabis. Now, cannabis was and is currently at the time of this recording considered a Schedule I drug by the Drug Enforcement Agency, or the DEA. This category of drugs is reserved for drugs with no accepted medical use and a high propensity for abuse. Other drugs in this category include things like heroin and bath salts. Well, in the 80s, there was a push to try to reschedule cannabis, and an administrative law judge, Francis Young, issued a report commenting on the whole issue. And in this report, he stated, in order to induce death, a marijuana smoker would have to consume 20,000 to 40,000 times as much marijuana as is contained in one marijuana cigarette. A smoker would theoretically have to consume nearly 1,500 pounds of marijuana within about 15 minutes to induce a lethal response. Now, by that measure, if you're trying to consume 1,500 pounds of marijuana in 15 minutes, one, I don't think physically you'll ever be able to pull that off. But second to that, even if you could, you're going to have some way more serious issues related to carbon monoxide poisoning and tar exposure than you would need to worry about with any issues coming from cannabinoids as far as a lethal response goes. But that was THC. What about CBD? As recently as this year, in 2019, a report was issued claiming that CBD was identified as being toxic for the liver. Publications like Forbes promoted headlines reading CBD causes liver damage. So is this something cannabis consumers need to be concerned about? I had the chance to talk about the safety of CBD with Dr. Ethan Russo, a neurologist and cannabinoid researcher that worked as a medical advisor for the development of two cannabinoid pharmaceuticals, Sativex and Epidiolex. Epidiolex, specifically, is a pure CBD pharmaceutical.
There was an article that came out recently. It was a rodent study. The doses of cannabidiol that they were using purportedly producing liver damage would be impossible to attain in a human. And somehow this travesty passed peer review and was widely reported by the media. It has no correspondence to reality. I just wish that it had been sent to me, and I would have done my best to ensure that it didn't deserve publication. And this kind of thing, unfortunately, this kind of material is often produced with taxpayer money.
Yeah.
And it's more than intellectually dishonest. It's downright dangerous and unethical.
If you look up the LD50 for cannabidiol, or CBD, which, in case you don't know, LD50 just stands for lethal dose 50%, meaning what is the lethal dose that will kill off 50% of a target population. And usually this is in rodents, monkeys, or dogs. If you look up the LD50 for cannabidiol, you'll typically find data reporting intravenous doses of over 200 milligrams per kilogram of body weight. Now, it would be extremely difficult to get that much CBD in your bloodstream through typical consumption methods. To put this into perspective, for an average human that weighs 65 kilograms, or around 144 pounds, 200 milligrams per kilogram equates to a dose of approximately 13,000 milligrams, or 13 grams of pure CBD. And this 13 grams of CBD would have to be in your bloodstream to reach this LD50. Now, consider that CBD-rich cannabis, like hemp, contains approximately 10 to 20% CBD, or 100 to 200 milligrams of CBD per gram of cannabis flower. So if you consume a gram of CBD-rich cannabis flower, you're ultimately going to be exposed to maybe 200 milligrams of CBD at best. Now, ignoring the fact that not everything that's in that flower is going to actually make it into your body, and ignoring the fact that everything that makes it into your body is not necessarily going to make it into your bloodstream or reach any sites of action in your body. Ignoring all of those facts, 200 milligrams is approximately 1.5% of the 13 grams you would need to get to the lethal dose.
I've seen a lot of people conflate, even in presentations at conferences, conflate the side effect profile of pure CBD at high dosage to CBD in general, and that's not a fair comparison. I would say that cannabidiol, despite its many complex mechanisms of action, is an extremely safe drug with very few adverse events.
Now, to put this into further context, let's consider the LD50s of some other compounds you might be familiar with.
Time out for many men of medicine usually means just long enough to enjoy a cigarette.
For nicotine, the LD50 is around 8 to 13 milligrams per kilogram of body weight, which for most humans equates to something a little over a half a gram of pure nicotine, which equates to about 40 cigarettes or so. 40 cigarettes, that's still a lot, but you can see how that would be actually physically possible to achieve, and something that you need to really be careful about. You can, die from nicotine poisoning, although it is pretty rare. Now, what about caffeine, another drug that, people are commonly exposed to, even more so than nicotine? The LD50 of caffeine is 200 milligrams per kilogram of body weight through oral administration. Now, this is important to take note of. This is 200 milligrams per kilogram, which sounds similar to the CBD LD50 of 200 milligrams per kilogram, but we're talking about oral administration in caffeine versus intravenous administration in CBD. Huge differences. Not everything that you consume orally is going to make it to your blood. So the LD50 for caffeine is actually a lot lower than CBD, meaning that it is easier to achieve a lethal dose of caffeine than it is to achieve a lethal dose of CBD. Now, 200 milligrams per kilogram of body weight for oral caffeine, that ends up equating to somewhere between 75 and 100 cups of coffee back to back as fast as you can drink them. Once again, pretty hard to achieve. Maybe that's possible. You'd probably have a number of other issues before you got to that 75th cup of coffee. But the point is that reaching the lethal dose for CBD is even harder, much harder, than even reaching the lethal dose of caffeine. Now, you may be saying, okay, sure, it may be difficult to lethally overdose on THC or CBD, but cannabis is a lot more than THC or CBD. And you'd absolutely be right. So just how many reported deaths are there associated with cannabis use? While many advocates of cannabis claim that there have been no deaths attributed to cannabis, that's not exactly true. However, the number is still extremely, extremely low. There have been a handful of case studies reported that have linked fatal heart attacks and lung infections with cannabis use, but these reports have been difficult to confirm definitively. During autopsies, they tend to try to look for drugs in the system, and cannabis tends to stand out, and there can be a number of reasons for that. One is that cannabinoids linger in the body longer than a lot of other drugs. But even with that controlled, there are some cases where it seems like the only thing out of the ordinary that someone encountered right before they died was cannabis. And we can't just totally rule those case studies out. Now, consider there have been this handful of reports of people that have had these heart attacks or lung infections that have died supposedly because of their cannabis use. Now, let's also consider that there are estimated to be approximately 100 million people in the United States alone that admit to having at least tried cannabis once, and well over 30 million people that are classified as regular users in the United States. Now, that's just based on how many people are willing to admit their own cannabis use on a survey. The actual numbers, we don't really know, but, we know there are a lot of cannabis users in the United States. So we're looking at a handful of possible fatalities linked to cannabis use, compared to tens of millions of users, regular users, repeated users. So let's assume 1 out of 10 million users were to die from cannabis use in some way. We'll be kind of ultra-conservative here. That would mean that you would have a 0.00001% chance of dying just from cannabis use. And even that's an exaggerated number. To put that into context, you'd have a much greater chance of dying by getting into a car crash or getting struck by lightning than you would from using cannabis. So okay, it's unlikely that anyone's going to die from a lethal overdose of cannabis. But what about other health risks?
Remember that old lady who was killed by what was called a marijuana-crazed youth?
Under the influence of the drug, he killed his entire family with an axe.
All reefer madness and propaganda aside, there are a variety of research papers out there that have summarized the common, realistic health risks of cannabis use. One common symptom of cannabis use is dry mouth, also called xerostomia. Xerostomia can negatively affect mouth health if not managed properly, and can lead to changes to the bacteria and fungi that live in our mouths. This can potentially lead to things like gum disease, tooth decay, bad breath, and even an altered sense of taste, which is pretty strange. Now, many may assume that the dry mouth effect from cannabis use is related to smoking, but this does not seem to be the case. The dry mouth effect is directly linked to the stimulation of cannabinoid receptors in the body, regardless of how you choose to use cannabis. Another thing cannabis affects directly is blood pressure. Interestingly enough, cannabis can lead to lower blood pressure with repeated use, but at high dosages and acutely, cannabis can actually elevate blood pressure and heart rate. And this can be particularly problematic for users that have a prior history of heart issues, such as high blood pressure or previous occurrences of heart attacks. And this effect, of course, can be made worse by smoking. Additionally, if you're smoking cannabis, you also run a greater risk of experiencing chronic bronchitis and emphysema. THC-rich cannabis can cause motor coordination disruption, potentially increasing the risk of falls, home or workplace accidents, and car wrecks. However, this effect tends to be much more mild in frequent users that have built up a tolerance. THC-rich cannabis can present several psychological health risks to users, including memory disruption, anxiety, fear, and paranoia. When it comes to the negative psychological effects of cannabis, new or infrequent users are more likely to experience those effects compared to regular users. Additionally, cannabis can act as a precipitating event for mental health problems to reveal themselves in younger users, but we'll talk more about that later. Although cannabis has gained popularity for being a potential treatment for seizure and tremor conditions like epilepsy and Parkinson's, there has been some research that has revealed that cannabis could actually exacerbate these conditions, but more research is needed. In addition to these risks, there's also a condition that can develop in chronic users, usually in users that have been using high THC cannabis regularly for 2 years or more, called cannabinoid hyperemesis syndrome.
In states where pot is legal, doctors are seeing an increase in a violent illness.
Local doctors are seeing an uptick in a rare illness caused by chronic cannabis use.
For unclear reasons, the nausea and vomiting are relieved by hot showers or baths. Since 2009, emergency room visits for CHS in 2 Colorado hospitals nearly doubled.
The good news is that for anyone that may experience this condition, it typically goes away if you simply stop using cannabis for a while. However, there are some reported cases where users that stopped using cannabis to recover re-experienced the nausea and vomiting symptoms when they started using cannabis again. Cannabinoid hyperemesis syndrome is a somewhat controversial condition. There are some people out there that claim that it's likely caused by contaminants like pesticides in cannabis products rather than the cannabinoids found in cannabis. However, this has not been substantiated as of yet. We just don't really know exactly what's going on here. Also, in states that have legalized cannabis use, reports of this condition are starting to become more and more prevalent as people become more comfortable talking about their cannabis use with their healthcare providers. So potentially this condition is actually more widespread than once thought. We just don't really know yet. The next thing I wanted to explore were drug interactions with cannabis.
So cannabis can definitely interact with meds.
That's Jana Champagne, a registered nurse who over the past several years has focused her attention almost exclusively on cannabis.
That's one of the big areas we assess with patients. In fact, we have a list of criteria on our website under the FAQ that it kind of guides patients through a questionnaire. Do you have a cardiac condition? Do you have cancer? Do you have diabetes? Is it for a child or adolescent where they should seek medical oversight of their cannabis therapy? And pharmaceutical interactions are probably the big one that could potentially cause harm. And I know that is such an unpopular message, but I've seen some close calls. I've seen some near misses. And I'm telling you, in a perfect storm scenario, somebody could get harmed. And then the reputation of cannabis as a safe medication goes out the window. You know, I had an 80-something-year-old woman with chronic pain in Michigan, and she went into a dispensary, which she called a health clinic. She thought she was getting medical advice. Yeah. And, you know, for chronic pain, never used cannabis. She was taking metoprolol, which interacts with THC in a way that can cause somebody to think they're having a heart attack and they end up in the ER.
Yeah.
This bud tender sold her a 300-milligram THC candy bar. But don't worry, he told her to only eat half.
Oh my gosh,
this poor woman
150 milligrams.
was high for days, and thank God she happened to space it away from her medications, or that could have been a real problem. So, you know, and that's just, you know, a medication interaction, but then you have other interactions with like chemotherapies where combined with CBD, it can expedite liver failure.
Yeah.
So, I mean, there's definitely reasons to seek medical oversight, you know, when those conditions are present.
Other healthcare professionals I spoke with said that they're particularly concerned about interactions with things like blood thinning medications, chemotherapy drugs, epilepsy drugs, and immune system therapy drugs like HIV treatments. It's been long known that certain foods and medications can change the way the body metabolizes things, like other foods and drugs. This effect is so well known with grapefruit that some drugs even have an actual grapefruit warning on them. If you ever see a grapefruit warning on a medication, it's referring to this potential interaction that could occur where compounds in the grapefruit can slow down the liver's ability to metabolize a lot of different medications by inhibiting a group of enzymes called the P450 enzymes. This inhibition will cause the levels of medications in the blood to rise. And so for people taking drugs with really narrow safety windows, this can actually be really problematic. Well, it turns out that CBD exhibits the same effect, the grapefruit effect. The CBD market's just exploding, and the regulatory oversight's kind of weird on it.
Yeah, and CBD has the most interactions with pharmaceuticals.
Right, and the way it affects the liver. Yeah,
if you're taking warfarin and you combine it with CBD, it's going to increase the efficacy of the warfarin, and you can see where internal bleeding could be a potential side effect of that. If a patient's on hypertension medications and they want to try CBD for pain, we still teach, watch your blood pressure, take it every day. If it's low, you know, don't take one or the other, and document it for your physician and start talking to them about, I'm taking this and it's lowering my blood pressure. Mm-hmm. Can we start to wean off the pharma?
Anyone using CBD, particularly high doses of CBD, along with other medications, should be particularly cautious and work with a healthcare professional to stay safe. Let's review what we've learned so far. The primary constituents of cannabis resins, THC and CBD, or to be more accurate, THCA and CBDA, are not toxic, and it's virtually impossible to lethally overdose on cannabis or cannabis products. But there are other health risks associated with cannabis use, like risks to lung health, mouth health, mental health, and heart health. Many of these risks can be minimized by simply avoiding smoking and using low doses. Cannabis can interact with medications, and anyone taking drugs with narrow safety windows or medications that have a grapefruit warning on them should make sure to work with a healthcare professional to stay safe. So far, everything we've explored about the health risks of cannabis have ignored a critical element: contaminants. You know, so far we've been assuming that if you're using cannabis, that cannabis must be clean. But unfortunately, that's not always the case.
The cannabis contaminants that we're looking at...
Anthony Smith is a biochemist that has spent the last 5 years analyzing cannabis products for potency and purity in labs all across the United States and Canada.
Contaminants we're looking for are pesticides, residual solvents, heavy metals, mycotoxins, and then also microbiological contaminants, E. coli and or S-Tech, which is Shiga toxin, E. coli, Salmonella, Aspergillus, a total mold count or total aerobic plate count, which would be like non-specific bacteria. The most common contaminants that we find are definitely pesticides. I would say 4 or 5 years ago, it was like a rampant thing, where, At times in Oregon, some times of the year, we were seeing pesticide product failure rates at 20% or more.
Yeah.
I think the industry got a little bit of a black eye, but honestly, those rates today in Oregon, also in California for pesticide fails are, in the 2 to 4% range. It's really actually fairly low. And I mean, back in the day, I mean, a lot of those pesticide fails were products that were, consciously sprayed on the material. Mm-hmm. Either they didn't know that those materials were persistent in the product, or didn't care, or didn't consult the list of things. I don't know.
Yeah.
But today, mostly when we talk to clients that have pesticide fails, it's either a mistake or something that was overlooked, or
sometimes unlisted,
an unlisted product, or just kind of a lack of control. And not properly trained farm technician found something maybe in the farmhouse garage instead of in the sort of validated growing area, and used it by accident or whatever. Sometimes agricultural overspray from either neighboring cannabis farms or, in Florida, a lot of product is coming up with malathion. But there's parts of Florida where helicopters fly over the neighborhoods spraying malathion, in the swampy areas. So if you're not paying attention to that in your greenhouses,
just sucking it in and blowing it over everything. Before we continue, let's talk a little bit more about pesticides. Now, many pesticides are designed to disrupt the nervous systems or hormone signaling in insects. The effect this has is that it basically excites the insect so much that it becomes paralyzed and eventually dies. Now, the problem is that this same effect can happen in humans if someone is exposed to enough of a certain pesticide for long enough periods of time. You might be thinking, what's the big deal about pesticides in cannabis specifically? Aren't we already exposed to pesticides through our food? Well, technically that's true, unfortunately, but the problem relates to the way in which cannabis is consumed. You see, when you eat something, and if it has pesticides in it, your liver goes to work to try to metabolize those products and get them excreted out of the body. And it helps keep you safe. It helps limit the amount of pesticides that actually reach your bloodstream and get distributed throughout your entire body. However, when you smoke something, you're bypassing that metabolic process. You're not allowing things to go through the normal route and go through what's called first pass metabolism and allow the liver to break down some of those things before it reaches your blood. In your lungs, you've got these little sacs called alveoli that are basically the sites of gas and blood exchange. So when you breathe in oxygen, this is where the oxygen passes through the lungs and into the blood. Well, when you smoke cannabis and you inhale that cannabis smoke, if it has pesticides in it, those pesticides will actually pass through that barrier and reach your blood and then get distributed throughout your body without your liver ever having a chance to help you out. So that's really the main difference, why smoking things with pesticides in them is such a bigger problem than eating things that have pesticides in them. Additionally, some pesticides, like myclobutanil, which is a common fungicide often used by cannabis cultivators, can actually degrade into toxic compounds like hydrogen cyanide when they're heated. It's also really important to point out that many pesticides, as well as mycotoxins, can become concentrated in cannabis extracts. The whole process of making a cannabis concentrate can elevate contaminants like pesticides as much as 5 to 10 times the concentration that they were found in the cannabis flower that was used to make them. This means if you're consuming a cannabis concentrate, you're potentially being exposed to much greater doses of contaminants than if you were consuming the cannabis flower that was used to produce that concentrate. I also want to point out that it's not enough to simply test your cannabis flower for contaminants prior to making a concentrate. It's totally possible for there to be very trace amounts of pesticides or other contaminants present on that cannabis flower that are not going to show up on any testing. But once you make that cannabis concentrate and those contaminants get concentrated, all of a sudden you'll start to see them on tests at dangerous levels. Now let's go back to our conversation with Dr. Smith.
Microbial contaminants, at least on the Salmonella E. coli end, honestly, we don't really see any significant failure rates with modern, shelf cannabis. That stuff is all pretty clean. Those are contaminants, generally come from manure or bad hand washing. And so in California, occasionally we do see some problems with that in manufactured or infused products because they're, I guess didn't wash their hands making the cupcakes or whatever. Again, that's pretty low.
Yeah.
And not really a cannabis thing. We do detect aspergillus. We use PCR or polymerase chain reaction as a screening tool. So this is a way to look for like the genetic signature of a bunch of different microbes rapidly in a reaction. And then when we do get positive hits, those are always confirmed by direct culture plates. So aspergillus is still kind of a thing. This is why a lot of states require moisture content measurement and or water activity measurement. This is a means of benchmarking how dry your materials are and that you're cured to a certain level.
So you don't have to worry about mold or different types of fungi or bacteria growing out.
Yeah, absolutely. Also, while we're talking about mold and fungi, aspergillus and other dark colored molds produce their own sort of form of pesticides. They're called mycotoxins. There are a number of mycotoxins that are required to be tested for, again, and not yet in Oregon, but I would imagine we'll see that within the next year or two. To the chemists, they look much like pesticides with respect to like their chemistry and how you analyze them on a mass spec. But California has a specific requirement for mycotoxin testing, and so I would say the failure rate for those are about similar to like the mold failure rate. Those are really the signature of mold.
Yeah.
But they are persistent, where you probably would only find mold in cannabis flower. Just like pesticides, we do occasionally detect mycotoxins in more finished products, in resins and infused products.
Well, there's mycotoxins once produced are super, super stable. They're very heat tolerant.
Yep.
Even under high pressure, they seem to be able to survive those processes.
And unlike most pesticides, like we know mycotoxins are hepatotoxic and persistently or cumulatively, they cause cumulative liver damage. And so like your lifetime dose, if you will, matters. A lot of pesticides, you certainly don't want a lot of them in your bloodstream. Unfortunately, you actually do from food.
Yeah.
But a lot of those are, very well broken down by the liver, and they're generally not that toxic below a certain level. That sounds funny to say, but still.
Yeah. Well, the dose makes the poison, right?
Yeah, exactly. Mycotoxins, not so much. Yeah, they do cause liver damage cumulatively, and so it's definitely not something that you want in your food.
Yeah, and they're pretty carcinogenic too, from what I understand. And it's something that when Oregon was developing their rules, I was surprised that mycotoxins. There was discussion about it early on, and then it kind of fell out. But it was something that we did, some work trying to look at that, and we were able to confirm that, like, it's around for sure.
Yeah,
it's floating around. Not super common, but just in the context of public health and safety, and especially with how popular extracts are getting.
Yeah.
Just more and more in vape pens and dabbing and all this sort of thing. I have some pretty serious concerns about exposure to mycotoxins as well as pesticides and everything. But pesticides seem to be one of the first contaminants that states catch on to that needs to be tested for. And so there's, a lot more control over pesticides than there are mycotoxins. And it's so common for producers to take flower material that might be moldy or otherwise, can't be sold as flour, and to extract it and turn it into, a concentrate and then sell that. So what about heavy metals in cannabis products?
In like 2013 or 2014, Jeff Raber of the workshop published some paper where they were finding heavy metals in the vapor stream of low quality vape cartridges. So we've been thinking about it for a while and encouraging vape pen manufacturers to, when they buy these materials, get several different samples and bring handfuls of them to the lab, and we'll wash them either with like acidic water or sometimes MCT oil.
See what might come through.
And a lot of them indeed do leach a lot of metals, and it's primarily lead.
Yeah.
But also some mercury.
Yeah.
We do see some arsenic fails at times in cannabis. The story there was that we had a manufacturer or a farm, an indoor place, and they were anticipating doing metals test on their final stuff, and so they didn't really want to wait until the end and see. And so these guys were smart, and when their plants were fairly immature, just at the start of the budding stage, like we went and collected a bunch of materials. So basically immature buds, and they were loaded with arsenic.
Oh, wow.
So that, prompted a test of the soil and the water and the media and everything that we could. And turns out at the end of that story, it was a bunch of nasty rock wool.
Oh, wow.
So it was,
the initial growth medium. Wow.
It was just off the charts with arsenic.
The leaching of contaminants from cultivation, processing, or packaging equipment is an issue that people working in the natural products industry have had to think about for quite some time. However, some cannabis companies are still learning about best practices when it comes to these sorts of things, and this is ultimately putting consumers at risk. I spoke with Travis Simpson, an herbal scientist that spent the past several years working with hemp in the cannabis industry, and he shared some of his concerns regarding contaminants from manufacturing and packaging equipment.
Chemical compatibility is an ongoing issue I see within conventional THC and hemp processing environments. A lot of manufacturers are utilizing equipment that has not been thoroughly validated and tested, and can, in some circumstances, be utilizing solvents that might be denatured with other components in order to reduce costs in manufacturing. So one of the big areas that we see is ethanol manufacturers using things like heptane denatured alcohol, and how that has an actual impact on some of the fluid transfer equipment used in the manufacturing process. Terpenes are one of the great chemical classes produced by the cannabis plant. We, in the natural products world, would refer to that whole mixture as just essential oils that can be derived from steam distillation, subcritical CO2 extraction, some very cold hydrocarbon extraction, such as propane-based extracts, yield a very terpene-rich product that, unless handled with the appropriate chemically compatible material, can cause considerable leaching that will bleed into the products without any test methods in place to identify those. Other than the organoleptic, rubbery, or acrid smell that might come from some silicone products that are used for either in the world of butane propane extraction. The purging steps are an area where chemical compatibility can become a very considerable issue. But the essential oil market, some of these products can have as much as 7 to 10% essential oil by mass without ever being packaged in a method that takes into consideration the assault that might have on, say, a silicone gasket for a jar lid. Starting to encourage consumers to have compatibility conversations with their preferred manufacturer, I think, is a really good way to bring that topic up in a non-confrontational way, but at least provide the questions to the manufacturer to enable them an opportunity to express how they're addressing compatibility within their production system. And those manufacturers that cannot provide forthcoming information on their compatibility strategies would be a red flag as a consumer choice.
Yeah. One of the really important things to note regarding most of these contaminants, including things like pesticides, metals, and mycotoxins, and really particularly with metals and mycotoxins, is that you're not necessarily going to have an immediate reaction when you're exposed to these toxins. These things can build up in the body over time, and you may not exhibit any symptoms for a long time before the body finally reaches a tipping point, and then you're in trouble. So just because you've consumed a cannabis product and you didn't notice any adverse effects, that doesn't necessarily mean that you're not being exposed to harmful contaminants. This is why it's really important to verify that a product's been tested for contaminants prior to using it, and don't just take someone's word for it when they say that it's been quote-unquote tested. What was it tested for? You need to ask really pointed questions. Was it tested for pesticides? Was it tested for metals? Was it tested for mycotoxins? You know, for instance, currently at the time of this recording, in the state of Oregon, where I am, metals and mycotoxins are not required to be tested for in cannabis products. However, in California, they are. So, depending on where you are, when someone says that something's been tested, it can mean very, very different things, and it doesn't necessarily mean that that cannabis product is free from contaminants. So the takeaway from some of these discussions is pretty clear to me. Know the purity of your cannabis before consuming. But this is easier said than done. There are still many places in the US and abroad that have not legalized cannabis or established strict testing requirements for cannabis. For users that are getting their cannabis from the black market, they're really left at the mercy of their supplier's quality. And unfortunately, this can sometimes lead to tragic consequences.
We've got a public health crisis out there right now with additives in vape pens.
Yeah. Dr. Russo is referring to a recent string of fatalities linked to lung infections or lung damage associated with vape pens. People are calling it a vape crisis.
The latest tonight as the opioid epidemic hits Pennsylvania. Today, the state reported its first vaping-related
Two more
death.
Indiana residents have died from severe lung injuries linked to
17-year-old
vaping.
from New York has become the youngest person to reportedly die from vaping.
Death linked to a lung injury because of vaping is being reported here in Michigan.
There are now 20 deaths that have been linked to vaping-related lung disease in the United States. According to the Mississippi Department of Health, there have been 5 cases of vaping-related lung disease in the state, and so far at least
the Texas
one
Health
death.
Department has confirmed a death in North Texas from lung injuries related to vaping.
We have learned that a Bronx teen was the first New Yorker to die from a vaping-related illness.
Yesterday, the CDC reported the number of cases in the U.S. has reached almost 1,300 in 49 states.
Developments now in the ongoing vaping crisis. Lawmakers across the country weighing whether to put restrictions on it or ban it altogether.
At the time of this recording, there have been 29 recorded deaths and over 1,300 reported cases of lung infections or damage linked to vape pens. And these reports are growing at a rapid rate. While the exact culprit responsible for these illnesses and deaths has not been yet identified,
the CDC does not know the cause. There are all kinds of things circulating about what might have been the cause.
Investigators suspect it has something to do with additives or contaminants.
That actually has nothing to do with cannabis.
Yeah.
It has everything to do with additives that are toxic that are put in these devices. And so it can happen with nicotine vape pens. It could happen with cannabis vape pens or whatever. But I'll put the finger on the government. You wouldn't have this situation if we had legal commerce federally in cannabis and had standards applied to any of these products, because this is 100% preventable. If these things were available and regulated properly, there would be no need for kids to be going to a street corner to purchase black market vape pens with dangerous ingredients.
There's other evidence that contaminants in cannabis have caused very serious problems for some people as well, which in rare cases has led to death. There are several case studies available of patients that contracted fatal lung infections, such as a condition called aspergillosis. Aspergillosis is a condition where the spores of certain species of Aspergillus fungi get nestled in small little scrapes and crevices in the lungs where they begin to grow, forming a fungal mass called an aspergilloma. This ultimately starts to break down lung function, and it can be fatal. In some fatal aspergillosis cases reported, contaminated cannabis was deemed to be a contributing factor and possibly the sole cause. Now, this is more common in immunocompromised users than regular healthy users, but that just highlights the tragedy here. Many people with serious health conditions are turning to cannabis as a medicine, and those patients are the ones that are most vulnerable to the adverse health effects of consuming contaminated cannabis.
This is your brain. This is drugs. This is your brain on drugs. Any questions?
Kids today have become very wary of drug education of any kind, primarily because kids have been exposed to tales of exaggerated harms or even outright lies about drug use for decades as part of prohibition and abstinence-based drug education programs.
So in 1986, you could go in and lie to kids and
Right.
kind of like say whatever you wanted, but now they have Google.
This is Matt Vogel, a health and wellness educator that's spent a lot of his time focusing on teaching high schoolers and college-age students about substance use and harm reduction strategies.
Right,
They have their cell phones.
Yeah, they can fact check you in
Yep.
the moment. And it's interesting because a couple of years ago, I had a situation where I was presenting to a private high school to the seniors, and early on in the session, a student he said, does cannabis cause lung cancer? And I kind of, usually when that question comes up really early, it signals to me that someone has done their own research on that and they want to kind of get a sense of it. So I was just really straightforward. I said, we don't have data right now that shows that. We show that with chronic use, there is an increase in kind of, lung infections, and people get sick more and they have a cough and things like that. There's chronic bronchitis that can occur, but we don't have data around that shows it causes lung cancer per se. I said we may in the future, especially if people are smoking concentrates a lot in a chronic way. We don't know exactly what that's going to entail, but right now that's where we're at. And it was really interesting. So after then we had the whole session, there was really good discussion, good conversation. And at the end, he came up, and a lot of students sometimes have questions after, and they'll talk to me. And he said, "Hey, I asked you that question to see if you were full of shit." So, it's an interesting that kind of testing the waters out to see, can I trust this person? Where are they at? And I also would say, if you critique the Nancy Reagan just say no, it doesn't mean that you're just say yes.
Right.
That there's people think that you're giving permission or being condoning this type of thing. Not at all. It's really important to think to holistically think critically about this entire issue. But if we go in, with fire and brimstone, and that's all the only approach we're going to take, it's generally not very valuable. And that said, I have concerns about young people, especially adolescents, using high potency cannabis products and smoking dabs and other things. I mean, there's issues with that, I think, that are very real that we need to critique and think about, especially at that age, especially with new emerging research about the brain and brain development and the different and the new products around cannabis, more potent products. So it's something we have to think about and can't get completely dogmatic about.
When it comes to cannabis, kids have been told a lot of things. They've been told it'll kill their brain cells, that it'll lead to schizophrenia or psychosis, it'll make them lazy or stupid, or even cause them to move on to other drugs like cocaine or heroin. Well, it should first be pointed out that there are big differences between acute or just the occasional cannabis use and chronic or regular cannabis use. In general, acute cannabis use is pretty safe physiologically, with the biggest risks being risks of motor discoordination, which is why it's really not a good idea to try to drive after using THC-rich cannabis.
Let's go, Jack. I'm red hot.
Better be careful how you drive it. The first thing you know, you'll be ice cold.
And then also memory disruption and psychological distress like fear or paranoia. However, most of the major risks that adolescents learn about cannabis are associated with chronic or repeated cannabis use. While chronic cannabis use can alter the way the brain functions, and we definitely need to understand the consequences of that more, to say that it kills brain cells is a little dishonest. Yes, chronic cannabis use can definitely change the way the brain works. It can make certain areas of the brain less active, while also making other areas of the brain more active. But this is a complicated puzzle. In fact, in some cases, cannabis can actually encourage new brain cells to grow in a process called neurogenesis. While cannabis can exacerbate or reveal underlying mental health problems in adolescence, there's not strong evidence that it actually causes those problems. Typically, someone has to have a genetic predisposition to mental health problems, and cannabis can act as a precipitating event to make those mental health issues reveal themselves. And the only time that cannabis really seems to act as a gateway drug to other drugs seems to be when users are exposed to those other drugs on the black market. Now, the issue of adolescent cannabis use in IQ is a bit more complicated problem. Research has confirmed that there does not seem to be a link between cannabis use and low IQ, but there does seem to be a link between early onset cannabis use and poor cognitive performance. If you dig through the research, a common theme will emerge. The issue is that THC in cannabis can, in some people, interfere with the learning process by disrupting attention and memory primarily. Ultimately, users that are affected in this way have to work harder to perform as well as they typically would without cannabis. But a lot of these possible outcomes are difficult to assess because there's a lot of different variables that affect a person's cognitive development, including things like social factors, concurrent drug use like alcohol use, and underlying mental health disorders, just to name a few. In addition, everyone responds to cannabis differently. There are also a wide variety of cannabis products with different health risks associated with each of them. It has to be noted here that the context of cannabis use has a lot to do with outcomes. There are children, teens, and adults throughout the world with qualifying medical conditions that are using cannabis medically and exhibiting very few adverse events. In addition, CBD-rich cannabis or cannabis products that don't have intoxicating effects don't present the same psychological health risks as THC-rich cannabis products. Dose is also a really important factor to consider. Lower dosages of either THC or CBD will present fewer risks than higher doses. So if cannabis can be used responsibly in a way that minimizes adverse events, what does that type of use look like? And when does cannabis use become cannabis abuse?
The question between use and abuse gets really tricky because it's really hard to standardize. So with alcohol right now, for example, someone could say, well, what is adult responsible use of alcohol? And you can give all these things around risk reduction and never letting your blood alcohol content get above 0.06 and making sure you're hydrated and drinking water. You never drive a car, things like that, right? We know this, right? We have a number on it really around BAC, essentially not letting that point of diminishing returns, right? 0.055 to 0.06. That's where beyond that, you're going beyond the buzz point. We can really put that as a demarcation. That gets tricky with cannabis, right? Because it's almost impossible. What's the terpene profile? When was it harvested? Were the trichomes amber color or were they cloudy, right? Now is it more sedating because there's more CBN and the THC started to degrade based on when the person harvested it, regardless if it's a sativa or indica? What if the THC level is 15% versus 25%? Is it one hit or two hits or 10 or one hit of a concentrate? Right? It's almost impossible to quantify that based on all these factors that are playing into it. So I love this question. I'll ask young people, particularly, especially if I used to teach a class like for conduct if students got caught smoking cannabis on campus. So I know they already have experience with it or use it. I would ask the students, what does adult responsible use of cannabis look like? What if you had to describe that to someone? And that is a tough question for people to answer because it's complicated. It's harder to put this like quantifiable number on it. And so again, it's looking at it from kind of these different personal factors, and it's a very complicated one.
One thing I really appreciated about my conversation with Matt was his attention to just how complicated this topic is, and that there's really not a one-size-fits-all answer regarding teen cannabis use and the potential risks involved. Even just finding reputable information about cannabis can be challenging in this age of internet headlines and memes.
There's nuance to it, right? There's nuance to this entire conversation around cannabis, but people love things in we're in this time where it's kind of like, we get our information from a headline on social media, let alone going to an article that wrote about that came up with that headline,
Right.
and then let alone going to the research article that informed that pop culture article. It's not really happening. Everything is kind of like this. We're getting information from headlines and memes. Just yesterday, my daughter was like, "Hey, did you know Joe Rogan's running for president in 2020?" I was like, "That's not happening." She's like, "I saw a meme about it." I'm like, "Oh my gosh, please do not get your information from memes." And I do not think that's true at all. I've heard nothing about that. So it's like, it's just interesting what I have found, and I talk about this quite a bit whenever I present to whatever age group. I talk about confirmation bias, and I say of a confirmation bias essentially is we seek out and find information and research that already confirms our pre-existing beliefs and ideas about something, and we do this politically. We do it with a lot of things. Cannabis is really prominent with that. But we do this with so many things. So like most things, it's not black and white.
Right.
There's complicated aspects to it. And that's for me, when I do any kind of education, specifically when I'm doing it with like high schoolers or young college students, I ask them to really think critically about health and wellness and who they are as people. That to me, it's like, I have this flow chart that I have, if you're making a decision about substance use, and it's just all these questions that no one ever, I don't think a lot of times we're asking young people to think about, where am I at mentally, physically, and socially in my health right now? How will this decision I'm making impact that? What's the purity? What's the dosage? Who am I going to be with? What's my mindset going into it? What's the setting I'm going to be around? What would the people in my life who love and care about me feel about the decision I'm making? What impact could this have on my life in general, good, bad, or indifferent? Like just run through a series of questions for them to really process this and think about it. Because so much of this now, we have to keep encouraging people to think critically about their decision making and their life and their health, and not just kind of get on a team and say, that's the team I'm on, I'm going with it.
So let's assume an adolescent has decided that they want to experiment with cannabis and they're determined to do it. How long should they wait in order to stay safe?
In legal states, it's 21, right? So you could look at it from that perspective. From a brain development perspective, you could look at it at 25, which seems really irrational for a lot of people. Canada put out these federal guidelines a few years ago around risk reduction, harm reduction related to cannabis, and they're pretty solid. I thought they were really interesting. One of them, they said, it did talk about age, and it said if you could, it recommended waiting till at least 18. Now, gosh, I talk to 18-year-olds and I think, wait till you're 40. I don't know. I don't know if I can give a good answer to that, because everyone's maturity level is going to be different. And some of those biological factors, whether it be their endogenous cannabinoid system or their own mental health, sometimes maybe we don't even know that at that point. Some of the mental health issues are really found to really full on come on in like late adolescence, early adulthood. So if something like, especially a strong cannabis product is introduced at that time, could exacerbate things. Who knows? With data we have now, I think a lot of people are sort of pumping the brakes on this and saying, hey, wait a minute. If you're a teenager, please abstain from everything if you can. The longer you wait to ever try anything, the better the outcome will be with it. And you don't have to try it, right? Like that's the other thing too. Right. You might be 20 and say, I'm not interested. I don't need to do this. But it's different the younger you are. You think of yourself at 13, 14, or 15 years old. Like I try to ask people to walk through that exercise. Think of what the clothes you were wearing, the bike you were riding, who you were in that moment. You didn't know yourself that well. You don't know yourself that well at that time. You don't have a ton of self-awareness and physical development, social, emotional, mental development. It's a sensitive time. So to throw in a really intense experience, whether it be from a cannabis concentrate or too much of an edible, or they didn't know what they were doing and ate, 4 grams of psilocybin mushrooms or something and had an adverse response psychologically to that. Like there's risk with that. It can be an exacerbating event that can cause and lead to more of an adverse psychological reaction for people at those age. So I think like us being able to have that conversation it's a delicate thing to say, I want you to be empowered and really understand this topic, because I have data in front of me that says X number of teens are doing these things already. So we need to empower them to think about that. Yet we don't want to just say, yeah, you're going to be, the message of you're going to do this anyway, so be safe is a terrible message.
Yeah.
It's completely putting out an expectation that this should be happening and people are going to do it. It's more like my line around this is, you know, you may be around this, or you at some point later in life, you may try these certain things. So to have a really strong knowledge base and critical thinking skills around it is really important and empowering. And you also may be around it. So being around someone who maybe is engaging in something in an unsafe way, maybe you could help them.
This all begs the next question. What can people do to reduce the risks associated with cannabis use? From Matt's perspective, that begins with cultivating a healthy amount of self-awareness regarding not only substance use, but health and wellness in general.
There's a lot of stuff we could really look at in our life in general, I think. And whether that gets overtly marked down on a journal or just some self-awareness and self-assessment about food we eat or movement in our physical movement and activity, stuff like that. Yeah, it's an interesting one. Yeah. Around that, the self-awareness piece, and to have, you know, to be able to do that and say, wow, you know, I'm using cannabis way more than I want to be. Mm-hmm. And I've had students tell me that. I've had students say, I basically start my day off smoking a concentrate and I don't want to. I don't like it. It doesn't really even make me feel good, but it's just become such a way of being for me. It's hard for me to get out from under it. Or I stopped using cannabis and I thought it was helping me with my anxiety and I thought it was helping me with my sleep, but I realized it was the opposite. It was actually making me more anxious, intermittent anxiety, with depending on how high I got at that moment. And it was actually my sleep. It was rough for the first week or two when I stopped using, but now it's way better. And I sleep deeper and I sleep long. I don't wake up in the middle of the night, stuff like that. So it's interesting. Some of the things we think it might be doing for us, maybe it's not. So I think it's important, anything in life, to take away something, it really helps you reevaluate it.
And beyond all of that, Matt had a simple recommendation to reduce risk that was echoed by many of my other guests.
So I think my advice would be, one, starting off small, like with like low potency flower and having small amounts, whatever age you are when you first engage in this. And don't start off by smoking dabs, smoking concentrates.
I asked veteran cannabis and cannabinoid researcher Dr. Ethan Rousseau about his thoughts on minimizing risks associated with cannabis use. Right away, he wanted to bring attention to the diverse and sometimes uncertain quality of cannabis products on the market.
First and foremost is an issue of the preparation. Mm-hmm. Right now, it's sort of the Wild West out there. I can't vouch for the utility or safety of any preparation without a certificate of analysis. And I want to know exactly what's in it, not just the cannabidiol content, but other cannabinoids, the terpenoid content. Mm-hmm. I want to see evidence that it's safe, that there's no pesticide residue, microbiological contamination, or heavy metal contamination. Mm-hmm. And beyond that, I just won't comment. And I would urge consumers to be extremely diligent in trying to acquire that information. My bias is that that information should be available for every product, whether medical or recreational, at point of sale. I'm not a proponent of smoking anything, particularly in a medical setting. Vaporization potentially is a safer approach, but when we're talking about medical uses of cannabis, we're almost always talking about chronic conditions. Mm-hmm. And in that situation, best approaches are for oral agents or tinctures, say in the mouth even, and there are reasons for that. When that type of preparation is used, it's got a much longer half-life. Mm-hmm. Basically, the need for more frequent dosing is limited. Often people can treat their condition with dosing 2 or 3 times a day. This offers other advantages in that there are fewer peaks and valleys of activity. You avoid what can happen with inhalation, where there's a rapid increase in blood and brain levels that is going to make a person prone to psychoactive side effects, specifically anxiety, paranoia, things of this sort that are much less likely with a slow titration, slow raising of dose with an oral agent. And therefore, the risks of intoxication, reinforcement, withdrawal, and all these other effects can be minimized. Again, the ingredients are key. People need to know, and that can only come through regulation, because it is a situation, I can say without a lot of fear of contradiction, that companies are not going to produce lab results unless it's mandated.
Yeah.
No, it's all about the bottom line. And if something isn't required, companies are not going to spend the money. But there's a happy balance there. It has to come on the side of safety.
So it's clear that the first step of minimizing risk is to ensure you find clean, high-quality products. But what comes next? Many people already understand that it can be a very uncomfortable and unpleasant experience if you take too much cannabis. So what can people do to avoid this? I spoke with Dr. Jason Miller about the issue. Jason is a doctor of acupuncture and Chinese medicine that's also an expert regarding the clinical use of medicinal plants. Recently, he started having a lot of his patients come to him to ask about cannabis, so he began taking note of what their experiences and their outcomes were in order to be prepared to counsel others on the potential pitfalls and the promises of cannabis use. The first goal, he noted, was to develop strategies to avoid taking too much in the first place.
We need to have some safety nets in case you fall into that sort of pitfall, that pit. And also, like you said, how do we avoid getting there? And I think the most important thing about that is looking at the endocannabinoid receptor system, right? And the way that it's tuned in each person's body, and how it's a system that builds a relationship to cannabinoids, whether they're endogenous or if they're coming from, the plant, from exogenous. And so always starting with a small amount of a THC rich, cannabis extract is a really good way to go. And, if you want to start with something small, I would say something like 1 milligram or less as a dose. It's a really great small place to start. That's where, if people have a known history of cannabis use and they have a relationship with it, that's one thing. You can start them with more than that. But for some people who just have never experienced it, a lot of people are really interested and they want to experience it. One thing I've found with medicine in general is that if someone has an overdose experience where they take too much of anything and they get sick from it, they don't ever want to take that thing again. And it may still be a really beneficial medicine for them. And so I'd rather start slow, take our time, and build to the right dose rather than risk having that initial, bad negative experience.
All right. So let's say you've done your best to find your minimum effective dose and you still went too far, and now you're in the middle of an uncomfortable cannabis experience. What can be done?
Well, there's some real simple things. Even some of the older ideas, just like drinking a cup of warm milk or just a couple ounces of warm milk, is a real simple calming thing for the mind. But there's a lot of other things that we think of that have a history of use. Citrus, and really this, the citrus essential oils, whether it be tangerine, and then of course things like black pepper, which you and I've talked about a bit, and the rich source of beta caryophyllene, right? And that's another compound like limonene that shows up in cannabis itself as as a modulator of the THC effect on the brain, right? And
now we know that beta caryophyllene interacts with CB2 receptors and is affecting the endocannabinoid system in pretty direct ways, even though we still don't quite understand exactly what's going on there. And then also in black pepper, there is, some pinene and stuff too that would also kind of play into that. And kind of going back to the warm milk thing, trying to calm the system down.
Right.
I know that pinene can kind of modulate acetylcholine levels and that sort of thing.
That's interesting because a lot of the compounds that have been shown to calm a THC overdose effect, like a paranoia, kind of heart rate increase, like you said, some sweats, that calming that down has been associated with these compounds, like we're talking about pinene and limonene. And I think all of them have this other aspect where they actually act as cholinergics, where they support the acetylcholine transmission in the brain. So they kind of support smooth neurological flow.
In case you don't know, acetylcholine is a neurotransmitter in our brains that, among many things, is responsible for influencing things like sleep, arousal, memory, and attention.
And then they also, in doing that, one of the ways they do that, I should say, is that they block the acetylcholinesterase enzyme. And that's the enzyme that, naturally breaks down the acetylcholine once it's been in the synapse. It's already kind of been, the message has been sent and received. Then it needs to be, we need to stop sending the message. So that's what that enzyme does. But if that enzyme's overactive, which it happens in a lot of people, especially in aging, and it's associated with, dementia, the Lewy bodies, you get into Alzheimer's disease, that these are all associated with somehow a breakdown in that acetylcholine transmission, and that acetylcholinesterase enzyme becomes overactive. It's also, an oxidative and inflammatory process. There's a lot of drivers, right, to this sort of error in enzymatic activity. And these compounds, the limonene, the pinene, the caryophyllene, they all have data now showing that they actually inhibit, peroxide-induced cell death in neurons. They actually protect neurons, and some of them actually block the acetylcholinesterase activity, preserving the acetylcholine. So there's something, a real deep neurological link there to, what's happening as far as like the healing properties of the brain and sort of cell transmission, and how these terpenes have a really positive effect.
What are some other medicinal plants that would have that kind of calming effect on the body, or would, support acetylcholine and that sort of thing? What are some other herbs you'd recommend?
Well, one of my favorites is passiflora, passion flower, right? And that's passion flower is a wonderful, just central nervous system calming agent that also works really well with the THC overdose. It's sort of like calms the central nervous system, calms the heart, kind of softens the mind and that kind of overthinking, and sort of reduces the monkey mind effect. It's really good like that. And then probably the chief herb, and I mean, it has been used and could be used alone, is sweet flag, or Corius calamus. It's really like a traditional Chinese and also an Ayurvedic herb used for a long time for cognition. And also it's been used in flavorings now, and there's all kinds of different compounds in it. And
that's a root, right?
Yeah, the calamus root, exactly.
Root,
that sweet flag plant, and then you've got this root, and then the root is dried, and then it's extracted into an ethanol. Most of the time nowadays, it's an ethanol extraction. That then you get this really nice blend of terpenes and flavonoids that are really powerful in this plant. And one of them is the acerones, right? Alpha and beta acerone, that both have strong activity in protecting the brain from neuronal cell death. But the beta acerone particularly does a really nice job of calming that THC-induced overdose, and that overdose effect of all the kind of neurological hyperexcitability that starts happening. And it just calms it down. I mean, even if you just had one thing, if you could only have one thing, I would definitely choose a Corius calamus. And I wish I could go back to those couple of experiences I've had, where I had too much THC, and have a bottle of a Corius calamus there and say, oh, I'll just take a couple droppers of this tincture, because I have given this to, I don't know how many patients. And I've even, some of the local dispensaries now have been buying this material from me at regular intervals to pass on to their patients, because, in the event that people are like, hey, I really want to get going on this THC regimen for whatever condition, and I'm a little bit worried because I'm sensitive. Well, then you say, okay, great. Well, you can go ahead and start increasing your dose a little faster. And if you hit that point where you've gone over, if you use a combination of a Corius and some other herbs, or like I said, even if you just had the Corius, it would really help to bring it down. And I've tested this out, a number of people, and it's been very successful.
Are there any like health risks or anything like that with calamus that people should be aware of? Is it something that they can use just kind of at will, or do they need to kind of watch their intake or anything like that?
Well, you bring up a good point, and again, this is not an herb that's meant for long-term chronic ingestion. These kind of high potency terpenes and things, like there's different species and different like variants of the plant, where they, like the tetraploidy varieties that come from parts of India, have very high concentrations of beta acerone. Like some of the essential oils have like 75% beta acerone. And at that concentration, you're getting to this kind of like, essential oil terpene substance that has a very strong aromatic quality, and we don't want to take that in all the time. It could eventually overwhelm our ability to kind of quench its own oxidative properties, and then we could get some damage, whether it be liver damage or other things. So we don't really know, but there have been associated toxicity studies done on some of these compounds, and a lot of compounds. You just look at, if you took it too much over too long of a time, it could be a problem. But in the short term, where you're just taking it for a THC overdose, there's no risk at all. On a single dose, no way. It's just if you ended up taking high doses long term, I wouldn't advise that at all.
Yeah. So you're telling me I shouldn't start smoking bowls all the time and just following it up with calamus every day?
Well, you bring up a really good point, because, it's kind of that thing where, gosh, I got to go to work, but I'd really love to get stoned. I could imagine people, just like smoke a big bong load or two and get really high for 15 minutes and then be like, oh, I got to work. So take a big load of calamus and then go to work. Right.
Right.
I'm not advising that approach.
Yeah.
Definitely not. And I think there's a lot to that, to what you're saying about, using it in a very, just a very specific manner, where you're using it as a medicine to help people who are building a medicinal regimen out of THC be able to control the potential for overdose and give them some security, that they could be assured that if they get to that dreadful headful kind of place, that we can calm it down. I was going to say too, one thing I thought of was, with that kind of warm milk is the cardamom, cardamom in warm milk is another one, the Elateria. There's a lot of great compounds in there too that have been associated with calming that sort of THC overdose effect.
And if you forget all of those suggestions, there are some products on the market now that claim to combat cannabis intoxication.
I do have a product that's out of Arizona. It's called Undo, UNDOO.
Oh, yeah. Yeah, I've heard of that.
They're wonderful.
That's Peggy Anderson, the founder of a company called Can I Help You, which is dedicated to providing seniors with education about cannabis. In one recent study, it was found that the demographic of cannabis users over the age of 65 is growing faster than any other demographic of older adults. Many of these users don't want to be intoxicated and are particularly concerned about taking too much THC. Peggy shared some of her experience with this issue.
And if you smoke or vape and you take one Undo with 22 ounces, 24 ounces of water, you'll come down after 10 minutes. And I have tried that product, and it does really work. And with edibles, it takes 30 minutes. But I've had two people that love that THC chocolate, and next thing you know, they've got 50 milligrams in them. And, too much. But that's a good product. And again, I think I just have to reassure them that they're not going to die. Might be uncomfortable for a while, and if they are, I always give them my number, and I kind of debating right now offering the service of sitting with somebody for the first 2 hours. Just to be there with them, and so that they're not scared, and the anxiety does go up, which we're trying to go down. Yeah.
Is there any advice that you give to seniors that if they've gone too far, they're having an uncomfortable experience, they don't have access to Undo or a product like that? Are there other things that they can do to try to calm that anxiety, that paranoia down, or try to get some relief from that uncomfortable experience?
Yeah, a lot of water.
Yeah.
As much water as you can handle, and then I call it distraction. Put something on television that's just going to take your mind off of what you're doing. That's what I did with this woman who ended up in the emergency room, but she, her daughter took her because she was out of control. But, and again, that was a weird thing. This was about 2 years ago, where she had some taffy, and she had a quarter of it, and she did fine. She slept well, and she got to that last quarter, and that's where all the THC was. So
Interesting.
that was early in the day.
Yeah, it wasn't a very uniform product.
Right. Not 2 years ago, for sure.
Also, CBD is known to reduce the effects of THC to some extent by changing the way that THC actually binds to cannabinoid receptors. So that's another option available. All right, let's review what we've learned so far across these past 3 episodes. While the exact level of toxicity of cannabinoids is unclear, we know that cannabinoids are orders of magnitude less toxic than caffeine or nicotine, and it's physically impossible to lethally overdose on herbal cannabis. As far as extracts and concentrates are concerned, there's still a lot of unknowns. There's no long-term safety data available yet to understand how chronic consumption of cannabis concentrates might affect health. However, we do know that a variety of contaminants in cannabis can become concentrated in extracts, presenting greater risk to consumers, particularly those that have pre-existing health issues. Although cannabis is unlikely to present the risk of a lethal overdose, there are still health risks to users, including risks to lung health, heart health, mouth health, immune system health, and mental health. Many of these health risks stem from smoking and can be minimized or eliminated altogether by using other consumption methods, like vaporizing. I'm not really talking about vape pens here, I'm talking about true low-temperature vaporizing, or using edibles or sublingual products like tinctures under the tongue. Naive users are at greater risk for experiencing the psychological adverse effects than experienced users are, so it's best to start with a low dose and take it slow. Cannabis can potentially interact with other medications. Usually this leads to sedation, but in some cases, particularly with CBD, cannabis could slow down the body's ability to metabolize drugs, resulting in elevated concentrations of those drugs in the blood. For anyone taking medications with narrow safety windows, or if your medications have a grapefruit warning on them, this could potentially be dangerous and you should seek medical oversight when using cannabis. Some people with pre-existing health conditions could be at greater risk to suffer adverse events from cannabis use. If you're using cannabis and have a heart condition, compromised immune system, diabetes, or mental health conditions, it's really best to work with a healthcare professional to make sure you stay safe. Cannabis use in adolescence can exacerbate underlying mental health issues. In general, it's best for young people to wait as long as possible before trying cannabis, ideally until the age of 25, as this is the age when the brain is thought to have reached most of its maturity and when most mental health issues will reveal themselves. If you do decide to use cannabis, start with a low dose and slowly work your way up. If you end up getting too high, there are a number of home remedies to counteract the effects of THC, including things like drinking water or drinking warm milk, eating peppercorns or black pepper, taking tinctures of other medicinal plants like passion flower or calamus root, chewing on pine nuts, or even drinking lemonade. There are even some targeted cannabis antidotes now on the market. Additionally, CBD can also counteract the effects of THC to some extent. Finally, if you consume cannabis regularly, it's important to perform regular abstinence breaks and wellness audits to evaluate your relationship with cannabis to ensure that your cannabis use is not negatively impacting your health. So, is cannabis safe?
I would say in regulated states in general, I feel pretty confident that most products you get are safe in the sense that they're, probably don't have pesticides and solvents. They probably are fairly consistent in their dose.
Well, the other thing is, in the 70s and 60s, you didn't know what you were getting. And I reassure my seniors that I'm talking to that this is safer than it's ever been before.
It's generally well known that nearly anything can be toxic when consumed in a particular way or in a particular dose. Going back to the early days of toxicology in the early 1500s, the Swiss physician, alchemist, and astrologer Paracelsus said, "All things are poison, and nothing is without poison. It is the dose alone that makes a thing not a poison." Today, this is often simplified to the saying, "the dose makes the poison." This applies to everything, including the water we drink and the air we breathe. Nothing in life is without risk. But in general, cannabis is safer physiologically than many substances we engage every day, like coffee and some of our foods. While there are some rare exceptions and contraindications to be aware of, cannabis, as long as it's clean, seems to be pretty safe and well tolerated by most people, especially at low doses. Deaths attributed to cannabis are extremely rare, and most adverse events that could arise from cannabis use, like hyperemesis syndrome, are usually reversible. Now, if you want to minimize risk, in general, you want to wait as long as possible before you decide to try cannabis for the first time, ideally once you get past that age of between 22 to 25 years old. You want to try to avoid smoking because a lot of these health risks we've covered are a result of smoking more so than cannabis itself. You want to only use cannabis of a known quality, and you want to start with a low dose and slowly work your way up to find your minimum effective dose. And remember, if you do take too much THC and are having an uncomfortable experience, there are a variety of things you can do to help ease that uncomfortable feeling, and most importantly, the feeling will eventually pass, and you'll be fine. I know that some of you listening might be wondering about the issues of substance abuse and addiction as risks, which I specifically didn't really cover in these episodes. Well, don't worry, there's going to be an episode dedicated to that issue, as well as issues like pediatric cannabis use and cannabis use while pregnant or breastfeeding. So stay tuned as we revisit the issue of cannabis safety in other episodes throughout this and future seasons. In 2015, the Journal of the American Medical Association published a review acknowledging a list of therapeutic applications of cannabis, while also expressing skepticism over others. Then the National Academy of Sciences released a lengthy 400-plus page review, also identifying clear therapeutic applications of cannabis and its constituents.
The National Academies of Sciences, Engineering, and Medicine published the results yesterday. Panel looked at medical and recreational use and examined more than 10,000 studies.
Well, in terms of treatment, there's pretty solid evidence that can be helpful in alleviating chronic pain in adults, nausea from chemotherapy, and then spasticity or muscle spasm in people with multiple sclerosis. They also looked at a whole bunch of other things where there wasn't quite adequate research. They said we need more research for things like epilepsy, PTSD, even anxiety.
Were you surprised that there are some clear health benefits from marijuana?
Not at all.
I have to point out here that when we talk about the medical use of cannabis, we aren't just talking about smoking cannabis. And I know that when a lot of people hear the idea of the medical use of cannabis, they think about people smoking. But there are a lot of ways to consume cannabis, and each consumption method affects the body differently. Sure, cannabis can be smoked or vaporized, but it can also be eaten in the form of cannabis-infused foods, or taken sublingually by taking drops of a cannabis tincture under the tongue. Cannabis can also be administered on the skin topically, or less commonly, cannabis can also even be taken as a suppository. Now, anything consumed orally, by the mouth, will take longer to take effect, because it has to pass through the digestive system, and it undergoes a process called first-pass metabolism before the cannabinoids are passed into the bloodstream. During this metabolic process, cannabinoids are chemically altered. For instance, when THC is ingested orally, nearly half of that THC is metabolized to a compound called 11-OH-THC, which is considered nearly 4 times as strong as THC. This is why the experience of eating cannabis products can sometimes be really unique, and sometimes a lot more powerful than consuming cannabis by other means. However, when cannabis is smoked or vaped, or when someone uses a sublingual product or suppositories, cannabinoids actually bypass the liver and pass straight into the blood. And this leads to a much faster onset and avoids the chemical alteration that can happen during metabolism. So it seems among the scientific and medical communities, there's no doubt that in some contexts, cannabis can be a medicine. But to what extent? And for what conditions? At what dosages? And in what form? That's where much of the debate currently resides. According to the United States government, at the time of this recording in 2019, cannabis and its cannabinoid constituents are classified as Schedule I drugs, a classification reserved for drugs that are presumed to have no medical value and a high propensity for abuse. Other drugs that are classified as Schedule I drugs include things like heroin and bath salts. And to put this into even better perspective, drugs like cocaine and methamphetamine, which are Schedule II drugs, are less controlled than cannabis. Despite the U.S. government's determination that cannabis should be a Schedule I drug, and as such has no medical value, the government actually held a patent on the antioxidant and neuroprotective properties of cannabinoids up until this year. And to many, this patent represents some deep hypocrisy. Regardless of the legal status of cannabis, there are many people across the U.S. that have jumped on the cannabis bandwagon, touting benefits so profound and diverse that it can't help but sound like a pitch for the next snake oil. Browsing through Instagram or Facebook, it's so easy to get barraged by meme after meme about the different promises of cannabis and the ills of Big Pharma. So what's the truth here? Well, to start, let's explore the ways cannabis has been used as a medicine throughout history. Then we can look at some of the more modern cannabis research and see how some of these traditional uses hold up against modern science. Cannabis has been used by humans for a long time. We're talking thousands of years. I mean, really, we're talking like 5,000 years. Half of a decamillennium. If decamillennium is even a phrase. If not, it is now.
Well, cannabis is, of course, shrouded in all this, prohibition and a lot of political, struggle and
a lot of different energies surrounding it.
It's gotten into a darker place, even like just sort of the information we have about it.
That's Dr. Jason Miller, a medicinal plant and Chinese medicine expert that's been noticing that more and more of his patients are starting to talk about cannabis.
I like to start always when I'm looking at what is the benefit of a plant or what are the weaknesses of it or the potential, dangers of it. I want to see what is the record of that plant look like across traditional cultures. Again, it's not like, people talk about, oh, it's woo-woo, it's folk medicine. Whether you call it that or not, those people were carrying oral traditions and written traditions about medicines to help their people that they cared a lot about. They didn't have time to sit around and go to the movies. No, they were living, and life was a struggle for a lot of people, and medicine was really important. So there's a lot of heart in it. There's a lot of intention in it, and there's a lot of empiricism. So I always go there first. And what I've done with cannabis, in my kind of digging into what is cannabis as a medicine, I've had to cut through that same kind of shrouding and sort of darkness of like, what really is it? When looking back at what are the records from Chinese medicine and the use of cannabis, and I've looked deeply into it and tried to find what are the threads. Because most of the time in school, in medical school, with Chinese medicine and the doctors from China stuff, it's just kind of we don't talk about it. You know, of course, the hemp seed. Everybody knows that's
nutritional.
And it's generally there's a couple of great formulas that use ma zi ren, and ma is the word in Chinese for hemp or cannabis, right? For marijuana. And so ma zi is a seed, and so you got ma zi is the seed of the cannabis plant, right? And so that seed has been used really successfully for moistening up the bowels and helping with constipation. And you combine it with other herbs that have other, peristaltic actions, or, pull some fluids into the large intestine, and then like, mirabilitum, things like that. And then those will all work to kind of create this bowel. But beyond that, you start digging into what was actually cannabis used for as a medicine. And was it cannabis in the sense of, THC rich, or was it cannabis in the sense of hemp? Was it ragweed? It's really hard to determine that from the records that we do have, but there is some consistency across the writings I've examined in using cannabis for conditions that involve, something in Chinese medicine called wind, which I've talked about with you before, which is like the idea that there's an instability in the body. So there's a homeostatic stabilizing kind of effect from cannabis, where, it's instability in the mood. There's things like tics and twitches and tremors and dyskinesias and things of that nature that cannabis was really good for, that it's been recorded that people would use it for that. And again, it's hard to understand, were they using CBD at that time?
Right.
Or was it a strain that was blended? And we don't really know. The records are hard to follow. But clearly it was used for problems of the mind, people having anxiety, schizophrenia, people that had, mental instabilities. It would really help to bring back some balance to them. And, one of the things that I saw that people used was they made a cannabis wine, and it was made, so they would take it was like more like a cannabis wine extraction, I guess, but they would take their rice or sorghum wine that they would make, right? They'd ferment those grain, the grain, and create, an ethanol rich solution. And of course we know that, ethanol is a great way to extract cannabinoids, right? And so they would take the seeds with the coating on the seed, what do you call that? It's not the calyx, but it's actually, there's a coating around the seed as it, sits on the plant. And that coating is covered in little hairs, right? Little trichomes. Right. So it's got a lot of cannabinoid on it. But so they would put the seeds with those little trichomes into their solution, and they'd extract it, and they'd give it as this cannabis wine, and they'd give it to patients for different conditions. So it's clearly been used that way, and it has it's very safe medicine. But I think that part of the problem is just that we have a hard time understanding with this plant the differences in its phenotypes, in the different types or cultivars of cannabis, which is one of the things that makes the plant really unique. You can get a very different physiological effect from one strain, right, than another. And that's, and there, to some degree, some plants have that, but very few, and to that degree. And I think it's one of the things that makes cannabis unique and fascinating to me, is just that, God, there's so much. And we talk about, what does cannabis do? I'm like, well,
man, yeah.
Which part of cannabis? Which cannabis are you talking about?
Yeah, how are you using it? Yeah. In Chapter 2 of the book, The Handbook of Cannabis, Dr. Ethan Rousseau, a neurologist and cannabinoid researcher that's been studying cannabis for well over 25 years, summarizes some of the ways in which cannabis was used therapeutically throughout the last several millennia. Here's an extremely condensed version of what he presented. Oral traditions of cannabis use for things like appetite stimulation and fighting the effects of old age date back to nearly 3,000 years BCE. That's 5,000 years ago. In 1500 BCE, the Atharva Veda indicates that Indians were using cannabis for anxiety relief. Cannabis is suspected to even be a component of the holy anointing oil of the Hebrews as far back as 750 BCE. The juice of the leaves was noted to be a remedy for earaches in the 1st century, and in the 2nd century, Chinese records indicate that cannabis was used in wine as an anesthetic. In the early 10th century, Persian records indicate it was even used to stimulate hair growth. In 1542, it was noted that cannabis roots could be boiled and used to treat gout and burns. And throughout the 16th century, records indicate that cannabis was used for things like sore muscles, stiff joints, burns, wounds, even jaundice, colic, and tumors. In 1839, a researcher named O'Shaughnessy studied Indian use of cannabis and performed experiments in dogs and then later people to determine if cannabis was a suitable treatment for things like tetanus, rabies, epilepsy, and even rheumatoid disease. Now, O'Shaughnessy is a particularly interesting figure in the history of medical cannabis, and we're going to be learning a lot more about his work in future episodes. Shortly after O'Shaughnessy published his findings, cannabis began showing up in the European and United States pharmacopoeias. As records become more easily obtainable, we can find records throughout the 18th and 19th centuries of cannabis being used to treat things like migraines, pain, spasticity, anxiety, depression, and insomnia. Cannabis was even featured in the U.S. Pharmacopoeia as a medicine until the 12th edition, when it was released in 1942, well after the marijuana prohibition had begun in 1937. You can still look up old issues of the USP and look for entries for extractum cannabis or tinctura cannabis. It may also be listed as extract of hemp or tincture of hemp. And upon the initial publication of cannabis in the USP in 1851, the 9th edition of the U.S. Dispensatory had this to say about the medical use of cannabis. Quote, "It's been found to cause sleep, to allay spasm, to compose nervous disquietude, and to relieve pain. The complaints in which it has been specially recommended are neuralgia, gout, rheumatism, tetanus, hydrophobia, epidemic cholera, convulsions, chorea, mental depression, delirium tremens, insanity, and uterine hemorrhage." After cannabis prohibition began, cannabis became unavailable as a medicine, and research into the plant progressively slowed down into the late 1950s. Modern medical research into cannabis really started to take off again in the 1960s when THC was isolated and synthesized. A little known fact, but CBD was actually isolated and characterized approximately 20 years prior to when THC was isolated. But because CBD doesn't elicit an intoxicating effect, it went largely ignored at first. More recently, the FDA just also approved a CBD-based drug called Epidiolex for the treatment of drug-resistant epilepsy in children. As THC research progressed throughout the 1960s and the 1970s, research confirmed that THC could reduce nausea and vomiting associated with cancer chemotherapy, that THC had the same analgesic effect as codeine, and that THC performed as well as the anti-asthma drug salbutamol, aka albuterol or Venlafaxine, as a bronchodilator. Now, the 1980s ushered in renewed interest in CBD, as well as continued research in THC. In 1981, CBD was identified as an anticonvulsant. A year later, it would be found that CBD could help relieve the anxiety brought on by THC. In 1985, the unique flavonoid canflavin A was discovered, and this really broke cannabis research away from the cannabinoid chemical class to encompass other types of plant compounds. It was also in 1985 that the pharmaceutical drug Marinol was approved by the FDA for chemotherapy-related nausea.
In 1985, synthetic THC as Marinol was approved by the FDA.
That's Ethan Rousseau, and he's had a little bit of experience with cannabinoid pharmaceuticals.
The thought among certain people at the time was this would obviate the need for cannabis treatment for medical conditions. Instead, what we got was a drug that is very poorly tolerated and gained no traction in the marketplace. THC by itself is a very disorienting drug. People tend to be dysphoric, unhappy, rather than euphoric. Even people who are accustomed to cannabis find THC in pure form a very difficult drug to tolerate, and very few people remain on it for any length of time. And when people have had the opportunity to compare, almost invariably they prefer herbal forms of cannabis.
In 1988, scientists finally discovered a chemical receptor in the body that seemed to be responsible for most of THC's effects, the cannabinoid type 1 receptor, or, as we call it now, the CB1 receptor. This marks the beginning of piecing together a fascinating puzzle about a physiological system that had since been ignored, the endocannabinoid system, which wouldn't really be formally named for another 10 years. But we'll get into that story in another episode. In 1993, CBD's anti-anxiety effects that had been previously noted in the 1980s were again confirmed. And in 1997, it was found that THC could help reduce agitation in patients with dementia. In 2003, clinical trials of the cannabis-based pharmaceutical Sativex began, investigating whether it could be an effective treatment for multiple sclerosis symptoms. In 2005, Sativex would go on to be approved in Canada for the treatment of MS-related pain. Over the years, Sativex would later be approved for other types of pain, such as neuropathic pain and cancer pain. Eventually, Sativex would be approved in the UK and Spain for spasticity in MS patients. In 2010, it would be discovered that Sativex can also treat nausea related to chemotherapy treatments. One problem with our current approach to medicine, at least in the United States, might be that it tends to favor isolated or limited ingredient formulations over things like botanical extracts that would contain a high diversity of compounds. People want to know what herbal cannabis and cannabis extracts may or may not treat, not what THC or CBD alone may treat. In fact, time and time again, research is indicating that cannabis extracts with a broader diversity of chemicals from the cannabis plant actually tend to perform better than isolated cannabinoids like THC or CBD. A lot more research is needed to understand the nuanced differences in the therapeutic activity of isolated cannabinoids versus herbal cannabis or cannabis extract, but there certainly seems to be major differences.
One of the big issues right now is trying to sort out whether people should have single compounds, like single cannabinoids, versus whole plant extracts. And I'm clearly in the latter camp for the synergy, the boosting effect that these provide over and above the kinds of effects that we can get with single compounds. We have now a lot of evidence, both laboratory and clinical, that much better results accrue when we're dealing with complex mixtures from cannabis extracts as opposed to pure compounds. A recent illustration was an article from Spain, Blasco Benitez et al., in which they were looking at effects on cancer, both in cell culture and in animals, comparing pure THC, which worked to some extent in treating the cancers, But in comparison to a cannabis extract, there was much, much greater activity with very salient, statistically significant differences. Another good example there was a paper by Pamplona in 2018 that compared pure CBD, as would be in Epidiolex, to the results that people got with CBD predominant cannabis extracts. What they found was equal efficacy, but with the cannabis extracts, the doses were about, on average, 22% of what was required with pure CBD. So instead of 1,500 milligrams a day, perhaps 300 milligrams would be enough of the corresponding extract. So this can represent a substantial savings in cost. Additionally, with the high doses of pure CBD, there is the possibility of drug-drug interaction, particularly sedation with some of the drugs that are used in epilepsy treatment.
Over and over, healthcare professionals I spoke with commented on the superior efficacy of broader spectrum cannabis products over isolated cannabinoids.
We've seen that, and it was interesting when we first started out. We thought half of our patients didn't want THC in their products, so we gave them a CO2 extracted, just CBD, and the others did want a little THC.
This is Dr. James Taylor, a pain physician working in North Carolina. Ever since hemp became federally legal in the United States, he's been working with his patients to understand how hemp extracts, and CBD particularly, might be a tool to help treat chronic pain.
And what we found is, once again, in the waiting room, the people who were trying the CBD products, the ones that had a little bit of THC and had a full spectrum, were having profound results. Those that were on the isolate weren't having such profound results. So it was in the waiting room that the patients were talking. So when they came back to the office visit, they said, hey, I don't want to take the CBD I'm taking. I want to take the one they're taking. And so it was the patients that were coming back telling us that this full spectrum was superior over an isolate. So I'm assuming, these large doses that folks need with the Epidiolex and the CBD isolates is because it's just inferior. It's an inferior product, and you can take much less if you're taking a full spectrum product.
This difference in therapeutic outcome between isolated compounds from cannabis and the use of herbal cannabis or broad spectrum or full spectrum cannabis extracts is attributed to something often called the entourage effect.
I think the best depiction of this idea of the entourage effect, or what we have called for probably longer synergy in medicinal plants, is a symphonic effect.
That's Kevin Spellman, a molecular biologist and phytochemist that's dedicated his entire professional career to trying to understand why plants affect the body the way they do. And lately, he's had his eyes on cannabis.
So think about a Mozart symphony that's so incredibly beautiful, and you have a lead violin, and then you have all these other instruments, right? And all those other instruments basically support that lead violin. Now, what's happened in pharmacology is, under the illusion, and I will call it an illusion, that we can control the dose, we've isolated the lead violin and just used that in our pharmacology. And the rationalization for this is actually, if you really go back and look at the science, the rationalization for doing this is actually not very strong scientifically. In the 30s, in the early 20th century, 20s, you had the eclectic physicians doing studies on whole plant extracts, and then in some cases they actually used an isolated constituent. And this is the Lloyd brothers. The eclectic physicians were supported by some brilliant pharmacists called the Lloyd brothers. And the Lloyd brothers were really good at extracting. In fact, some of their instrumentation, their chemical instruments are still used today. They invented them to do extractions, and we still use them today in chemistry labs. So they had this opportunity to look at whole plant extracts versus isolated constituents. And they found in many cases, not always, but they found in many cases that the whole plant extracts were had a better outcome Now, and I think that's really what we have to look at, because in an isolated model, for example, a cell culture in an animal model, you actually might get a better outcome with an isolated constituent.
Right.
Because you're pounding, essentially it's pharmacological dosing versus physiological dosing, right? So in physiological dosing being that idea of using just enough to get the effect you're looking for.
Minimum effective dose.
Exactly. And what we end up seeing with this in healthcare is that everybody's too busy to do that. The patient's too busy to pay attention, because they're going to have to pay attention to where they get the effect. The doctor's too busy to actually put an inquiry into where was that dose that worked for you. And everybody wants instant relief. So it's fallen by the wayside. But were we to pursue that further, I think we'd have a much more effective model. The other thing that happens here when we look at isolates versus whole plant extracts is the adverse event profile goes up. And this is a huge issue. And for example, in my own body, if I take ginkgo 24/6, the standardized stuff, I actually end up with a huge diuretic effect. I'm running to the bathroom every 20 minutes. If I just use ginkgo leaf that's thrown in a capsule, I don't have that effect.
Yeah.
I notice the blood flow effect in terms of cognitive function with both of them, but I'd rather use the whole leaf ground up. So we have that lead violin that's working. And what we found in reductionist chemistry now is that, there's more than one lead violin. Turns out that the oboe takes a lead in this section as well, right? And it turns out that the cello also ends up having a lead in the. So we have found multiple active constituents. In the case of echinacea, it's been hypothesized that at least 4 now compounds are considered the actives. When they came across the CB2 binding of alkylamides, what happened is everybody thought, we've finally done it. We have found the active in echinacea. Well, not so fast, because we've got the caffeic acid derivatives, which, by the way, are directly antiviral, but incredible antioxidants and potentially block histamine release. By the way, if you're looking at anaphylactic reactions and you're stuck in a pinch. We've also got the polysaccharides, the rabinogalactans in echinacea that are also super active and directly stimulate immune function. So that becomes very interesting, because here in one plant you've got something that's a bit of a immuno dampening effect, the alkylamides, and you've also got something that's a direct immune stimulator, that's the rabinogalactans, and then you've got something that tends to modulate immune function, that's a caffeic acid derivatives. And by the way, it's antiviral. So we can't simplify plants to one constituent, and that's the mistake that's being made over and over and over. It started in the 70s with ginseng. People were looking at ginseng and saying, what's the active constituent? And they came upon the ginsenosides, or the saponins of the plant. And so what happened from this ridiculous research in the 70s is there was a time when people would look at plants, and if they didn't have alkaloids or they didn't have saponins, they were thrown out. No, they're not active. It's all fantasy. No, these tribes using this are not getting any effect. We know best.
Right. We've studied it.
Exactly. So I could talk about this all day. I've written a couple of chapters on it in books, and published a couple of papers on synergy. But the idea that there's only one active compound is really naive. There is this bias in science against medicinal plants, as if it's not real. And we need to stop and realize that about half of all of our drugs have been based on medicinal plants, and about 25% of all of our pharmacopoeia is still directly isolated from medicinal plants. If you look at cancer drugs, something like 70% of them in the last 10 years have come from natural products in some sort of way. So when physicians and healthcare providers look at me as, with a disapproving look that I'm into medicinal plants, they don't understand their own pharmacopoeia that they're writing from daily.
There are a lot of medical claims swirling around cannabis. If you go into just about any cannabis dispensary, you're likely to see posters on the wall indicating the myriad of different chemicals in cannabis linked with their supposed effects. However, many times these kinds of charts are built off of very simple preclinical research data that may not really have any relevance in a real-life cannabis use scenario. So how are medical claims derived about cannabis? Well, there are several different forms of medical research that are considered to have varying degrees of quality. On one end of the spectrum, there are anecdotal reports, and these are basically eyewitness testimonies from a single person or maybe a small group of people. And, in these situations, there are no controlled variables. This is just simply someone reporting what they experienced, what they saw, what they felt, and that sort of thing. Up from that, you have case studies, usually written by a professional describing an incident in detail and giving their professional opinion. Moving along, there are observational studies where a healthcare professional might watch a patient engage in an activity and then record the outcomes. Now, on the other far end of the spectrum is the gold standard of the randomized controlled trial. Now, before a drug ever sees a randomized clinical trial, typically when that drug's being developed, the first way it's studied is through something called in vitro research. In vitro studies are laboratory studies performed in test tubes or petri dishes. In vitro literally means in glass.
Basically, yeah. I mean, when you're studying, like when you're doing drug development, you tend to look for a certain kind of activity that the drug is like. Well, let's just take THC as an example.
This is Justin Fischetic. Justin is a natural products researcher that studies the activity of the chemical constituents of plants, including cannabis.
THC interacts with the cannabinoid 1 receptor, which is mostly in your brain, and it also interacts with the cannabinoid 2 receptor, which is in the peripheral nervous system, as well as like immune cells. And there's more to it than that, but so like if you're looking for a compound that interacts with CB1 receptor, you would start with mostly probably an in vitro assay. So that just basically means you have some kind of test tube that you have some kind of, you can put the receptor on a certain type of cell, or there's all kinds of different ways of doing in vitro experiments, but generally you're looking for some kind of specific biological activity. So you either have a receptor in a tube and you can measure various ways of how compounds interact with it. Do they interact with it strongly? Do they interact with it mildly or at all? And this also applies to cell, like if you're looking for an anti-cancer drug, you would normally start by growing cancer cells in like a petri dish and then applying different compounds to it and seeing if they kill them. And, that's a big, that's usually the starting point of a lot of this stuff. Or you have some plant that you already know has medicinal properties for like historical reasons, and then you go try to figure out why. But yeah, so, that's in vitro means like in a test tube, basically.
Then moving on from in vitro studies, there are in vivo studies, which are studies in living animals.
And then as you move into an in vivo system, that would be in like a test organism, so a mouse or eventually a person if it's clinical drug development.
But there are limitations to each of these types of studies, and the results of an in vitro study or even an in vivo animal study cannot always be easily extrapolated to real-life human clinical situations.
A lot of times you see people like quoting things about different cannabinoids, different terpenes from kind of very basic in vitro kind of research, like, oh, this terpene has anti-inflammatory properties in this assay. And then they just quote it as if that means they have anti-inflammatory properties in general. And you can't, there's a reason drug development takes a long time and it's complicated, because you usually start with these very simple systems and move into much more complicated systems, like a person versus one cell or one receptor.
I had a conversation with cellular and molecular biologist Dr. Anthony Smith about this issue regarding the limitations of interpreting in vitro studies.
A lot of science papers are either built on or in some cases supported by what we call cell culture research. And so cultured cells, what I mean by that is that, we can get bits of tissue from different animals, humans included, and essentially break them apart from their tissue mass and grow them in flat-bottomed bottles with synthetic blood, if you will. And so there's all kinds of different mammalian cell lines that we call them that are, used for all sorts of research that relate to drugs, disease, environmental control, detoxification, etc. And these are very important models. But I think when you see research, if it's built on or even supported by cell culture experiments, keep that in mind. If it's important enough, a study will use several different cell line types and look for, some theme in whatever metabolism they're looking for in those models. Sometimes you'll see clinical work, so like actual, physiology or, clinical outcomes that maybe produce a theory that it relates to a particular tissue and signal. And so they will try to support that hypothesis by testing that signal again in a cell culture model. But the thing about cell culture models is, until you in your research mind or your research repertoire really built up a large library, if you will, of understanding, it's not a good idea, I think, to make lay conclusions that are based on a single observation of a cell culture line.
A lot of cannabis research has, up to a point, been primarily in vitro and in vivo rodent studies. But very few research projects with cannabis have crossed into the world of placebo-controlled, double-blind clinical trials with large patient populations. And many politicians and regulatory bodies continue to claim that because of this lack of clinical trial data with herbal cannabis or cannabis products, that they cannot be deemed safe or a viable medicine for any condition. Now let's break this phrase down, the placebo-controlled, double-blind clinical trial. Now, placebo-controlled refers to the fact that a compound is given to some of the patients in a trial, and this compound is intended to have absolutely no effect. Sometimes this might just be sugar, something like that. In general, it's expected that if something is a candidate to be considered a medicine, it needs to perform better than a placebo. Now, it can be difficult to adequately utilize a placebo in a THC-rich cannabis study. Because THC has such distinct effects, it's pretty difficult to fool people into thinking they got the drug when they actually didn't. Now, this kind of situation is referred to as incomplete blinding, because the patients are not truly blinded to whether they received the drug or not. The gold standard for clinical trials is for a study to be double-blind. Now, the phrase double-blind refers to the idea that both the clinician performing the study and the patients participating in the study are both blind to whether they received the research drug or the placebo. This is important because there are various biases that can enter a study if the physician knows who's had the placebo or not, and likewise, patients may react differently in a study if they know they're receiving a placebo. Although some modern research is actually beginning to call that idea into question and has shown that patients can actually respond really well even if they know that something's a placebo. But we don't have time to get into that today. Next, large sample sizes are required in order to understand whether the results of a clinical trial are actually representative of a much larger population. A study that only examines the response of a couple dozen or even a couple hundred people is considered to be really, really small and can't actually represent the hundreds of millions of people living in the United States, much less the billions of people living in the world. Finally, there's also the issue of repeatability that's worth mentioning here. Even if a research study is placebo-controlled and is double-blinded with a good sample size, it's still really important that that study be replicated by another set of researchers in another location with a different population of people. Research findings are much, much more robust when they've been repeated. When trying to interpret medical research, there's also the issue of deciphering what the studies are trying to measure, how they're measuring it, and whether the significant effects that are identified in a study are actually relevant in a real-life clinical setting. This is the issue of statistical significance versus clinical significance. Statistical significance is a measure of the likelihood that a result is not due to pure chance, whereas clinical significance is a measure of the practical significance of a treatment in a clinical setting. Basically, Just because a research study determines that something exhibits an effect technically, and that effect is statistically significant when compared to chance, it doesn't actually mean that effect's going to end up being significant in any practical sense when someone consumes that product. There's another similar issue also facing drug development and medical research, and that's this battle between efficacy research and effectiveness research.
You know, for me, I feel like I think we're at sort of the end of the research arc of the revolution of sort of efficacy research.
Mhm.
It's still being promoted and pushed because it's a great way to sell a drug. You know,
Right.
if I'll just map, the difference between efficacy research and effectiveness research
Mhm.
is that effectiveness really looks at a therapy or a therapeutic approach.
Clinical significance.
Clinical significance. Like,
Yeah.
was I able to effect a positive change in a patient population using a technique or
Yes, yeah.
a way of formulation or something like that? It doesn't require this efficacy model, which says, is this molecule effective for this condition?
Mhm.
And that's a great way to sell a drug,
Mhm.
and there are cases where we can still really use that, especially
Right,
in cancer. There are some places where targeting a specific, molecular receptor or a pathway can be very powerful in a disease process like cancer that gets out of control really easily. But I want to find out, how is cannabis effective and how is plant medicine effective for different conditions when applied using some principles, like using some basic, approaches to medicine. And so I want to see a divergence in how we prove something's value as a medicine. And I feel like we're stuck in a place where the money and the cash grab is driving us to keep using this archaic model that was really, a model set up in the, 30s and 40s of, to prove out these pharmaceutical medicines and that they were powerful because they were going to direct function.
Right.
We want to be in control.
Mhm.
And in the emergency room, heck yeah, I want to be in control in the emergency room,
Exactly.
Someone comes
It's
in
an acute,
with acute chest pain. Man, let's get them on nitroglycerin. Let's throw, these guys got an ST wave, elevation. We've got, this person's having a cardiac event. We need to get them taken care of. We need some single molecules to block some pathways and keep them alive. Awesome. But where I see cannabis and where I see plant medicine is in day-to-day health. And we don't need to use that model to understand how those things affect our health and disease, And so I don't know how to make that bridge, but I'm pushing for my own work and my own, search for meaning and search for what am I here to do. I want to try to help proliferate a way of approaching medicine, a way of proving that looking at a person's lab work, combining it with looking at their Chinese medicine diagnosis, and then using natural materials, maybe some drugs too if they need them, but whatever, but a combination, but that approach would be effective for patients. And how do we move from the efficacy of that single molecule, single target to a more, what I would call a more useful and pragmatic,
Right.
research approach?
So we've established that there are a lot of different ways to study medicine, and the results of some of these studies are not necessarily straightforward to interpret.
It's always tough. For me, I'm 67, so my basic science training was like 45 years ago, and things change radically.
Yeah.
So I'm like a lot of people, and when I've got a new journal article I think has pertinence to what I'm investigating, I may need to read it 3 times
Yep.
to try and get it straight. So none of this stuff is simple. There's a problem trying to translate this into lay terms because the foundation is so broad in the endocannabinoid system, and the details can be so extensive. It really defies simple explanations. And to be fair, that makes it very tough for the average physician to be able to grab a hold of this when their schedule has them seeing a patient every 15 minutes. It's just not amenable to providing good education to the patient about anything, let alone something so complex as medical treatment with cannabis or the endocannabinoid system.
Now, all of these nuanced details about research are important when it comes to the development of cannabis-based pharmaceuticals. To get a drug approved as a medicine in the United States, at least, a company has to present lots of data that shows that that drug, compared to a placebo, will provide an intended therapeutic effect for a particular condition or set of conditions. And that takes a lot of time, a lot of energy, and a lot of money.
In most respects, the development of a cannabis-based medicine as a pharmaceutical is the same for anything else. Mm-hmm. But cannabis is a botanical, a plant-based medicine. There's still a common misconception out there that you can't make a pharmaceutical from a plant, but it has been done. And even though Sativex isn't available in this country, it is approved in 30 other countries, and it passed the chemistry, manufacturing, control, and the safety signals.
Sativex, or nabiximols as it's also known, is a particularly interesting drug to focus our attention on. Sativex is a mouth spray that consists of a standardized cannabis extract with a 1-to-1 ratio of CBD to THC. Now, unlike Epidiolex, which is often criticized for being an isolated cannabinoid drug like Marinol, Sativex consists of a wide diversity of plant compounds extracted from cannabis. This means that the clinical data on Sativex is likely to be far more relevant when thinking about the therapeutic potential of herbal cannabis or cannabis extracts than research on isolated THC like Marinol or isolated CBD like Epidiolex.
But basically what's involved is you have to take your preparation and show that it's safe through toxicology. This means giving large amounts, unfortunately, to rats and dogs and seeing what happens. Then it's put through phase 1, in which normal people are exposed to the drug in varying amounts, and you see how long it lasts in the body, in the blood, and what the reactions of people are, monitoring the side effects, if any. Then it goes to phase 2. In this, moderate numbers of patients with a specific disease are given the drug. And again, you're looking for efficacy, safety, and then the other factor is consistency. Can you show that your drug, if it's a botanical, it's going to contain many ingredients? You have to show consistency of each component within very tight tolerances over the duration of the drug development program. The final step is phase 3, in which large numbers of people with the disease are given the medicine, again, to show safety, efficacy, and consistency. At a point where a drug is past all those steps, it's FDA approved, and then it takes about a year to designate a schedule. You know, if it's a drug that has psychoactive effects, it has to be put in a schedule that describes what its drug abuse liability is, whether it has addictive potential, how often a physician can prescribe it, et cetera, et cetera. And then label is developed and it goes on the market. So we're talking about, generally from start to finish, a 7 to 10 year proposition that will cost anywhere between $700 million and $1.2 billion. Easy, right?
Right. Yeah. Yeah. No problem.
But so that's one aspect of cannabis as medicine. However, as we're seeing now in this country, cannabidiol has been available in various preparations on another level where people can access it without prescription. So in the future, there are going to be other cannabis-based supplements. These should be also subject to safety and efficacy issues, as well as labeling. And we've got a final level or echelon of activity, which would be someone grows cannabis and may use it in a medical context. So there are these 3 different ways of getting cannabis medicine. I think people make a mistake when they think that one level can eliminate the others, much as the government thought that Marinol, synthetic THC, would reduce or eliminate the issue of medical cannabis. It never happened. It never will happen. Similarly, we've got some counterculture people that would just like to free the herb, so to speak,
Right.
and forget about these other areas of commerce. God forbid a company would make money on something that is God-given. But again, those are extremes of philosophy, I think.
Now, Dr. Rousseau makes a great point here. Just because cannabinoid and cannabis-based pharmaceuticals are being developed, it doesn't necessarily mean that herbal cannabis and the use of cannabis extracts is going away anytime soon. And in fact, a lot of times people tend to prefer herbal cannabis or the use of cannabis extracts over these available pharmaceuticals for a number of reasons. Sometimes it's efficacy related, but sometimes it's cost related too. Pharmaceuticals can be extremely expensive, and when you can just grow a plant at home and make your own extract and get the same or better efficacy, sometimes it's a little hard to justify going the pharmaceutical route. However, pharmaceuticals tend to be very standardized and consistent batch to batch. So it's possible that trying to treat a medical condition with homegrown cannabis or cannabis products obtained from either the black market or even legal markets and dispensaries may not provide the same consistent outcomes because the product chemistries will be a little different batch to batch. Unfortunately, there's really not much research available right now regarding herbal cannabis or cannabis extracts, and this is for multiple reasons. One reason is that research tends to happen with products that can be patented and that a company can make money on. So there's not a huge financial incentive to do the really expensive research on herbal cannabis or unstandardized cannabis extracts. Another issue is that cannabis flower and extracts are very diverse and inconsistent in their chemistry batch to batch. However, despite all of these issues, clinicians around the U.S. are noticing striking results in many patients using cannabis products.
My largest population is children with autism.
Okay.
Probably hands down. A lot of autoimmune, a lot of, just inflammatory pain syndromes.
Mm-hmm.
I've seen it work beautifully for opioid reduction.
That's Jana Champagne, a registered nurse who over the past several years has focused her attention almost exclusively on cannabis.
But, there's just so many things that it can be utilized for. And it was so funny. I had a consultation with a retired pharmacist, and you could tell he was questioning the science, and I was sticking to the research.
Yeah, well, that's good. Yeah.
And he was saying, Jenna, I just don't understand how one thing can be good for so many different conditions.
Mm-hmm.
And this is the shift that needs to happen. And, pharmacists and doctors are used to pharmaceuticals that have one or two active ingredients.
Right.
Where we have the cannabis plant that has upwards of 500
if not
therapeutic
thousands.
Components that we know of.
Mm-hmm.
We're finding more all the time.
Yeah.
And so this explains, the way that it works is to promote balance in the body. The underlying cause of every chronic illness is underlying imbalances. So in a general way, you can see how it's going to come in and kind of promote wellness overall. So it's very different. And cancer, we've seen cancer patients that are in stage 4 on hospice, not eating. Of course, we encourage patients to please reach out to us before cannabis is their last resort. But, we have seen some miraculous recoveries from cancer, patients who graduated from hospice. On hospice, we typically talk about, let's try to promote appetite, so at least you're not starving to death from the cancer and the cachexia piece. But, we always warn, if you're really intent on letting go and passing, this could extend your life. And, one of the best cases was lung cancer patient and on hospice, starving to death, took cannabis just to eat.
Mm-hmm.
And 6-7 years later, he's still alive and well and cancer-free.
Wow.
So we do have those instances, but once again, it's not to encourage people that, they can try everything else first and then bring in the cannabis. Because we also know by research that cannabis improves the efficacy of chemotherapy.
Right.
It's protective against the effects of radiation and against the symptoms that we often see as side effect of chemotherapy, where they lose their hunger, they can't eat, they don't have the energy to get well. So it just works on so many different levels for people. In my own case, the reason I became a cannabis nurse was my own health failure back in 2012. And it was immune related. And I was very, very sick and non-functional and on disability. I was critical care nurse doing acute care 12 hours a day, working my graduate program, homeschooling my daughter with autism. I mean, there were some other factors like stress involved.
Oh my gosh.
But you know, I turned to cannabis as an alternative to opioid pain medications after totaling my car. And knowing as a nurse, you've seen these long-term opioid patients and what they go through, and their gut stops working and they have tubes everywhere, and they're either awake and screaming pain or completely sedated and out, and nothing in between. And, you know, that's not anything anyone would wish for. So, but in addition to managing my pain, the cannabis actually started to rebuild my immune system. And now I'm healthy, fairly healthy, and functional anyway. I mean, I was non-functional, bedbound for a long time. People don't understand how sick I was. I mean, I was 20 pounds lighter than I am now. I was very, very ill. Chronic renal failure, and just all my systems were not handling the stress very well.
Well, yeah, it's definitely something I wouldn't guess by looking at you.
Most
got
people
to that
wouldn't.
serious point.
And then it went on to help my daughter with autism. A couple of years later, she went into autism puberty crisis, high level behaviors. You know, as a homeschooling mom, out of home placement was not something I ever would have considered, but it was almost mandated because of safety issues. And cannabis spared her that. So now I actually have a plan in the next year. She's 17 now, and working on a model of cannabis care homes for autism here in Oregon.
It's closer to a nutritional supplement than I feel than it is a medicine at this point, because we don't understand it.
This is Dr. James Taylor, a pain physician working in North Carolina. Ever since hemp became federally legal in the United States, he's been working with his patients to understand how hemp extracts, and CBD particularly, might be a tool to help treat chronic pain.
We know it's modulating and changing your endocannabinoid system, but modulating and changing it in what ways? I can't answer that question yet. So a lot of this is just hit or miss. And for me, being a physician that's dealing with the opioid crisis, I don't have a lot to lose, right? 60,000 Americans are dying every year. We need a Hail Mary in order for this to, for our country to change. And so for me, it felt good bringing something like this into this practice of medicine because we had nothing to lose. It is positively affecting our patients. We are able to reduce their dependency on narcotics, and we are slowly getting there.
All of this positive benefit that some of these healthcare professionals are seeing does not mean that cannabis is without risks. For an in-depth review of the risks associated with cannabis use, I recommend listening to the first 3 episodes of this season where we explored the question, is cannabis safe? Cannabis can interact with other medications, and it's not for every person or every condition.
Cannabis has a role to play, and I want to help find what that role is. And I want it to find a place where it's well understood for what it can do and what it can't do. What its strengths are and what its weaknesses are. It sounds like the next silver bullet to me, which doesn't exist, right? Cancer is an incredibly complex disease. People are complex organisms. How can one thing do all of that? Of course, as time came to bear, I saw that a lot of people died. Literally, and I would advise them, hey, I think you need to, really consider some oncological therapy. We need to, you're losing the momentum here, and it's a momentum game with cancer. It's trying to gain enough of its own resource generation and using what you have faster than you can maintain your own resource to build yourself. And there's this crazy struggle there. And if cancer starts winning that battle, it's really hard to turn it around, even with really powerful plant medicine or any kind of thing. Sometimes you just need, you need an intervention like a targeted therapy, an immunotherapy, a chemotherapy, even radiation in some outside, cases, or surgery, to debulk it and then go after it. And, I'm very selective and very specific about my choices, especially when it's concerning the life of someone and then their family and how it affects their community. It's a big deal to make a choice. And so, I got really put off by the fact that there was basically one person promoting, sort of like this path to curing cancer. I'm not gonna say any names, but it was like the idea that this person cured their cancer. Well, they cured basal cell carcinoma, a skin cancer that's basically you just cut it out and remove it. I can put, bloodroot and turmeric on it and just have it come out. I've just seen so many of those go away, but they're taking that and then interpreting it as, oh, cannabis cures cancer. And it's a very revolutionary thought. It's a very rebellious thought. And I feel it too. I really want there to be, a cure for cancer.
Right.
But there's no cure for cancer. It's not, you can't cure cancer like in one, it's like it's an incredibly complex thing, and I would love to elaborate on it at some point, all my kind of like 7 different sort of metaphors of cancer, as I call them, how it relates to as within, so without, and how cancer manifests, and then how we have to address it. And of course, prevention. I mean, that's what we can do. We used to talk about an ounce of prevention is worth a pound of cure. In cancer. My adage is an ounce of prevention is worth a ton of cure.
Yeah.
Because the cure is
so challenging,
damaging, and challenging. Oh my God, people, it's a long story, but swinging back around, I think that was the thing that concerned me the most about cannabis, was that, wow, people are going to take this medicine and they're going to fill their desire and their need to have that hope for the cure for all of what ails us. I will say also that I think with the, inhaled cannabis, especially vaporized, I really don't worry about drug interactions with people, especially if you've got a person who's going through chemotherapy and they're suffering from nausea and appetite loss.
Right.
And, like the benefits to vaporized cannabis in that context, I mean, it's the best medicine that I've ever experienced. And I've talking about dozens to maybe hundreds of patients that I've guided them through that with. And it's remarkable that they're able to actually take their therapy because the medicine of the cannabis allows them to overcome the symptoms caused by the medication. But the medication is actually doing something good. It's killing their cancer, and of course there's more, it's a complex story about that. But, I think in those contexts, whatever we don't know, I think it's okay, and I've seen a lot of people do that and come through with flying colors,
Well, a big part of that is like, if you can deal with the nausea, then you can eat more, you can have more strength, your body's able to do its own work to protect healthy cells from the damaging effects of things like radiation or chemotherapy. And so the likelihood that you'll have a positive outcome with that conventional therapy for cancer treatment increases. And I think that's a very valuable tool. And back in the 80s, researchers were catching on to that. That's why Marinol exists on the market, is to treat cancer-related nausea. Of course, turns out it doesn't work as well as herbal cannabis.
So inferior.
Has its own side effects and issues. But that's why one of the first pharmaceutical drugs from cannabis got approved was for that indication. So, despite some of the miraculous claims about cannabis, it's not a cure-all, and some of the claims made by advocates are a little overhyped. However, other clinicians I spoke with also shared additional stories of the successes of the medical use of cannabis in their patients, which begs a question. Just how much evidence is required before cannabis or any other natural product can be accepted as an effective medicine? We've already discussed that the gold standard of medical research is considered to be the randomized controlled trial, but it's an extremely expensive process to get something through the drug approval process in the United States. Because this process is so expensive, it's pretty rare for a company to spend the millions, if not billions of dollars required to study a natural product alone that they can't even end up patenting and capitalize on later. Additionally, natural products are challenging to standardize and control, which really doesn't lend itself well to the modern medical research schemes. We've also covered the fact that cannabis has an extraordinarily long track record with humans, going back nearly 5,000 years or more. Through that time, records of varying degrees of quality have been kept about the medical use and toxicity of cannabis for thousands of years. The historical record indicates that cannabis has been considered a potent medicine all the way up until the 1930s, when cannabis prohibition began. And we haven't even really talked about the history of cannabis prohibition, but let me just say, the start of cannabis prohibition was not something based in science. And many medical associations were actually unhappy when access to cannabis was prohibited in the 1930s. Now, modern research has confirmed that, in fact, many of the traditional medical uses of cannabis are actually well-founded, and compared to many foods and drugs, cannabis is actually pretty safe. Where we lack clinical research, we have a host of anecdotal reports, case studies, and observational studies documenting the medical efficacy of cannabis. And while, yes, these types of research may be considered lower quality, at a point, these reports become pretty overwhelming in their results. And yet, today in 2019 in the United States, people are still struggling to get legal access to medical cannabis. While many of you may already be familiar with the little girl named Charlotte Figge that brought nationwide attention to the treatment of CBD-rich cannabis for seizures in children in a famous CNN special with Dr. Sanjay Gupta called Weed, you may be less familiar with another little girl that's fighting the same fight in my home state of Mississippi, and her name is Harper Grace. Harper Grace is a little girl that also suffers from seizures, similar to that we saw in Charlotte. Her parents found that CBD-rich cannabis was an effective treatment, and in 2014, after a lot of advocacy from Harper Grace's parents and friends and supporters, the state actually legalized CBD oil, but in a very limited capacity for limited conditions in a very limited selection of patients. Since the law passed, which is actually named after Harper Grace, that little girl still has not been able to get access to CBD treatment. And now her parents are fighting for statewide medical marijuana legalization for Mississippi in 2020.
Activist Ashley Duvall registered the Medical Marijuana 2020 initiative last year, and her daughter Harper Grace hasn't been able to receive marijuana extract oil for treatment of her rare form of epilepsy. A 2014 law named for Harper Grace nixed the oil from the state's banned substance list. Others, including Governor Phil Bryant, say there's a lack of scientific evidence providing the benefits of marijuana treatment outweighing any risk.
This issue is especially poignant considering the country's only federally sanctioned cannabis research and development laboratory is actually located at the University of Mississippi. So, let's review what we've learned. Cannabis has been used as a medicine for a lot of different medical conditions for thousands of years. Up until the early 1940s, cannabis was even part of the U.S. pharmacopoeia, until Prohibition began in the late 30s. Medical research comes in a lot of forms, and we really have to be careful not to conflate the statistical significance of an effect that's measured in a research study with the clinical significance of an effect that's measured in a therapeutic setting. Just because something might seem statistically significant doesn't mean that's going to translate to any meaningful effect when someone's trying to use it to treat something that's ailing them. We can't assume anything based on a single research result. Research findings always need to be replicated by a different group of researchers. The clinical research that is currently available about cannabis indicates that it could hold promise for the treatment of conditions like nausea, loss of appetite, chronic pain, and spasticity. There are case studies and uncontrolled clinical research that indicates that cannabis could be useful for a number of other conditions like autism, ADHD, PTSD, anxiety, depression, and immune system-related disorders. While there are numerous case studies and observational reports documenting cannabis's efficacy treating conditions like these in patients, it's difficult to interpret that data and extrapolate it to a much larger population, at least yet. Clinicians working with patients using cannabis are seeing positive effects in general, and at times even profound results. But cannabis is not a silver bullet, it's not a cure-all, and it's not for every person or every condition. But it is a tool in the clinical tool chest that some people respond very positively to. There's a lot we don't know. Cannabis comes in a lot of forms. There are many different chemical profiles of cannabis, each with its own therapeutic index. We're just scratching the surface, really, with understanding cannabis, and we still have a long way to go. But we do know that cannabis is very safe when consumed responsibly. It is impossible to lethally overdose on cannabis, and many of the adverse health risks of cannabis can be minimized by utilizing oral forms of cannabis at low dosages. For more information about the safety of cannabis, check out episodes 1 through 3, where we explore this topic at length. So, how is cannabis a medicine? Well, simply put, a lot of ways. While yes, some of the claims about cannabis as a medicine are overhyped, a lot of them aren't. And a lot of people are finding relief from very serious conditions that they're having to live with every day through the use of cannabis. Today, it seems like the rationale for restricting access to cannabis or cannabis products often comes down to an argument around safety and a lack of research. Harper Grace is fighting for access to CBD oil because lawmakers in Mississippi feel that cannabis needs to be studied more to understand its risks. The FDA has stated that they're unlikely to allow CBD in foods because they want to better understand the potential risks. This issue with CBD safety in particular is really interesting, especially considering the World Health Organization in 2018 already issued a report claiming that, and I quote, "CBD is generally well tolerated with a good safety profile. To date, there is no evidence of any public health-related problems associated with the use of pure CBD." Now, despite this determination, the FDA backs their stance by citing a recent rodent study that claimed to have identified the liver-damaging effects of CBD. However, as we covered in episode 1 of the podcast, this study was a rodent study that utilized massive, unrealistic doses of CBD before uncovering the damaging effects on the liver. At doses more typical of what anyone might encounter in real life, these liver damage effects were not observed. Very recently, Democratic presidential candidate and former Vice President Joe Biden stated that he believed that there needed to be more research into the risks of cannabis, particularly as a gateway drug, before he would consider legalizing the plant federally. Yet, as we also covered in episode 1 of this podcast, an administrative law judge in the U.S. back in 1988 made a formal statement attesting to the safety profile of cannabis and the need to reschedule it to a more lenient drug schedule. Hell, if you think about it, over the past several decades, starting in, I guess, maybe around the 50s or 60s, most of the research into cannabis has been focused on trying to find the risks and damaging effects. That kind of research has been done. So, what do you think? Do we need more research into the safety of cannabis before we legalize nationwide? How much evidence is enough before people are allowed open legal access to cannabis for medical purposes around the world? Personally, I was left with a few questions. 1. Why are cannabis and its cannabinoids still Schedule I drugs in the United States? It's clear cannabis has therapeutic applications in certain contexts. Sure, cannabis can be abused, but so can many other things which are totally legal. Many lawmakers claim we need more research, but how will that research ever take place if cannabis remains a Schedule I drug? Ultimately, the legal status of cannabis seems to be hurting people far more than the plant ever could. 2. Given the safety profile of cannabis and its potential efficacy, contrasted with the sometimes harsh effects of some other medications, why is cannabis often used as a last resort treatment option for patients rather than one of the early options? And 3, how much of the benefit that users claim they're getting from cannabis is actually related to its therapeutic activity, and how much might just be placebo? And if some of cannabis's therapeutic effects are placebo effects, does that matter if people are finding relief and the treatment is relatively benign? So far, we've been looking at the various ways cannabis is used as a medicine, and how it's been used as a medicine throughout history. But what do cannabinoids and other chemicals in cannabis actually do in the body to elicit these medicinal effects? The story of the discovery of the endocannabinoid system goes back nearly 150 years ago, when more sophisticated systematic research into cannabis was just beginning to take place in the mid to late 1800s. Researchers were taking notice of cannabis's medical as well as recreational effects and wanted to understand how cannabis worked. So they gave cannabis to animals and people and studied what happened. Eventually, researchers began trying to isolate components of cannabis in an effort to identify the primary active component of cannabis that's responsible for a lot of its effects. at least the effects that researchers were aware of at the time. In 1964, researchers in Israel hit the jackpot when they isolated THC and discovered that it got dogs high. This triggered a series of research experiments to try and determine why THC got the dogs and people high. There must be some mechanism in the body that was responsible for these effects. But it really wasn't until 1988 that researchers discovered their first chemical receptor in the body that THC interacted with. This would later be identified as the cannabinoid type 1 receptor, or, as you might know it, the CB1 receptor. A year later, the chemical structure of the CB1 receptor would be characterized, and it would be later discovered that CB1 receptors were actually the most abundant chemical receptor of its type in the brain by far. And yet, up until the late 1980s, researchers had no idea it existed. Talk about hiding in plain sight. And CB1 receptors are not just limited to neurons. They're found all throughout the body, even in the skin. Researchers then began to ask an important question. Why do these chemical receptors exist in the body in the first place? In 1992, researchers would begin to uncover an answer with the first discovery of a cannabinoid endogenous to the human body, which researchers would later name anandamide, or the bliss molecule. It was discovered that anandamide and THC behaved very similarly in the body, and that when someone ingests THC, that THC is basically able to take advantage of the series of chemical receptors in the body that are normally reserved for anandamide. And as researchers would later discover, there are a host of other endogenous cannabinoids also produced by the body that are influencing these cannabinoid receptors. Now, I want to clarify a point here. It's often claimed that the existence of cannabinoid receptors in the human body is evidence that the human body is somehow designed for cannabis. But this really is simply not true and a misrepresentation of the science. Although humans and cannabis have co-evolved for thousands of years together, the endocannabinoid system is not designed for exogenous cannabinoids. It just so happens that cannabinoids in cannabis are similar enough to our own endogenous cannabinoids that our bodies make that they can interact with those same receptors in much the same way that other drugs elicit effects in the body. For instance, tryptamine-based psychedelics like psilocybin from magic mushrooms and DMT from ayahuasca elicit their effects because they are similar enough to other endogenous neurotransmitters like serotonin that are in our bodies, and so they can interact with those chemical receptors in our body. But that doesn't mean that our bodies were designed to interact with these compounds. Now, back to our history lesson. Now, a year later in 1993, a second receptor was discovered that THC interacted with. This would go on to be called the cannabinoid type 2 receptor, or CB2 receptor. Real creative. The CB2 receptor is now known to be located all throughout the body, heavily on immune system cells, but also in neurons and other places. And it'd later be proposed that CB2 receptors may form a critical system in the body that actually helps protect cells and tissues from damage. Then in 1995, another endogenous cannabinoid, or endocannabinoid as I'll call it from here on out, would be discovered. And this second endocannabinoid that was discovered would be called 2-AG, or 2-arachidonoglycerol. Funny enough, it would later be discovered that 2-AG is actually far more abundant in the body than anandamide, but I guess since 2-AG was the second endocannabinoid discovered, it didn't really get a fancy name like anandamide did. So while anandamide is often the most commonly cited endocannabinoid, 2-AG probably deserves a lot more attention. Now, at this point in history, it was beginning to be clear to researchers that they were piecing together some complex system or network in the body that was continuing to grow in complexity the more that they studied it. It was in the year 1998 that the concepts of endocannabinoids and the endocannabinoid system were first presented to the public. And now, over 20 years later, the endocannabinoid system has continued to evolve and astonish researchers. But what does the ECS actually do? In 1998, when the ECS was first formally described, it was hypothesized that the functions of the endocannabinoids in the body were to help the body, quote unquote, relax, eat, sleep, forget, and protect. Now we know that this picture is actually quite a bit more complex.
The endocannabinoid system is really fascinating. I look at it as a lipid signaling network that, if we were to diagrammatically look at it, I would say that it's at the bottom of a pyramid, and everything else, neurological system, cardiovascular system, immunological system, all of those are stacked on top of it.
That's Kevin Spellman, a researcher that's been spending a lot of his time trying to understand how compounds like those in cannabis interact with the endocannabinoid system and with cannabinoid receptors like CB1 and CB2 receptors.
And therefore, that foundation endocannabinoid system affects everything that's sitting on top of it. So it has this huge role in signaling throughout the body, and I think that's really, really key. And so it's so much more than just the enzymes that are synthesizing and breaking down cannabinoids and the receptors that are directly considered cannabinoid receptors, such as CB1, CB2. There's, now there's a putative CB3. It looks like there's probably a CB4 and a CB5 at this point, but it's too early to actually call them that. But there are a lot of compounds there are a lot of receptors that actually bind our endocannabinoids, as well as the exogenous cannabinoids in our body.
Yeah, and are you referring to like a lot of those G protein coupled receptors?
Yeah, GPCRs, exactly.
Yeah.
And then you've got the ion channels that are coupled to receptors. So the whole TRP receptor system is really fascinating and makes a huge difference in terms of pain and sensation, as well as just gut health and neurological health. And so it's a very pleiotropic system that affects so many different subsystems or tissues throughout the body.
The endocannabinoid system is the master homeostatic regulator of physiology.
That's Dr. Ethan Rousseau, a neurologist and cannabinoid researcher that initially proposed the idea of clinical endocannabinoid deficiency back in the early 2000s.
What does that mean? Well, physiology is how things work in the body. Generally, you need a certain level of activity, neither too high nor too low. And that's precisely what the endocannabinoid system does, is try and keep things in happy balance. So if a system is overactive, it tends to bring it down. If it's underactive, to bring it up. This works through complex mechanisms. We have endogenous chemicals within called endocannabinoids, specifically 2-arachidonoglycerol, 2-AG for short, and anandamide. Anandamide in particular closely resembles THC. Both are partial agonists at the CB1 receptor, the main psychoactive receptor in the brain and elsewhere throughout the body. And what this does at the brain level is actually reduce the release of neurotransmitters. So if we have a glutamate neuron that's stimulatory, the reduction in the release of glutamate will lower that activity. Good example of why that's important is, we'll give two. Glutamate activity tends to be excessive in neuropathic pain, nerve-based pain. So if we have a person with chronic neuropathic pain, we can either raise their anandamide level or supply exogenous THC and bring that glutamate level down. And that's going to help with pain. Similarly, in brain injury, whether it be trauma, stroke, or things of that sort, we get an excessive release of glutamate. It can be so bad, there can be so much glutamate that it produces an excitotoxicity, that the cells actually stimulate themselves to death. We have situations in which people suffer a head injury. They might seem okay briefly and then rapidly deteriorate over 48 hours. And some of that effect is from this excitotoxicity from glutamate. If we're able to supply drugs like cannabidiol or THC early enough, some of that can be prevented and have a much better result clinically. So those would be examples.
The ECS is often characterized as consisting of three primary parts: the endocannabinoids, the cannabinoid receptors, and then the enzymes that produce and break down those endocannabinoids and cannabinoid receptors. However, modern research is really shattering this concept. We now know that there are many different endogenous cannabinoids in the body that really haven't gotten much attention in mainstream media. One, for instance, is called N-arachidonyl dopamine. I bet you've never heard of that one before. Additionally, there are more cannabinoid receptors than CB1 and CB2 receptors. There are numerous yet-to-be-named chemical receptors in the body that are the same receptor type as cannabinoid receptors. They're called G-protein-coupled receptors. And both endocannabinoids and exogenous cannabinoids like THC and CBD seem to interact with these receptors. The most common example of this is a receptor called GPR55. There are numerous others like GPR18, GPR35, the list goes on. And it's highly likely that one day at least some of these receptors will be referred to as the CB3, CB4, and perhaps even a CB5 receptor. We also know that cannabinoids actually interact with a lot of different chemical receptors in the body besides the classical cannabinoid receptors. CBD is a great example of this. CBD hardly interacts with CB1 or CB2 receptors at all. Instead, CBD interacts with a host of different chemical receptors like adenosine receptors, serotonin receptors, vanilloid receptors, and PPAR gamma receptors, just to name a few. Additionally, CBD can stimulate the production of endocannabinoids in the body, potentially causing indirect stimulation of cannabinoid receptors like CB1 and CB2 receptors. So the endocannabinoid system is a very complex thing, and its definition is starting to get a little hazy as we learn more about it, because it overlaps with so many other chemical signaling systems in the body. The discovery of the ECS and its connection to all these different parts of the body have helped doctors better understand why cannabis may be producing some of its therapeutic effects in patients. It turns out that different cancerous cells, for instance, upregulate the production of different types of cannabinoid receptors in different tissues. So understanding what diseases are going to affect the ECS in different ways can help doctors understand what cannabinoids might be effective in treating those disease conditions. Endogenous cannabinoids and cannabinoid receptors are critical components of the immune system, controlling the release of certain types of chemicals in the body called cytokines, which can trigger pro- or anti-inflammatory responses in the body. While studying how cannabinoids affect pain, a radical discovery was made about cannabinoids. If you will, imagine that the chemical signaling in the body flows like a river, in one direction. Typically, when neurons communicate with one another, the signal can only flow one direction. However, cannabinoids are able to do something very profound. Cannabinoids can actually travel backwards, against the current, if you will, to affect signals coming from a neuron upstream. In this way, cannabinoids are actually able to essentially change the current of this river of chemical signaling. Cannabinoids can slow the waters down by dampening the signaling, or they could speed the current up, enhancing the signaling. Another way I like to think of this is that cannabinoids are able to help turn the volume of signaling in the brain up and down. If that signaling is a pain signal, then turning the volume down could be very therapeutic. Understanding the ECS also helped explain some of the classic THC-rich cannabis side effects. For instance, there are a lot of CB1 receptors located in the hippocampus of the brain, which is a part of the brain that does a lot of work associated with memory. Now, it's no surprise that when CB1 receptors are affected, as they are when THC is consumed, memory would be affected in some way. Additionally, cannabinoid receptors are associated with saliva production. While some people believe that smoking is responsible for the dry mouth effects of cannabis, this is actually not the case. Dry mouth is caused by cannabinoid receptors. Additionally, cannabinoid receptors are also intimately associated with appetite and hunger satiation. In a research study with rodents, it was found that if CB1 receptors in infant rodents were not stimulated within the first hours of life, the rodents wouldn't feed, and they'd suffer what is often referred to as wasting syndrome. Eventually, these rodents would just die from being malnourished. And it's the same kind of effect that's responsible for producing the munchies in THC-rich cannabis users. CB1 receptors are intimately linked to that appetite signaling. But with everything we know about the ECS, there's still a ton that we don't know. For instance, we still don't understand how to appropriately measure the state of somebody's endocannabinoid system in order to determine whether a cannabis or cannabinoid therapy will be effective for treating a medical condition that someone may have. In 2001, it was proposed that endocannabinoid system deficiencies might be responsible for some medical conditions like fibromyalgia, migraine, and irritable bowel syndrome. But without a solid way of measuring someone's endocannabinoid system tone, it's really hard to study this idea of underlying endocannabinoid system derangements. If the endocannabinoid system can be deficient, then it could also be overactive, which might lead to issues like excess hunger and possibly even diabetes. And there are some other effects that an overactive endocannabinoid system could cause, including things like depression.
Endocannabinoid tone is an important concept, but we don't have good ways of measuring it.
Right.
The three important aspects are how much of the endocannabinoids are present. Second is, what's the activity of the receptors? If someone is using THC at high doses recreationally, the receptor number will actually go down. It's the brain and body's way of trying to keep things on an even keel. So the receptors become inactive. When they stop, they'll reactivate. So there is the number and status of the receptors. There is the amount of the endocannabinoids. And the third part is, what is the activity of the enzymes that make the endocannabinoids and break them down? So unfortunately, we don't have ways of measuring this directly, except with invasive techniques, such as doing a lumbar puncture or spinal tap to measure anandamide levels. But that's invasive. It's not something you can do on an experimental basis with most ethics committees, for example. Ideally, in the future, we would have scans, non-invasive methods of trying to assess endocannabinoid tone. But that's a dream for the future right now.
And one thing I want to point out here is that modulating the ECS to affect health doesn't really have to be about cannabis at all. In fact, the discovery of the ECS actually begins to carry us away from cannabis as we learn how other things affect the ECS. For instance, it was recently discovered that several common flavonoids found in plants and fruits interact directly with the ECS. A common component of many plant essential oils, called beta-caryophyllene, was found to directly interact with CB2 receptors and now is being called a dietary cannabinoid. Interestingly enough, many years ago, humans were actually exposed to a lot more beta-caryophyllene in their diets because corn, of all things, was once very rich in this oil. But over time, through intensive breeding and farming practices, this component of oil was nearly bred out. Then in the early 21st century, researchers actually discovered that corn rich in beta-caryophyllene is actually more pest resistant, and this motivated farmers to grow corn that's more rich in this oil, and potentially we'll see this dietary cannabinoid become abundant in our diets once again. Now, one can't help but wonder what the potential health ramifications have been for humans over the past 100 years if our food has been purged of these botanical constituents that interact directly with such an important bodily system as the ECS. Now, additionally, from things like flavonoids and certain oils in plants that interact with ECS, there are other things like physical activity that stimulate the ECS.
The paramount lifestyle approaches that would affect the system would be, first, aerobic exercise. We've got good data, especially from animals and limited in humans, that show that you improve your endocannabinoid tone and overall well-being through aerobic activity. Humans weren't designed to be sedentary, as is prevalent in modern society. And the other one, which seems to be taking on more and more importance, is the microbiome, the bacterial content of the gut. A lot of the ills of modern society are nutritional in origin. We're seeing a huge increase in things such as the metabolic syndrome, type 2 diabetes associated with obesity. Again, this is not normal in human populations. In contrast, we're seeing a situation in which the American diet in particular is pro-inflammatory, as well as having an improper balance of nutrients, generally too much. But a lot of this can be counteracted by having a better bacterial balance in the gut, and that can be attained through eating more vegetables, more fiber, and particularly use of probiotics and prebiotics. And this can make a tremendous difference in health and regulating the endocannabinoid system.
Things like exercise, yoga, and even massage have been shown to cause releases of endocannabinoids in the body. Finally, meditation is another activity that seems like it may have direct effects on the ECS. What this all ultimately tells us is that although the story of the ECS may have begun with cannabis, it certainly doesn't seem like it's going to end with cannabis. But we're faced with a major problem in our healthcare system currently. Well, one of many problems. And that's that many healthcare professionals are grossly undereducated regarding the endocannabinoid system. And many, if not most, medical schools around the world still don't teach about the endocannabinoid system, despite the immense progress and research that's occurred over the past 50 years or more.
What's amazing to me at this point is for a system that's so fundamental to how our bodies work, this is not, in general, taught in medical school. Somebody can go through medical school and learn nothing about cannabis, or except perhaps its alleged addiction potential. But unfortunately, it's highly likely they won't learn anything about the endocannabinoid system, despite the fact that CB1 is the most abundant G protein coupled receptor in the brain, exceeding the number of all the neurotransmitter receptors put together. So obviously, it's really fundamental to how humans work.
So it's obvious that there's a major education effort needed if our healthcare system is going to start incorporating the endocannabinoid system into the way that it functions. And it's clear by now that because the ECS is tied to so many things in the body and serves such a foundational role in regulating health, ignoring the ECS when trying to affect positive changes to health could be profoundly foolish. Now let's review what we've learned. The endocannabinoid system is a relatively new concept. The basic pieces of the ECS were not discovered until the late 1980s and early 1900s, and the definition of the ECS keeps expanding the more that it's studied. The endocannabinoid system is much more than CB1 and CB2 receptors, or anandamide and 2-AG. There are all sorts of endocannabinoids in the body and all sorts of receptors that endocannabinoids, as well as exogenous cannabinoids like THC and CBD, interact with. THC and CBD affect the ECS in very different ways. While THC mimics the behavior of anandamide and interacts with both CB1 and CB2 receptors directly, CBD hardly interacts with cannabinoid receptors at all, and instead affects things like vanilloid, adenosine, serotonin, and PPAR gamma receptors. CBD does indirectly stimulate cannabinoid receptors by stimulating the production of endocannabinoids and limiting the activity of enzymes that would normally break those endocannabinoids down. The ECS is affected by all sorts of other things besides cannabis. Many foods can affect the ECS directly, and additionally things like exercise, yoga, massage, and even meditation can affect the ECS, although much more research is needed to better understand these effects and how they affect health. There is a severe ignorance about the ECS facing our medical institutions currently. The ECS is rarely taught about in medical schools, and many healthcare professionals are ill-equipped to think critically about the ECS, despite the fact that the ECS is a critical part of human physiology. Now, we'll be revisiting the concept of the endocannabinoid system many times throughout this podcast, which is why I wanted to make sure to go ahead and cover some of the basics about it in these early episodes. It's impossible for me to really dive into the nuts and bolts of the ECS in a couple of short episodes, but we'll start teasing out these complexities of the ECS, including the ways it may be connected to various diseases and health conditions, in future episodes and future seasons.
None of this stuff is simple. There's a problem trying to translate this into lay terms because the foundation is so broad in the endocannabinoid system, and the details can be so extensive. It really defies simple explanations. And to be fair, that makes it very tough for the average physician to be able to grab a hold of this when their schedule has them seeing a patient every 15 minutes. It's just not amenable to providing good education to the patient about anything, let alone something so complex as medical treatment with cannabis or the endocannabinoid system.
One of the big takeaways from my discussions with Dr. Rousseau and Dr. Spellman about the endocannabinoid system is that our struggle to wrestle with the complexities of the ECS are really reflective of our struggle to understand the vast complexities of biology itself. Despite all of the research that's been done to date, we still only have knowledge about a small sliver of the big picture, and we really have to maintain some humility regarding that fact. I really like the saying, the more we know we don't know. And I think this is very true for cannabis and the endocannabinoid system, as well as a lot of other things in life. Since the 1990s, research into the endocannabinoid system has exploded. Even the United States federal government recognizes the value of endocannabinoid research, as they offer grants to researchers that want to study it, and the National Institutes of Health regularly meets to share progress on endocannabinoid research. In the early 2010s, researchers began piecing together this bigger picture that they referred to as the endocannabinoid dome. The endocannabinoid dome is currently thought to consist of hundreds of ligands, or signaling molecules, and at least dozens of receptor targets and a whole host of enzymes. It's a very big and multivariate system that extends much further than our initial conception of the endocannabinoid system. In this episode, we're going to be diving into this concept of the endocannabinoid dome to try to understand its implications. And to guide our curious quest, we'll be tackling several primary questions. 1. What is the endocannabinoid dome and how was it discovered? 2. How does the endocannabinoid dome influence physiological functioning and health? And 3. What does the future of endocannabinoid dome research look like? And so, without further ado, let's get started. So how did this concept of the endocannabinoid dome come about? Let's very briefly review what we covered in last season's episode about the history of the endocannabinoid system. Cannabinoid receptors weren't discovered until the mid to late 1980s. For the longest time, researchers thought there might not even be a cannabinoid receptor. It was actually proposed that maybe cannabinoids exerted their effects by manipulating enzymes or cellular membranes without actually interacting with the receptor. However, in the 1980s, a researcher named Ellen Howlett and her team discovered that a synthetic cannabinoid that they had been gifted from Pfizer actually binded to a receptor in the body. They worked to isolate the receptor, and this chemical receptor was even tentatively named Howlett's receptor, before it was later dubbed the cannabinoid type 1 receptor, or as we often refer to it today, the CB1 receptor. Shortly after that, the CB2 receptor was discovered. Once these cannabinoid receptors were discovered, researchers then began hunting for the endogenous ligands that associated with these receptors. Contrary to some of the messaging floating around about the endocannabinoid system, there's really no evidence that humans evolved to consume cannabinoids from the cannabis plant. Just because we have cannabinoid receptors in our body That doesn't mean that they're there just because there are cannabinoids in a plant. What's far more likely is that the body produces those receptors because there's some compound in the body that the body makes that interacts with those receptors. And because chemical receptors tend to be rather promiscuous, meaning that they are stimulated by a wide variety of compounds of somewhat similar structure, rather than sort of the lock and key model that we often are presented in school, that kind of gives the impression that a chemical receptor is designed for a particular key. It's not really the case. And the endogenous receptors in our bodies can be manipulated by exogenous compounds from plants or fungi because they're similar enough in structure to the endogenous ligands that our bodies produce to interact with those receptors directly. We don't make the assumption, for instance, that just because we have nicotinergic receptors in the body, that we must then need to consume nicotine from plants. The same idea holds true with cannabinoids. Now, while it is true that there are chemical receptors in the body that are called orphan receptors, because an endogenous ligand hasn't been discovered for them yet, most researchers agree that with the proper tools and methods of analysis, most, if not all, orphaned receptors will someday be de-orphaned, meaning that we will someday find endogenous compounds that the body makes that interact with those receptors. In the early 1990s, researchers found that a compound in pig brains was binding to CB1. They eventually identified and later synthesized this compound that they would later name anandamide. And shortly after that, they would also discover another endocannabinoid called 2-AG, or 2-arachidonylglycerol. And once these endocannabinoids were identified, well, then researchers wanted to understand what were the enzymes that were building these compounds in the body and how are they getting broken down. And this leads us to the late 90s. It was 1998 when endocannabinoid researcher Vincenzo Di Marzo published a paper characterizing this group of endogenous cannabinoids, cannabinoid receptors, and the basic enzymes responsible for building and breaking down those endocannabinoids. And he referred to it as a single system called the endocannabinoid system. This is around the same time that Dr. Di Marzo and colleagues also published a separate paper identifying some strange activity they noticed while they were studying 2-AG they ended up calling entourage effects. And it was pretty much around this time that our modern conceptions of cannabinoid science were born. But it turns out they're really due for some major updating. When I spoke to Dr. Ethan Rousseau for Season 1 of the podcast, we spoke about the ever-widening conception of the endocannabinoid system.
Right. Well, yeah, no, it's a broadening concept. I asked my friend and colleague Vincenzo Di Marzo whether he now would consider the serotonin 1A receptor part of the endocannabinoid system. And he didn't hesitate. He said yes. How this comes into play is cannabidiol was shown by my team at the University of Montana back in 2005. Cannabidiol is a serotonin 1A agonist. And we're finding that mechanism explains a lot of activity of cannabidiol, as well as its effect on nausea, prevention of brain damage from ammonia levels in hepatic failure, and a lot of other mechanisms. Another example would be cannabidiol is also an agonist, a stimulant on the TRPV1 receptor, the same place where capsaicin works. And again, most experts consider that part of the broad concept of the endocannabinoid system. So what's amazing to me at this point is for a system that's so fundamental to how our bodies work, this is not in general taught in medical school. Somebody can go through medical school and learn nothing about cannabis, or except perhaps its alleged addiction potential. But unfortunately, it's highly likely they won't learn anything about the endocannabinoid system, despite the fact that CB1 is the most abundant G protein coupled receptor in the brain, exceeding the number of all the neurotransmitter receptors put together. So obviously, it's really fundamental to how humans work.
One thing that Dr. Rousseau and I didn't touch on is that beyond anandamide and 2-AG, there are other endocannabinoids that have been studied. Some of the best understood of these compounds are things like nolidin ether, verotamine, and N-arachidonyl dopamine, or NADA. These novel endocannabinoids are not well understood, but there are other endocannabinoid compounds that are even less understood than these. Another thing that we didn't mention in our discussion was that endocannabinoids and cannabinoid receptors perform different functions depending on where they're located. So, as I've mentioned before, endocannabinoids act locally on demand, meaning that they're produced when they're needed, and they generally only affect the immediately surrounding cells or tissues. The consequence of this is that there are essentially a vast series of miniature endocannabinoid systems all throughout the body. But that's only the beginning of how complex things get when it comes to endocannabinoids. The concept of the endocannabinoidome came up again in my interview with the Doctors Knox at the very beginning of this year. The Doctors Knox are a family of physicians based out of Portland, Oregon, that all specialize in cannabis and cannabinoid medicine.
I think the basic endocannabinoid system and its different components, that's pretty basic. What I am more excited about is finally figuring out that it's just bigger than the ECS and how many things that are interacting at the same time or in parallel. You know, each system of the body actually has its own endocannabinoid system, and they're all communicating with each other to keep the body in balance. But with that being said, that system is just a part of a bigger lipid signaling system. And I think when we really figure that out, what that is and how complex it is and get through it, then we're really going to be able to change health. When you think about THC, it doesn't just work on that CB1, CB2 receptor. Right? It's working on other things as well, as are the endogenous cannabinoids. It's working on other things as well. So it's a much more complicated picture than we realized. And that deep dive to try to understand more than what we see, what we know at this point, is what's going to lead us to make more effective drugs and therapies. I mean, novel things that really will answer questions even more than just addressing the conventional description of the endocannabinoid system. That's my realization of what I'm finding out. It's bigger than that even. You know, a prime example of that is all the attention and research that's now going toward the gut, you know, brain ECS axis. That is just, it's profound because that gut actually helps to create some of those endocannabinoids when that system is working properly. But no one thought about that before. So all these things are becoming to realization that it's just bigger than CB1, CB2, anandamide, and 2-AG. I mean, if that's all you understand, you're at the starting line, right?
Yeah.
You got to go beyond that because it's huge, and that makes the sky the limit as far as what we can create and do with wellness.
I wanted to learn more about this new concept of the endocannabinoidome, but I wanted to go to someone that was directly studying the system. So, who better than Dr. Vincenzo DiMarzo himself?
You know, with the word "om", now we make new words containing the prefix, the suffix "om", to identify a very large system. So we have the genome, we have the metabolome, we have the proteome, and so on and so forth. So the endocannabinoidome came in a way from, you mentioned before the study that Rafi Meshulam, in which we collaborated on the entourage effect. So basically what Rafi perceived is that, and what we were measuring, in fact, when we were measuring endocannabinoids, is that these two molecules, anandamide and 2-AG, were accompanied by a plethora of other compounds. And these compounds, these metabolites, were chemically and biochemically similar, meaning that anandamide and 2-AG belong to two different families of metabolites, and these are the N-acyl ethanolamines and the monoacyl glycerols. Some of which were already known, in fact, even 1 or 2 decades, or even longer than that, before the endocannabinoids were discovered. So, but nobody knew really how these molecules were acting. So Rafi, in a very imaginative way, that this is really his main feature is creativity and imagination, thought, well, these are accompanying molecules that are there to protect, to make the two big actors look even more important than they are. So it's an entourage, or when politicians go around and they take with them a lot of accompanying people, and that's certainly part of the picture. But then we started realizing that these compounds, in fact, do have molecules, do have targets of their own. So the endocannabinoidome, if you wish, is a kind of evolution of the entourage effect. Molecules like the N-acetylenolamides or the monoacylglycerol started being investigated. Receptors were being found, and this created, of course, excitement but also complications. Because the pharmacologists and the drug developers were the therapeutic drug developers were thinking, okay, we can manipulate the levels of since they are so strongly involved in pathology, we can manipulate the levels of the endocannabinoids of anandamide and 2-HG in order to make more of these compounds where they're needed, or to reduce their amounts where they're produced in an excessive manner. So you can do that by manipulating the degradation or the biosynthesis of endocannabinoids. But then when it was found that, and we and many others, that anandamide has the same biochemical pathways as other N-acetylenolamides, which have different receptors from the cannabinoid receptors, this created a strong complication. We cannot really manipulate the levels of anandamide in this way without manipulating the levels of the other previously known as entourage compounds, but having an identity and the mechanism of action of independent from the endocannabinoids of their own. So the endocannabinoidome is basically the bigger system, including not only anandamide and 2-HG and their main receptors, which are CB1, CB2, but also some of the other receptors for anandamide and 2-HG, because these are two very promiscuous molecules, unlike THC. This is one major difference between the endocannabinoids and the plant cannabinoids, or at least between the endocannabinoids and THC. And then it was found that, in fact, even the biosynthesis and degradation of these two compounds could not be only mediated by one or two enzymes. There was a redundancy of biosynthetic and degrading enzymes. And sometimes the degrading enzymes were not degrading enzymes because they were simply converting anandamide and 2-HG into molecules which had different receptors. And this may seem strange, but not to people like me who have investigated bioactive lipids all their life. All bioactive lipids are transformed into something different and come from something different with a different biological activity. So, and then there is the congeners of anandamide and 2-HG, what we called previously the entourage compounds, which have their own receptors, even though they share with the endocannabinoids the same biosynthetical pathways.
When Dr. DiMarzo refers to congeners, what he's referring to are these compounds that are very similar in structure to endocannabinoids, but that don't interact with cannabinoid receptors. Although these compounds may not interact with cannabinoid receptors, they often do interact with non-cannabinoid receptors that many cannabinoids also show affinity for, like GPR55, TRPV1, the PPARs, and others. Some examples of endocannabinoid congeners that have been more thoroughly studied are N-palmitoyl ethanolamine, or PEA, and N-oleoyl ethanolamine, or OEA. Both PEA and OEA are currently sold in the United States as dietary supplements.
And then finally, there were other molecules which have different biochemical pathways as the endocannabinoids, but are nevertheless, they're not congeners, they're not like cousins, they're not like brothers and sisters, but they're cousins. So you have other N-acyl amides, and in fact, when we collaborated with the other groups, we found that in fact, in particular with the group of Michael Walker, the late Michael Walker, we found that many amino acids could make amides with fatty acids, and this could create an almost an incredible number of new combinations between 10 or 15 fatty acids and 20 amino acids. So just imagine all the permutations, and so these compounds actually exist, as the group of Heather Bradshaw has also recently investigated, and so it's really, we're talking now about a huge number of chemical mediators. So the endocannabinoids, their congeners, their analogs, which may or may have not different similar biochemical pathways, normally have different receptors. We talking about the several other targets that anandamide and 2-AG have beyond CB1 and CB2. We're talking about other enzymes. So we're talking about something about more than 250 chemical mediators, more than 50 enzymes and receptors. And some of these receptors were actually known previously, like the TRP channels or the PPARs. And the interesting thing is that, of course, when the endocannabinoid system became so big, then the next question was, okay, THC is the only out of 100 and more plant cannabinoid that interacts with the endocannabinoid system. What about maybe if we don't look only at the endocannabinoid system, but we look at the expanded endocannabinoid system, at this endocannabinoid, maybe the other cannabinoids will interact with the endocannabinoidome, even though they don't interact with the endocannabinoid system. This is true to a large extent for things like cannabidiol or cannabigerol, the other minor, not so minor anymore, cannabinoids. And in fact, in the case of cannabidiol, even the endocannabinoidome is not sufficient to explain its pharmacology, because it has been suggested to interact also with receptors and proteins outside the endocannabinoidome, not just outside the endocannabinoid system, but even outside the endocannabinoidome. So I think the endocannabinoidome is a complex concept, which, however, has the merit of explaining the mechanism of action of a much higher number of plant cannabinoids than the endocannabinoid system.
Along with talking to Dr. DiMarzo, I also spoke via email with the godfather of cannabinoid science himself, Dr. Raphael Mechoulam. He shared with me that one of the areas of cannabinoid research that has him the most excited is looking at the activities of these endocannabinoid congeners, these compounds that are similar to anandamide and 2-AG in structure, but that are not formally recognized as endocannabinoids. Then there's another piece to this puzzle, and that's the role that non-lipid compounds in the body play in the endocannabinoidome. For many years, researchers assumed that any compound that interacts with cannabinoid receptors must be a fat, because after all, phytocannabinoids are lipids, anandamide and 2-AG are lipids derived from fatty acids. This idea began to change when the concept of peptide cannabinoids, or pepcans, was proposed. Let's talk about hemopressin. Hemopressin is a peptide subunit of the compound hemoglobin, which you may have heard of. Hemoglobin is the molecule that carries oxygen and carbon dioxide back and forth around in your blood between your lungs and the rest of your body. Peptides, in case you didn't know, are chains of amino acids, and these amino acids have nitrogen in their structure, which makes them more polar and less lipophilic. Or in other words, more water-loving and less oil-loving. It turns out that hemopressin interacts with CB1 receptors, and what's more is that hemopressin and peptides like it can reside both outside and inside cells, so they can be extracellular, outside, or intracellular, inside. Well, there are CB1 receptors located not just in the membranes of cells, but also in the membranes of some organelles, like mitochondria. That means that these non-lipid peptides could be interacting with CB1 receptors from within cells. possibly affecting how chemicals like anandamide or THC will bind to the receptor on the outside of the cell. But also, these peptides might be interacting with different components involved in the actual signaling cascade that takes place when CB1 is stimulated. And these peptides might be changing what cannabinoid receptors are doing for these organelles, essentially changing the way that the functioning of the cell itself is being orchestrated. This finding is a big deal. The discovery that hemopressin interacts with CB1 receptors makes understanding the activity of these receptors ever more complicated. Plus, it opens up a new area of investigation. How many peptides interact with cannabinoid receptors? What did these activities look like? I hope by now it's clear to you that what we call the endocannabinoid system is very complicated, and the simplified way that we often talk about it could get us into trouble if we aren't careful. It's really easy to take the simplified idea of the endocannabinoid system and to then try to extrapolate those ideas to predict how a cannabis product might affect someone, for instance. But we really need to stop and take a moment to recognize how much work is still left to be done to understand how cannabinoids affect the body. As Dr. DiMarzo said, it'll be several lifetimes before some of these critical mysteries of the endocannabinoid system and the endocannabinoid dome are understood.
The more we studied it, the more complicated it looked. So I really like complicated things. I like things that can explain in a mechanistic way things from the functioning of a single cell to up to the behavior of a complex organism like laboratory animals and humans. So I still think that we've probably done less than 10% or 15%, and one lifetime will not be enough to study it all.
I want to come back to this concept of the entourage effect. As we heard earlier in the episode, the endocannabinoid dome could be thought of as an evolution of the entourage effect. But it's important to acknowledge that this is not exactly the phenomenon that has become popularized as the entourage effect. And this idea was really not meant to be applied to the cannabis plant. It was reserved for activities that were seen with endocannabinoids and what we now call their congeners. So I asked Dr. DiMarzo what he thought about the evolution of the meaning around this term that he and Raphael Mechoulam coined. Is it fair to say that the concept of the entourage effect has been a little manipulated in popular culture to sort of take on a meaning that is different than what was originally intended?
Yeah, absolutely. I agree. And both Rafi and I wondered sometimes whether or not the entourage idea had not been kind of misinterpreted or misunderstood in many cases, because it has been applied to cannabis and to the pharmacology of cannabis, which is something that for a pharmacologist has really no meaning, because you cannot speak about the pharmacology of a plant. You can speak of the pharmacology of the components, of the chemical components of the plant, and even that is quite difficult to do. So clearly, the entourage effect, as we conceived it, was born to explain why anandamide and 2-AG in particular was accompanied by, in tissues, in blood, in wherever we analyze it, by congeners, by other monoacylglycerols, which at that time were thought to have no receptor. So they were orphan of receptors. Okay, so we wonder, why would the cell make 2-AG together with these compounds, or anandamide together with its congeners, if these congeners have no biological action? That would be a waste of a biochemical machinery. And then, and he said, okay, maybe they're doing something to the main actor of the scene. And I thought that something could be to retard their degradation, because as I mentioned, both the N-acetylethanolamides and the monoacylglycerols can be degraded by the same enzymatic pathways as anandamide and 2-AG. So clearly, they can compete for their degradation by this enzyme. And through this means they can enhance they can prolong their lifespan and then enhance their activity. And this is what we found, and this is what we demonstrated in that paper. But then the concept went on forward, and since for some of these compounds it was really difficult at the beginning to find a receptor, we carried out other different kind of experiments. For example, whether these compounds could act as allosteric modulators of the receptors, and in fact we found that one of them, palmitoylethanolamide, later on we showed would enhance the activity of anandamide at 3B1 channels. So these were really the early times of endocannabinoid research, and then many groups, including the group of Daniele Piomelli and others, showed that in fact these congeners were not inactive. They had their own receptors, and these receptors in some cases did things quite different from the CB1 and CB2, and in some cases things even opposite. So the entourage effect was kind of crushed by this idea, because if 2-AG acts on CB1 and by acting on CB1 stimulates food intake, stimulates fat accumulation, and its congener act on another receptor known as GPR119, which is doing exactly the opposite, there is no more entourage effect at the organismal level. So that was really something to be interpreted for the particular historical situation, and I think it's still valid in some cells. For example, because in all cells these compounds are produced together with their congeners, and not necessarily the receptors of these congeners are there. So when they're not there, maybe, and when CB1 and CB2 receptors are there, maybe they're actually acting as entourage compounds. The situation in the plant where it has been proposed that some terpenoids could enhance the activity of THC or CBD, or that other phytocannabinoids could enhance the activity of THC, CBD, is completely different. And I don't know if there is an entourage effect in cannabis. I don't know whether it explains anything, if there is one. But clearly it's different from what we conceived in the 1990s with Rafi.
What does the endocannabinoid dome mean for clinicians? Does our immature understanding of the endocannabinoid dome limit a physician's ability to help patients address health and wellness issues with cannabinoids? While endocannabinoid research is shining light on many of the structures and functions of the endocannabinoid dome, there still is not a lot of human clinical data available. And sometimes when human trials do happen, the results actually contradict the assumptions that researchers made based on preclinical, in vitro, or in vivo studies. My initial feeling is that, despite the lack of detailed human studies, there is a lot we know about the very basic functions of the endocannabinoid dome that could help clinicians make more informed decisions with patients. After all, we know that cannabinoids and cannabinoid receptors are involved in basic physiological functions like reproduction, nervous system functioning, gastrointestinal functioning, memory and learning, cardiovascular health, and immune system functioning, among others. Just having that very basic understanding can help legitimize cannabinoid treatments and encourage physicians to take cannabinoid medicine more seriously and to pay attention to what their patients are doing more closely. When I spoke to the Drs. Knox, we talked about this issue specifically.
My response for a very long time now is that we have enough information, scientifically speaking, for clinicians who are already trained in anatomy, physiology, and pharmacology to make pragmatic decisions, very practical decisions along with that about what they should be using. It's actually a lot simpler than people recognize. I think as soon as we start talking marijuana, people can no longer compute, can no longer apply. There are years and years and years of education and ability to critically think. And I think that's one of the biggest problems right now. You have more information on the science and pharmacology of cannabis and the physiology of the endocannabinoid system, both when it's functioning normally and when it's dysfunctional, to make good decisions. We do. So, I think, Jason, you hit the nail on the head. Like, we don't necessarily need more and more and more studies. We'll benefit from them.
Right.
We'll benefit from them. They're going to be wholly informative. But we can no longer continue to shun anecdotal evidence as though it's not as important as the data that we can glean from these meta-analyses of these gold standard trials. If something does not work for a patient, it does not matter how many studies have demonstrated that this drug is more effective than the placebo. That's when we're getting into the N of one, right?
Yeah.
That patient's personal story and their personal history provide us the most valuable data at the clinical level that we can use to help make changes to whatever we're recommending, that will direct us, help them make sense of all those products that are out in the marketplace that by and large have not been made to make sense. Like, they have not been made with using science to inform them. And so, it's going to take those of us who recognize that we need to fill a gap to step and do that. And we have enough information to confidently do that. And I get it, not all of our peers in the medical system, have the audacity or the guts or the gusta or whatever word you want to put in there, or the courage to step out on a limb and do it. But patients and consumers are using cannabis now. They're not waiting for the alphabet organizations to get on board. States have legalized it, even in states that haven't legalized it, or finding it. And eventually they're going to come into a clinic or emergency room or, a surgeon's office or surgery. And we healthcare providers are going to need to understand something about the endocannabinoid system and the pharmacology of cannabis without bias. We have to have that foundational knowledge.
In a simple way, one thing that the endocannabinoid dome highlights is the importance of diet. As Dr. DiMarzo said, many of the components of the endocannabinoid dome share similar or overlapping biosynthetic pathways in the body. Specifically, endocannabinoids and their congeners rely on polyunsaturated fatty acids as precursors. Some of the most common examples of polyunsaturated fatty acids are omega-3 and omega-6 fatty acids. Endocannabinoids and their congeners particularly rely on omega-6 fatty acids like linoleic acid to produce N-acyl ethanolamines and monoacyl glycerols. In particular, these fatty acids are usually morphed into the fatty acid arachidonic acid before being further transformed into endocannabinoids or other types of arachidonyl ethanolamines and monoacyl glycerols. If the body is deficient in linoleic acid and it can't actually form arachidonic acid on its own, then arachidonic acid can actually become an essential fatty acid that needs to be supplemented. But generally that's not needed as long as plenty of linoleic acid is in the diet. And linoleic acid is an essential fatty acid. For clinicians, this means that understanding a patient's diet and their metabolic profile may be more important than ever. Even if a person is consuming a diet rich in these important polyunsaturated fatty acids, if they aren't absorbing much from their food, it's not going to do them much good. So even though we don't understand all the details about how the endocannabinoid dome works, there is certainly enough known about it to give clinicians very good information to make informed decisions with their patients in order to actually take advantage of the endocannabinoid dome to influence health. So where are we headed from here? As Dr. Janice Knox noted earlier, one of the areas of research that is particularly interesting involves exploring how the gut microbiome and the endocannabinoid dome are connected. In fact, Dr. DiMarzo shared with me that his current research is focused on just that. In addition to better understanding the role of the endocannabinoid dome in gut health, endocannabinoid dome research is currently focused on examining the roles of endocannabinoid congeners as well as non-classical cannabinoids like cannabinoid peptides to try to understand how they are affecting things. Researchers are also very focused on understanding how changes to the endocannabinoid dome could affect other really large systems like the human genome and the proteome, which is the entire system of proteins involved in physiological functioning. Some preliminary research has already indicated that cannabinoids can cause epigenetic changes to DNA, which then changes the expression of different chemical receptors as well as the production of different types of chemical messengers in the body. Additionally, Dr. Meshulam shared with me that he was particularly interested to see more research to understand how the endocannabinoid dome influences personality traits. Preliminary research indicates that cannabinoids do influence brain phenotypes, and it's likely that endocannabinoids also influence psychology and mental health through their interactions with the gut microbiome. The bottom line is that research is really just getting started. There's a ton to learn, which will ultimately affect the way we think about health and medicine for many years to come. And now, as we begin to wrap up, let's summarize some of what we've learned so far. The endocannabinoid system is a concept that arose in the late 1990s and has grown in complexity. Cannabinoid receptors were discovered in the late 1980s, and endocannabinoids were discovered in the early 1990s. As researchers began to consider more and more chemical receptors and modulators part of the ECS, this new system called the endocannabinoid dome was born. The endocannabinoid dome features hundreds of ligands, dozens of receptors, and a whole host of enzymes, far outpacing the original conception of the endocannabinoid system. Endocannabinoids work locally, affecting the cells and tissues where they're produced. This means that the endocannabinoids can do different things in different places throughout the body, essentially meaning that there are numerous interconnected endocannabinoid systems located throughout the body in all tissues. The endocannabinoid dome appears to be linked to the gut microbiome, and endocannabinoid researchers are now trying to understand this connection to better understand how lifestyle choices like diet and movement can be better leveraged to support health. Endocannabinoid congeners are compounds that are structurally similar to endocannabinoids but do not interact with cannabinoid receptors directly. These endocannabinoid congeners often interact with other non-cannabinoid receptor targets that many cannabinoids also favor, like GPR55, TRPV1, and the PPARs. Non-lipids, like peptide cannabinoids, can sometimes interact with cannabinoid receptors. Because peptides are also intracellular, they can manipulate CB1 receptors in the membranes of organelles, like mitochondria. The endocannabinoid dome is heavily influenced by diet and digestion, as polyunsaturated fatty acids like linoleic acid are critical for forming precursors for endocannabinoids and their congeners. Understanding the endocannabinoid dome can shed new light on the mechanisms associated with various disorders and diseases to drive more targeted therapeutics in the future. The future of endocannabinoid dome research is likely to focus on the crosstalk between the endocannabinoid dome and other large physiological systems like the gut microbiome, the human genome, and the proteome. Future research is also likely to explore the role of endocannabinoid congeners in cannabinoid activities, as well as how the endocannabinoid dome influences things like human psychology and personality. But we're really just scratching the surface here. As the mysteries of the endocannabinoid dome unravel, it is sure to dramatically affect drug development and modern medicine. Already, insights about the endocannabinoid dome are changing the way we think about immune system functioning, the gut microbiome, human psychology and personality, and more. You can also rest assured that as we learn more and more about the endocannabinoid dome, there will be companies ready to manipulate those understandings to sell you more stuff.
Extraction Jackson, what's that fraction?
Welcome to What's That Fraction, the game show where we take a look under the hood at the dabs that you dubbed good. Extraction Jackson, come on down and tell us, what's that fraction? Woohoo! Yes, well, what we have here is some full-spectrum Delta-8 THC distillate. Ooh. Converted from high-quality, ultra-pure CBD sourced from hemp. Federally legal, you know. Ooh. Our product is only what you want and none of what you don't want. Ah. Just the cannabinoids that we chose to purify and the terpenes that we chose to add. Full spectrum.
Oh my goodness.
Okay, Jackson. Well, let's take a look at the lab results. All right, Jackson. This says that your extract is 70% delta-8 THC. Okay. 75% total cannabinoids. Okay. And 10% terpenoids. Wow. But Jackson, what else is in there? You know, our scientists and myself believe it's just flavonoids or some miscellaneous waxes that get in there, because after all, this is a full spectrum distillate, mind you. But you know, most labs don't test for all that other stuff, so we don't really know exactly what's come on through. So there's really no way to get any more data on it. Really, all you people should know is that we use the best extraction and refinement methods to produce an incomparable full spectrum extract, fortified with whatever cannabinoids or terpenes you desire. All right, Jackson. Well, let's take a closer look, shall we? We're going to the raw data! Excuse me, what? No, you don't have to. Uh-oh. Jackson, what's this on your chromatograms? Look there, right beside the delta-8 THC peak. What are all those other peaks? They're huge. Oh, well, you know, like I said, it's probably flavonoids, you know, or, you know, they get concentrated in our refinement process, so it would make sense you'd see something like that on there. All right, Jackson, well, let's take a deeper look, and let's check the reference standards. What? No, I don't know what that is, but you probably should, don't do that. Jackson, have you been pulling our legs? Well, I don't know what you mean. Nope. Jackson, that doesn't look like flavonoids. Well, you know, it is possible, you know, that from our process there might be some unknown chemical byproducts. Jackson, uninvited guests at the party? Okay, look, I'm sorry. Look, we're still trying to figure all of this out, but it's good. Try it. It works, please. I mean, we have to move it anyway. The market keeps changing, and everyone's now talking about CBG and CBN and CBC, and DEA is talking about shutting down Delta-8, and we're just trying to keep our heads above water, man. I mean, just look. We'll call it whole plant. Will you buy it then? Oh, what about this? My chemist informed me that the whole extraction and refinement process is totally organic. And I almost forgot. We only formulate with molecules that may or may not have once existed in plants. Oh, yeah. No, we're not playing around here. We may tinker, but our products are all natural, full spectrum, high quality products, I assure you. With some, unknown ingredients we may have made accidentally. I'm sorry, Jackson. I don't even think this is an extract. And it's definitely not the fraction we're looking for. Try again next time on What's That Fraction? What's that fraction? When we cut through the marketing terms and all of the buzzwords, what do you really know about cannabis extracts and concentrates? There are several primary ways that most extractors use to pull chemicals out of the cannabis plant. Some of the oldest and simplest forms of cannabis extraction involve simply sifting the cannabis plant over screens to collect the resinous trichomes that hold most of the cannabinoids and terpenoids. This method of dry sifting produces a product that many refer to as keef. It's a powdery consistency and can be pressed together to form hash. Contrary to dry sifting, there is also wet sifting, which produces a product commonly referred to as bubble hash or water hash.
Anyone that's ever seen a cannabis plant, you've seen that it's got this frost on it. Some people like to call it the crystals. Some people call it the THC, even though that's not really accurate. What it actually is called glandular trichomes.
This is Marcus Bubbleman Richardson, who was largely responsible for popularizing bubble hash in the late 1990s and early 2000s.
These little crystals are little mushroom-like creatures. They have a stalk and they have a little head on the end of them. Inside that head is where the magic happens with cannabinoids and terpenes. And so bubble hash is really just those heads broken off. And I'll give you a little explanation. So inside that head, we have things called organelles, two of them on either side. You have a plastid and a vacuole. Plastids produce phenols, which are alcohols. And the vacuoles produce hydrocarbons, which are terpenes. So these hydrocarbons and phenols push up into the upper membrane of this little globe, and they basically start synthesizing CBGA with the help of UVB and probably some other things that we're not even aware of at this point in time. So all of the compounds, all of the cannabinoids, which is THCA, CBDA, CBGA, there's a lot of them. You can look them up, as well as the entire terpene profile. And there's upwards of 180 of those, from humulene to terpenoline to alpha-pinene to myrcene and beta-caryophyllene, which is the one that drug dogs were always tested in because it's often a dominant terpene, very peppery and very, very noticeable to a dog's nose. So those little heads are where the magic occurs, where the medicine is produced. So that wax membrane holds it all in place. Bubble hash is basically, and you can do this at home, you could take a little bud, you could put it in a glass of water with an ice cube or two, you can kind of shake it up, break that bud up, shake it all up, and what'll happen is the little resin glands will become very brittle in the cold. That wax makes them very brittle. It'll break off right at the neck where the head sits at, which is the most easily broken area. It'll break off, and due to the density of the trichome head and the fact that it's oil-filled, it's still affected by gravity and water, and that's really the magic of bubble hash. So those little glandular trichome heads sink in the water while everything else stays afloat, and then we just pull micron screen bags accordingly. First one pulls out all the flour, the second one pulls out, some contaminant, and then you start getting these different gland heads at different micron diameters. So that's really what bubble hash is. It's the medicinal components that are, produced by the plant in these glandular trichomes.
Another mechanical way to extract chemicals from cannabis involves squeezing the plant material or a cannabis extract and collecting the resins that ooze out of the squeeze. This is usually done under heat so that the resins melt and pour out during the pressing so that they can be easily collected. This method of squeezing or pressing cannabis under heat to collect its resins is called rosin production. Now, beyond the mechanical methods of extraction, there are chemical methods which utilize various types of solvents to grab the fraction of the cannabis plant that's desired, or in some cases, to grab the fractions that aren't desired and to remove them. Of course, everyone seems to have a different definition of what's desirable, what extraction methods are best, but we'll come back to that later. The simplest form of solvent extraction is probably the use of food lipids like butters or plant oils, which can be used to extract the resins from the cannabis flower before using the infused lipid in a recipe. Think about like cannabis-infused butters, for instance. Because cannabinoids and terpenes are lipophilic, or oil-loving, they mix well with other oils and fats. And this plays into the chemistry involved in the use of other solvents, which we'll talk about later. Beyond food lipids, there are a variety of different chemical solvents that can be used to extract cannabinoids, terpenoids, and all sorts of other plant compounds. Last year, I connected with Dr. Wyeth Calloway, an organic chemist working on cannabis extraction method development. During the conversation, he described the primary differences between extraction methods that are commonly used in the cannabis industry.
Cannabis extracts would start with the crazy days when people were taking glass tubes, filling them with either nugs or, cannabinoid-rich trim, and blasting them through with these cans of butane. And so the butane will pick up the cannabinoids and the terpenes, and out at the end of this glass tube comes this mucky stuff brown stuff, which they're going to purge the butane out and get a cannabis concentrate.
Right.
So that's hydrocarbon. Nowadays, you have these closed-looped extractors, which simply means that the cannabis is loaded into these tanks. And what will happen is hydrocarbon, butane, propane mixes, isobutane, everyone sort of has their recipe, will be flushed through these tubes containing, the biomass. And imagine this whole apparatus is stainless steel. It can tolerate very high pressure. And as you flush the solvent through each of these tubes, you're going to eventually bring it over to something called a honey pot. And before you do that, you're going to purge the butane inside the system, and it's going to go back into this moving reservoir. So the butane is, or the hydrocarbon is recycled. People really like it because you can do the extraction in low temperatures, and you can help eliminate a lot of the waxes that are in the plants and get a lighter, very good-looking terpy crude. And all you have to purge is hydrocarbons, which are really low boiling. So you can do these in warm vacuum ovens, get rid of all the hydrocarbon, and you can use it as a raw concentrate, or it can go on further to further processing, be that distillation or some kind of winterization, or make diamonds out of this extract. The next method, it would be supercritical CO2. Roughly speaking, you're going to pressurize CO2 gas inside of it's also a closed stainless steel extractor. You're going to load your biomass again in these socks and inside a tube, and you're going to pressurize the CO2 until it's a liquid. Because you may or may not know, but in normal conditions, dry ice doesn't become a liquid. As it melts, it becomes immediately a gas. So the CO2 is roughly a decent polarity to pull cannabinoids. There's a big debate on conditions and whether you use cold solvents or not. I can't really speak to that, but the extracts tend to have more wax in them. If you don't remove the terpenes, the process of getting the material ready for the CO2 extraction will destroy the terpene profile. Advantage of this, it's eco-friendly. You're only using CO2, and as opposed to hydrocarbon, where you have to do really good purge to get rid of all the butane and propane, isobutane. On the other hand, so we have more waxes. Unfortunately, the machines are fairly slow, and you have to operate at very high pressure. But you will see people still using these. In fact, in hemp, it's one of the interesting ways to go, because it can be operated under what's called the Type 6 license in California without volatile solvent. Last but not least, and this has become sort of the giant of the industry, is ethanol extraction. Ethanol is not a very selective solvent at room temperature, and it'll pick up more plant matter, chlorophyll, waxes, probably even some of these fatty acids. And you get a really, really soupy, hard to deal with mixture when it's time to cool it down and filter it, and just try to get the cannabinoids alone. We had to use carbon scrubbing to get out the chlorophyll, a lot of processing with ethanol. Now what people figured out was, hey, well, why don't we do this ethanol at a very, very cold temperature, at the temperature you're going to do the so-called filtration winterization step? Let's just go ahead and skip a step and do the extraction at those temperatures. So the advantage of ethanol is you can do a lot of it very quickly. Disadvantage, you have to remove a lot of solvent very quickly. Use a lot of solvent to do these extracts. And you can also have difficulties with maintaining terpene profiles. In the past, a lot of people have gotten around this by adding plant-derived terpenes. So, with the goal just being to make as much drugs as possible. So, ethanol throughput and I would say ease of use of the equipment. The whole process is fairly easy to put under stainless steel, make one continuous process.
Mm-hmm.
So, there you have it. I would say the majority of large producers are going to ethanol.
But how does someone decide what extraction method to use?
So the first question that everyone has to ask themselves is, what do you want to make?
Yeah.
Your end product is really important. And a really quick and easy way to simplify that is, does your final product need to have the original terpene and flavor profile from the plant? Yes or no?
This is Murphy Murray, a cannabis educator and botanical extraction technologist.
And, a yes to that answer means that you're looking at CO2 or liquid hydrocarbons. If it's a no, then you can look at CO2, liquid hydrocarbons, or potentially ethanol or heptane or, some of these other products. The other question you have to ask yourself is, what type of cannabinoids are you looking for? Do you need the acid form? Do you need those, crystalline solids? Or are you looking for a decarboxylated product? Because certain extraction methods are also more likely to give you one or the other. And so those two questions will usually shorten your list right away. And so from there, ethanol is one of the best solvents suited for scale currently. And the reason for that is that so much ethanol extraction already exists in other industries. It's considered food safe. Yeah. And so there are, regulations and equipment in place that we can just straight up copy and, put into effect for cannabis. However, the boiling temperature for ethanol and, its interactions with water are really problematic, especially depending on the qualities of your inputs. And so you lose terpene content almost no matter what. And you are also at risk for some degradation and some pH issues, extraction of undesirable compounds like sugars. And so there's a lot of things to consider that are going to lead you to, first of all, a decarboxylated product, but also more than likely an isolated product. It's going to be harder for you to have a clean oil that doesn't call for a lot of post-processing and cleanup.
Yeah.
And so, the drawbacks are, definitely very chemical, but the benefit is that if you want to process 5,000 pounds or more per day of raw material, ethanol is your current best option. However, that 5,000 pounds that you extracted that day isn't ready for sale that day.
Right.
It's still in solution, most likely.
It's a big picture.
Exactly. So, there's still more days in that final product production end. Mm-hmm. If we look at CO2 is a very complicated product because CO2 is a flexible solvent. Mm-hmm. It relies completely on the operator and the equipment having a plan and sticking to it. And so CO2 is capable of being an excellent solvent for terpene extraction. It's also capable of extracting a lot of water and wax and nonsense, just depending on, how that equipment is used and how efficient that process is. A lot of people decarboxylate their material, like you mentioned, to avoid the water issues, which means sacrificing terpene content, which is a bummer because CO2 is capable of doing probably one of the best jobs with terpenes as far as solvent extraction would go. But, it comes generally with the cost of still requiring winterization in ethanol. Yep. So I tend to put CO2 and ethanol together because whether you make your crude with ethanol or you make it with CO2, you probably are going to be following the post-processing path. That's the same either way, which would be that winterization and filtration, and then probably, most likely, distillation.
Right. Yeah.
And the exception to not going to distillate is usually still just to be in that raw oil form. So maybe you might not distill, but it's still only available for pens or for, food. It's still not, it's still a limited product as far as what you can do with it.
Yeah.
And so hydrocarbon is a lot more flexible in that regard because while it is a very small input batch size, we're doing, 500 pounds or less per day in the average lab, which is not massive scale. We're not going to feed the world with that. However, I don't have any of that week-long post-processing that follows it up. So while I might only get to process 500 pounds that day, I could sell the oil that I made that day the next day. Which is, a big difference. And it's something that, we often skip when we look at our production plans is, how many, like we think about how much can this equipment do, per pound, per hour, whatever. But we have to bring it all the way back and say, okay, well, all of this equipment in a straight line is going to take how long from raw material to packaged and for sale?
Exactly.
And hydrocarbon is absolutely the fastest for that. Butane and propane evaporate at very low temperatures, which means we get the acid form, which means I can go to Delta 9. I can distill it. I can make a tincture. I can make edibles, or I can make all of these other things that I can't do as easily or as quickly with CO2 or ethanol.
Yeah.
So that that post-processing flexibility is the primary advantage there. It is, however, combustible.
Yeah.
And so, with ethanol, we have the flammable issue. And with CO2, we have the high pressure issue. With the liquid hydrocarbons, we have both.
Yeah.
So, the risks are significant, and the risks are only mitigated via equipment and safe workspace. There's no safe way to just be careful, and statistically speaking, for everyone who is going to listen to this and think, well, I've been doing it for years. Statistically speaking, the more days you've gotten away with it, the closer you are getting to the day when you won't. It will come. And so, the safety risks are significant because it is combustible in nature.
Yeah.
However, it is a clean extraction method. Butane and propane don't dissolve mold. They can't carry over, water as easily. So the final product, because it's very easy to remove the solvent, and the solvents are food safe, and our exposure to them is generally non-toxic. They're very safe products. Whereas with ethanol, high levels of residual ethanol can certainly be harmful, especially for oral ingestion. And, that high level of water content in a lot of CO2 products can lead to microbial growth. And so we have, some pros and cons both on the processing side as well as for the actual consumer. Because if I need a product that can store for a very long time with limited degradation, a hydrocarbon extracted product probably has a better shelf life than an ethanol extracted product or a CO2 extracted product based on literally just their moisture.
I spoke with Dr. Daniel Hayden from Extractioneering about the chemistry of the extraction process. Extractioneering utilizes a co-solvent process to overcome some unique challenges with typical solvent-based extraction systems. They're best known for their carbonated high cannabinoid and high terpene full-spectrum extracts, and they claim to be one of the first companies to use the term full spectrum to market a cannabis extract.
When I come up to this problem in cannabis, when I got done with academia and government and everything, it's a problem right in front of me. It's a separation problem that needs buffers. And so certain things work better than others. You have CO2. So CO2 doesn't have a hydrocarbon equivalent, although it comes from the industrial gas complex. Impurities could be added to CO2 just like any hydrocarbon, right? And so, but you have to bend CO2 in a few different directions. You say, I want a heavier molecule, I want a lighter molecule. In the end, I'll put them back together.
Yeah.
And so Humpty Dumpty got put back together again. It never, as I extract biology in my life and my career, I could not reassemble complexity in the reverse direction.
Yeah.
To any meaningful extent.
Yeah, I mean, that's a common issue in herbalism. I mean, going back to old roots of alchemy, and I don't want to deviate too much because we'll get to this, but this ties into the concept of full spectrum and everything. And this concept that a lot of herbalists have been chasing down for a long time is how do you capture the plant essence in basically a liquid form, essentially. And the most common way is taking all different parts of a plant, extracting it, trying to mix it back together. But to your point, when you do that and you mix things back together, you tend to find that things have changed, regardless of the ways you've tried to control them.
Yeah, cannabis presents the most complicated example of all this. If you want to extract salicylic acid from willow bark, I mean, it's right in front of you. You just remove everything and you get the one water-soluble compound.
Yeah.
And it brings down your inflammation. It takes your headache away.
Yeah.
But when you're talking about cannabis, it's incredibly complex, and oxygen, everything kind of affects what's happening there.
Especially with terpenes that are very, very sensitive to oxidation. And
we want that complete resin. You toss everything else out. I'll get my chlorophyll from somewhere else. I'll get my antioxidants from somewhere else. I'll get my proteins and my starch. I don't need this stuff from cannabis. I want a bioavailable cannabis product that I can use in an administrated way, which is a vapor, that works best for my chemistry and evolution species, right? So what I find throughout all my extraction and scientific knowledge is I've seen things come together and never be able to come apart again based on the chemistry you're using. And I feel a lot of that is happening in cannabis concentrates today.
What Dr. Hayden is describing here is a process called polymerization, where individual molecules start to join together, stick together to form long molecular chains. And this is actually really important because bigger molecules are more challenging for the body to break up and process, and polymerization leads to a lower bioavailability of things like cannabinoids and terpenes. Essentially, if an extraction process ends up leading to polymerization of these molecules, you're essentially losing access to them when they're consumed.
They polymerize with substances on the exterior of the leaf and what's trying to be protected on the interior of a trichome, lock it in place, and then when you go to vaporize it, almost like boiling water with salt in it, you're just getting these strands of glops coming flying at you, and the THC works just the same. You say like this to the product, it works, but you want all those things individual. So when they vaporize, you want them all individual, and so you can once your sensors and everything can get in there, and they can all get into your alveoli and in your bloodstream as individual molecules. It's just that little bit of extra, and it is found in chemistry and understanding. And so there is proprietary parts of it. So we're working a lot with a combination of CO2 and butane. And what we found is that CO2 is the perfect co-solvent. So what it does is it gets into the resin, and all the parts that would polymerize or attach or oxygen would affect the resin. We charge it with a CO2, like you would carbonate a beverage. And then we run the extraction, and with our sequence, we understand that the CO2 keeps it together, and it eschews like the butane in the solvent, and keeps its terpenes and all its complexity folded together. And then when we relax it and let it release, it unfolds and burps and effervesces, and all those CO2 kind of come off all those oxygens and those double bonded areas, and then you can really start to taste all those molecules start to kind of unravel. So in a sense, we protected all the molecules during the extraction. And at the end, there's no wax for them to lock together and to polymerize, and now you're able to pick it up and dab it, and the vapor, you're able to taste kind of each one. And we would hope each one would get into the bloodstream individually and have all the effects it's supposed to have.
Another method that's a bit newer on the scene for cannabis extraction, but that's gaining in popularity, is extraction using tetrafluoroethane, or R134A. This is a chemical most commonly used as a refrigerant, which I know at first might sound a little weird, but this compound, tetrafluoroethane, can be used as an extraction solvent. And supporters of this method usually claim that extraction with R134A can be performed at lower temperatures and lower pressures compared to other extraction systems without needing much, if any, cleanup or post-processing refinement. Very few of the extractors that I've talked to over the past year or so for the podcast had much experience using this refrigerant as an extraction solvent. So we'll come back to this method in another interview or in a behind-the-scenes episode to talk more about it. Don't worry, this isn't an ad. I just wanted to insert a brief intermission here to give you a chance to take a break if you need to. We're halfway in, we've got 30 minutes to go. If you need to pause and come back later to finish, this is a really good stopping point. Otherwise, I'll catch you back in the episode in a few seconds. Take it easy. So earlier I listed some of the many names of different types of cannabis extracts or concentrates. But what determines the difference between all of these products? Like what sets a wax apart from a shatter, apart from a sauce versus butter, batter, or pull and snap?
For a lot of cannabinoids, the acid form and the decarboxylated form of that cannabinoid have different physical states. So, for example, THCA is, a solid, colorless, crystalline product at room temperature, whereas, Delta 9 THC is, a colorless liquid at room temperature. And so that's a big difference in consistency. So if my concentrate is mostly THC Delta 9, I'm going to get sticky liquid because Delta 9 is a sticky liquid. But if I've got mostly THCA, I am going to have a primarily dry solid. And so, that first differentiation in ratio of, THC versus THCA or, CBD versus, THC makes a big difference in, just the potential consistency that I've got in front of me, especially because I don't want to say decarboxylation can't be reversed, but generally we're not going back from that. So once we have crossed into that decarboxylated state, once I've got CBD, I've got a solid. Once I've got Delta 9, I've got a liquid. And so the hydrocarbon extraction process allows us to play with that texture a little bit more because we can start with a dry product and go liquid or not.
Yeah.
So that already makes a big difference. It's just the dominant compound in any given solution is going to dictate, the structure that it takes on. Then from there, we have, the other minor groups that are involved. Now, hydrocarbon extraction is also excellent for terpene extraction because it happens at low temperature, so we don't destroy them, and they're soluble, in butane and propane, so we're able to capture a lot of them. We also have the added benefit through hydrocarbon extraction of being able to extract wet or fresh frozen material because it doesn't take on water content in the same way that 5,000 psi worth of CO2 or any given amount of ethanol will. So we have, the potential to not only extract more terpenes because they're compatible solvents, but also because we can capture terpenes from the plant material before it has dried out, before those have changed, before those have evaporated. And so that terpene content is mostly liquid. Some terpenes are solid at room temperature, but mostly we're dealing with liquids. And so the amount of terpene content in any given hydrocarbon extracted product has a huge impact on that liquid versus solid situation because those terpenes can dissolve that solid cannabinoid.
Yeah.
And so why we might have 90%, solid THCA cannabinoid content, we might still have something that looks half liquidy because those terpenes can actually dissolve quite a bit of it and keep it in solution. So, that recipe gives us a lot of options. And that's just based on what it contains, regardless of what I might do to it. If I just pour it out of my extractor and here it is. Then from there, because we have that acid form, because we have some of these solids, we have the potential for crystallization. Or, in the opposite route, we have the potential for, an emulsified or homogenized product. And so, shatter, wax, butter, those kinds of things are generally homogeneous products. Shatter is everything mixed up and, solid and flat, whereas the butter and the wax is everything whipped up and actually aerated. But in either case, basically the same original content, which is way more THCA than that liquid terpene content, which allows it to be, dry rather than wet. And then from there, it's just, how we play with it. It's at that point, it's kind of how do you take your eggs?
Once an extract is made, it usually is not ready for retail quite yet. Most extracts go through various forms of cannabis refinement. The most common form of refinement is winterization, where an extract is cooled so that heavy fats and waxes will precipitate out of solution, and then that solution is usually poured over a filter where those heavier components are captured and the resulting extract comes out more pure. But there are other forms of refinement, like distillation, and a controversial process called CRC.
Like anything new in cannabis, CRC comes with its own made-up name that people in the cannabis industry developed to use for its specific application within cannabis. So it stands for color remediation, column, or cartridge, generally. And that color remediation part of the phrase is the important part, because that's where everyone gets really hung up. And I say everyone because I mean everyone. The scientific community is going to criticize color as a remediation target, and the layman is going to criticize that as well, because it's not a very clear. Oh, that's a good pun, right? It's not a very. It doesn't help explain what it is. It just implies remediation, and remediation is a word that we don't like as consumers. We don't like hearing that because it implies that something was wrong to begin with. The motivations behind it are often what causes a lot of the scrutiny. In the same way that everyone was very critical of distillate. For a very long time, and even still today, to be honest, because it implies that we're taking something that isn't good as is, and we're making it look better without actually being better. Is kind of the real frustration that people have, is that if all we've done is change the appearance, then that's not quite a good enough improvement. However, changing the appearance can't happen without also changing the product in some way. But what people mean by that is to remove some of the most well-known compounds that are accompanied by pretty common colors. And so the first category of that is going to be, things like anthocyanins, xanthophylls, tannins, a lot of these like plant metabolites, these compounds within the plant that are not the oh no-nos like chlorophyll that we just all agree like green is bad, brown is bad. Some of these others put you in the like honey color, the copper color, the bright reds, the deep red, somewhat pale pink sometimes, Then you have things like carotene where you get that like bright orange. And so these are a lot of compounds that we know are in cannabis, we know are in other plants. And so we know about these compounds when we isolate them from other plants or when we use them within other plants. And with cannabis, we have all of these compounds that we want to associate this really important value to. Like these are the active ingredients, right? Because they're either psychoactive or relevant to your experience in one way or another. So we've picked like certain terpenes that we think are good, we haven't made a good list of terpenes that don't play a relevant role or that might be bad. But then we've looked at things like canaflavin or like certain flavonoids, certain individual compounds, but we really pick and choose off of that board based on the evolution of our research and the demands of, consumers and kind of just the trends in the way that we consume these products too, And so in that way, trying to remediate one or more of those compounds can give you wildly different results. So just removing anything that happens to reflect the color red might not have a very significant impact on the way your product tastes. But if you remove everything that reflects the color yellow, it will for sure, because you've got some compounds in there that are yellow that have a notable flavor. And these are flavors even more so than like terpenes or smells, right? So these are things that contribute to that like mouthfeel, to what you experience on the exhale. And those are really interesting compounds because those tend to be what we look at when we're trying to capture like the experience of smoking the joint in a dab, right? Some of those compounds don't translate over, either because we didn't extract them or we degraded them in the process or we filtered them out one way or another. So when people look at CRC, there's not one compound that we're saying is being removed. It's not like saying pesticide remediation where we're saying there's no pesticides now and everyone feels good about that. It's not like saying de-waxing where we're saying now there's not waxes and so everyone feels good about that. We're saying a big mystery category that we have not identified nor quantified has been removed, maybe, probably. Can't be proven because we can't identify or quantify these compounds. And then what you end up with as a consumer is just a visual change that represents any number of like actual physical changes in terms of what molecules were removed. And so when you look at a clear product, that is going to indicate generally more isolation, not a single isolate necessarily, but a higher purity of whatever compounds are there. And the whatever part is important, right? Because waxes can be white and chalky and dry. And that can be easily mistaken for ground up THCA powder, which appears chalky and dry, but is in fact a denser, more crystalline structure, right? And so that's the difference between looking at sugar versus flour. Because if I take sugar and I grind it up into powdered sugar, now I'm looking at powdered sugar and flour, and it's a little harder to tell the two apart. You can, but you got to get in there, right? You got to be familiar with that product already. And so for the average consumer, a scoop of dry wax is going to look almost the same as a scoop of dry THCA. However, the experience is going to be wildly different. So this particular method of this particular process is column-based, which is an important feature of it, especially from that chemistry perspective, because it is all a variation of chromatography, generally a solid phase chromatography. And so the way that you apply that is really important. And we've already established that the goal of the process is unclear, which within traditional chromatography would not really be acceptable. All chromatography is about, putting a sample in and separating it into major components. And so when it's something like pesticides, we're going to use a column and we're going to use a media that is very appropriate based on its lack of compatibility with the solvent and its, affinity to those particular pesticides to keep the pesticides in the column moving slowly and keep everything else in the solvent moving quickly. And so we choose our solid phase or that base, that media, the powder, based on what we want to remove. And then similarly, we also choose a solvent based on what's going to work really well with that solid phase pairing. And so, that whole chromatography theory is a very relationship-oriented theory. It is the media versus the solvent plus the oil. How do we do it? And the CRC approach, we've already chosen our solvent. We're keeping it in the butane-propane combination we already extracted with. So instead of having that variable that we choose with intention, we just say, here's our solvent, which is fine. Yeah, that's fixed. That's what our liquid phase, our mobile phase is going to be all about. And now we go in and we look at our solid phases, right? And so this is where things get really complicated because our chromatography media, things like silica, things like alumina, there's a million different kinds. There's like imprinted beads now that are targeted to an individual molecule, right? So that means that there's a different type of media or powder for literally every molecule individually. And then there's the media that are for more than one of those at a time in every shape and size, in lots of different levels of purification or quality control. And so the differences in those media are really important based on their industrial applications.
After talking to Murphy for nearly 2 hours about CRC, it became very clear that CRC is not a single thing, even though we often use that phrase as if it refers to a single thing, a single process. But in general, it's just a phrase used to refer to various widely different methods of column chromatography, often with very undefined quality parameters or molecular targets. So far, we've talked about how cannabis extracts are made, but let's change gears a little bit and focus on a different question. Are cannabis extracts, or dabs, safe? The safety of cannabis extracts is kind of complicated. First, there's the issue of contaminants in extracts, which can be unique compared to contaminants in cannabis flower, for instance. Without proper quality controls in place, extracts can be produced that feature any number of contaminants, sometimes in very high concentrations. And these contaminants can be things like leftover solvents, possibly even clays or silica. Sometimes there are chemical byproducts formed during the extraction or the refinement process. And also, the process of concentrating cannabis resins can also concentrate certain contaminants like pesticides or even mycotoxins. Next, there's the problem of additives, which are intentionally added to a cannabis extract for one reason or another, but usually in order to give the extract a particular consistency. Some of the additives you might find in cannabis extracts include things like MCT oil, vitamin E or vitamin E acetate, squalene or squalene, propylene glycol, just to name a few. And there's also an issue primarily affecting black market extracts, and particularly black market shatter, where pine resin is being blended with cannabis extracts to dilute them. And some of the compounds in pine resin are very toxic to the lungs. But let's say you have a clean extract. There's another problem: the hardware. A recent study found that vaporizer pens that feature nickel-chromium hardware can cause intense respiratory symptoms that mimic those seen in the recent vaping epidemic of 2019. Metals, glues, and other compounds can leach into cannabis extracts depending on how they're housed, and that can cause contamination well after the fact. So even if a cannabis extract is clean, if it goes into bad hardware, it can still become contaminated and cause safety problems. Finally, another element that influences the safety of cannabis extracts is the temperature used to vaporize the extract. One study found that when cannabis extracts are heated at high temperatures, there are toxic byproducts like benzene that can be formed from the terpenes as they break down. But assuming that an extract is clean, that it's housed in adequate hardware, and it's heated at lower temperatures, are dabs safe? Well, the truth is that while smoking or vaping a dab once in a while is probably not going to hurt you, we really don't know anything about long-term chronic use of high-potency extracts over, let's say, decades. I mean, really, most people have been exposed to these things for maybe a couple of decades. A lot of the cannabis extracts like butane hash oil or even like bubble hash really started to hit the scenes in the early 2000s, at least to the level of popularity that we know them now. So they haven't been around long. So there's a lot we don't know. We don't know how, let's say, dabbing every day for decades is going to affect someone's health. In general, it's probably not a good idea to heat plant resins and inhale them in your lungs. But of course, we know that safety and health and wellness is not quite that simple. Now, you might be thinking that one of the benefits to cannabis extracts is that because they are more potent, that would encourage people to actually use less, and maybe they would be safer than smoking something like flower that has all sorts of other chemicals in it. Generally, people are smoking it, not vaporizing it, and that sort of thing. But this doesn't really seem to be what is happening, at least not in large part. Find the dabbing community on Instagram, and you'll be bombarded with videos of people proudly dabbing ungodly amounts of cannabis extract at once. There are challenges where people try to smoke as much as a gram or more of a cannabis extract all at once. And let's just say a cannabis extract is, to be kind of conservative, let's say 60% or 70% THC. That would be around 700 milligrams per gram. So if you're trying to dab a whole gram, you're essentially taking 700 milligrams of THC at once, not to mention all of the smoke exposure and that sort of thing. So it's not necessarily true that people are smoking less because they've moved on to cannabis extracts. And I can tell you from personal experience in workshops that I've taught and communicating with people that consume cannabis extracts every single day, there are tolerance issues. And a lot of times, what I hear from my students that engage in these activities is that once they've switched over to high potency extracts, the level of tolerance that develops makes it very difficult to cut back or switch back to cannabis flower or anything less potent. And so that in and of itself is an issue because it's driving people to consume more and more, which may not be having positive impacts on their bodies in a lot of different ways. I mean, we know that chronic cannabis use does cause changes to the brain. It does change the way the endocannabinoid system functions, and we know the endocannabinoid system is tied into pretty much every other physiological system in our bodies. So constantly manipulating it may not be the best thing to do. Chronic cannabis use can lead to a downregulation of cannabinoid receptors and endocannabinoid production. It's also possible to develop things like cannabinoid hyperemesis syndrome, where there's a dysregulation of communication between cannabinoid receptors and other types of receptors like TRPV1 receptors that causes these really interesting physiological changes that makes people feel nauseated. There are negative effects associated from chronic cannabis use that can be experienced, and it is definitely possible that with cannabis extracts, you might experience those effects possibly more easily than you would with flower. We really just don't know, and that's what I really want to emphasize, is that we don't know. Before we wrap up this episode, I really want to directly address a very confusing set of terms related to cannabis extracts. And these include the terms full spectrum, broad spectrum, and whole plant. Perhaps you've noticed these terms on the packaging of a cannabis product. They're especially prevalent in the hemp market for CBD products and CBG products. The problem is that there's no standardized definition for any of these terms, which effectively allows any producer to claim anything they want. Here's a clip from a conversation I had with colleague and herbal scientist Travis Simpson, where I ask him how he feels about the use of these terms.
When I think of full spectrum, I am unfortunately jaded in the sense that it has been taken advantage of by commercial marketing techniques to really articulate product advantages over isolated products. Herbalists have been doing this for a very long time, trying to get the most therapeutic profile out of a plant, which has to do with multiple parts of the plant and then multiple preparations of those different parts of the plant. And within the cannabis and hemp space, the primary processing is done on aerial parts, leaves, some stems, mostly flowers, very infrequently, but sometimes seed will get its way into some of the extracts, and those lead to end concentrates that have a greater chemical diversity. But in the full spectrum conversation, it's very important to identify what spectrum it is that we're referring to.
Yeah, great point, yeah.
Because within a spectrum, that can be on the platform of, say, the whole plant. And we know the cannabis plant has therapeutic properties within the roots, primarily sterol constituents.
Like campesterol, beta-cytisterol, I think is one of them, yeah.
The stilbenoids are a powerful class that is outside of the spectrum of full spectrum oil.
Right.
Because we eliminate root tissue in most modern extraction techniques. So when we talk about full spectrum, it can often refer to either a cannabinoid spectrum, a terpene spectrum, or various degrees of pigments within a concentrate. Most people would agree that a distillate is not a full spectrum, though some people market distillate as a full spectrum cannabinoid profile, being that they are not isolating out any of the individual cannabinoids from that total cannabinoid process.
Full spectrum is a marketing term.
Yeah.
Unless they go out and define certain levels, you'd have to go back to the flower or go back to the biomass and say, I have X% of minor cannabinoids. In my extract, I am going to represent those minor cannabinoids at a certain level, and I'm not going to lose any of them. If you want to talk about flavonoids, if you want to talk about, what else am I thinking? Let's just leave it as flavonoids right now, because that's a buzzword for everybody because of the potential anti-cancer properties of canflavin.
Yep.
You need to show that with analytical work, not just saying, "Oh, my extract is mild." I don't know any testing lab that's testing for flavonoids. There may be. So until there's an accepted definition of what is full spectrum based on what you're starting with, it's a marketing term.
And what about this underlying assumption that full spectrum or whole plant extracts are best? This assumption is primarily based on anecdotal reports and very limited in vitro and in vivo rodent research. To date, there is very little controlled research that has investigated how different components of the cannabis resins contribute to effects. While it's clear that there are modulatory effects happening, how much of the plant's chemical spectrum are needed to drive these effects, we just don't know. The entourage effect, as we commonly talk about it today, is actually a far cry from the intended meaning when it was originally proposed in the late 1990s. I'll close out this section by going back to our conversation with Marcus Richardson. I've really noticed these terms get really popular over the last 5 years, 7 years or so, where they're like really, everyone's really talking about it and blended it into their branding. So what's your perspective on that?
Well, it's pure marketing, and it's come from our conversations on Hash Church. There's absolutely no doubt. You called the timeline to the perfection. Keep in mind it was Skunkman Sam who was the one who discovered the modality, the modulation effects of terpenes. He did it in 2000. He hit up Ed Rosenthal, who wrote the article on myrcene. He hit up Ethan Russo, who created the ensemble effect. He hit me up. It was the first time I had ever smoked pure THCA, and then pure THCA with a single terpene. It was a world of difference. So he opened our eyes up to this modulation. The rest of the world didn't get to become a part of that conversation until I invited him into Hash Church in 2014. That's when we started talking about terpenes. That's when Horatio started making terpenes, and Tony started making terpenes, and Kay from Trichome Technology was doing terpenes, and Sam was opening up this whole conversation. And of course, what people do is they listen, and then they become experts the next day, and they're like, well, terpenes are very important. It has to be full spectrum. It's like, well, that's just not true. And my perfect example is like, listen, the plant is producing a variety of things for us, and whatever works is what we should be able to do for ourselves. We should not try to pigeonhole anyone into, it's all about full spectrum. I listen to Hash Church, and terpenes modulate the effects. You can't not have all the terpenes there. And it's like, let's say, okay, full spectrum. You're all about your full spectrum. Giving full spectrum to a child with Dravet syndrome, it works for the first 6 months, no problem. But something happens in the grow room at one point in time. There's variables that occur. Pressures are lost. Heat and temperatures are lost. Things change. Maybe something happened in the water. The expression changes, and now that medicine no longer works for that patient. I never want full spectrum to go away. But I also will always fight for monomolecular isolates, because what if there are companies that can come in the future, test a full spectrum cultivar that's being used for neurologically sensitive folks like Dravet syndrome and whatnot, and what say we take that cultivar, we deconstruct it, we reconstruct it in a formulated room where everything is exactly what it was every single time. You've got the recipe. It's absolutely beyond consistent, more consistent than the plant itself will ever be able to be. And now you're now you've got the best of both worlds. We didn't have to get rid of one. Humans just want to put up a fence all the time. Oh, monomolecular, no, full spectrum, no, monomolecular, no, broad spectrum. It's like, oh my God, you guys are fighting for the same plant. Like, you can both have that.
Right. These
It
are all
doesn't have to
tools.
be. It doesn't have to be one or the other, which is the part that I just sometimes want to bang my head, because people, we just want to pick what we want, you know. And that took me a long time, being a water hash and a solvent guy. Now I'm at the point where I, of course, would fight for anyone's right to extract any way that they want. I would fight for the BHO guys and fight for the CO2 guys and fight for the ethanol guys, because we all have our choices and our personal preferences, and I want them all to be available, because what better way to choose when they're all actually available for you to choose, where you can actually make a choice and say, hey, this medicine works for me, or whether it's recreational, it reduces my anxiety and my stress, and it works for me for what I want. So I like the idea of all of these things being made available, and I try not to get myself stuck in a position where I'm choosing what is best. What's best for me is certainly not what is best for you.
Let's summarize what we've learned so far. Cannabis extracts can be produced through a variety of different methods. Solventless extracts can be produced through dry or wet sifting, or by pressing cannabis flowers or the trichomes themselves under heat to produce what's called rosin. Extracts can also be made using solvents, such as food lipids like butters or vegetable oils, or things like alcohols like ethanol or isopropanol, or other things like supercritical or subcritical carbon dioxide, alkane solvents like butane, propane, hexane, pentane, or even refrigerant like R134A, also known as tetrafluoroethane. How cannabis flower is prepared prior to extraction can dramatically impact the final chemistry of the product. For instance, if cannabis flower is decarboxylated prior to extraction, most terpenes are lost, and this is really common with CO2 extraction. Cannabis extracts often undergo a refinement process, like winterization, distillation, or column chromatography, which is the case with a method colloquially referred to as CRC. The safety of a cannabis extract depends on a number of factors, including contaminants, additives, appropriate hardware, the dose, the temperature if you're vaporizing or smoking, and the frequency of use. It's always best to practice moderation with anything in life, dabs included. For extracts that have been heavily refined or manipulated to produce other chemicals like delta-8 THC from CBD, it's really important to understand the purity of the product to know whether unknown chemicals were formed in the chemical synthesis process. Marketing terms like full spectrum, broad spectrum, or whole plant are not standardized terms in the industry, and every company can use these terms according to their own needs. Additionally, strain names and other labels like indica sativa that might be assigned to the cannabis flower often become irrelevant as the chemistry of the extract becomes significantly manipulated through the extraction and refinement process. Now, this isn't the case for all extracts and all processors. There are some processors that have done a good job at keeping the chemistry of the fractions that they're harvesting intact. But ultimately, what really matters to consumers should be the chemistry of the finished product, what it's housed in, the packaging or the delivery method, and how it's used. When it comes to cannabis extracts, it's important not to get lost in the weeds. For the past few years, CBD has been big business. The price of a single 1-ounce bottle of CBD tincture can range anywhere from $50 to $200 or more. Compare that to the average cost of a 1-ounce bottle of a different herbal extract tincture like echinacea or elderberry that would typically cost somewhere between $10 and $20. But what is CBD? CBD is an oily compound produced in the resins of the cannabis plant. Now, whether the cannabis plant is considered hemp or marijuana, they both produce CBD typically, outside of some uncommon exceptions. In the United States, hemp is classified as cannabis plants that contain less than 0.3% THC. In other countries, the limit can be even lower, sometimes as low as 0.2% THC. Instead of THC, which is the primary intoxicating compound found in cannabis varieties, they're often called marijuana. The primary cannabinoid that hemp varieties of cannabis tend to produce is cannabidiol, or CBD. Thanks to intentional breeding efforts, CBD can now be found in concentrations as high as 20 or 25% in hemp plants intended for CBD-rich resin production. Now, CBD is markedly different than THC. To start, CBD doesn't really cause any intoxicating or euphoric effects like THC does. This feature's gotten the attention of a lot of people, ranging from medical researchers that want to unlock the potential therapeutic effects of cannabis without the risk of abuse, and all the way to consumers that just want to check out cannabis, but they're not looking to get high. Although CBD is not intoxicating, it is psychoactive, meaning that it does elicit effects from your neurons in your brain. This is a common misunderstanding about CBD. It is psychoactive, but it is not intoxicating. The story of CBD goes back thousands of years, as cultures across time have used non-intoxicating varieties of cannabis for different uses. But the most relevant part of our story really starts in 1940, when researchers Roger Adams, Madison Hunt, and J.H. Clark published a report indicating the structure of a compound that they had extracted and isolated from wild hemp in Minnesota. Shout out to listeners in Minnesota. You're a part of CBD history. These researchers named this compound cannabidiol, or CBD as it would become commonly known. CBD was only the second cannabinoid found in cannabis at the time, with the first being cannabinol, or CBN, a degradation product of THC. In 1944, it was discovered that the effects of barbiturates could be extended if administered with CBD, but not with CBN or THC. Researchers didn't understand why this effect was happening, and they wouldn't get their answer till almost 30 years later. For a moment in 1963, scientists in Israel would shine light on CBD once again, until a year later in 1964 when they announced their discovery of THC as the intoxicating component of cannabis. After that, CBD would become a bit more ignored once again until around the 70s and 80s when research into CBD really began to pick up steam. In 1972, it would be discovered that CBD actually inhibits certain enzymes in the body, which affects how the body metabolizes certain foods and drugs. This helped begin to complete the puzzle that stemmed from the barbiturate study that was performed in 1944, nearly 3 decades prior, that we talked about previously. In 1981, researchers were able to demonstrate anticonvulsant effects of CBD in humans, indicating that it might be an effective treatment for certain forms of epilepsy and spasticity. In 1982, a year later, CBD was found to exhibit anti-anxiety effects, which would later be reconfirmed in 1993. In 1995, it was discovered that CBD improved symptoms of psychosis. And in 1998, the United States government actually filed a patent on the antioxidant and neuroprotective effects of CBD, as well as THC. The 2000s would become the decade of elucidating the activity of CBD. In 2001, researchers began to finally understand more about how CBD actually works in the body by revealing that CBD targets non-cannabinoid receptors in the body, that it stimulates the production of at least one endocannabinoid, anandamide, and it inhibits an enzyme responsible for breaking down anandamide, effectively allowing anandamide to linger in the body longer. In 2002, researchers would then confirm that CBD exhibits anti-nausea effects, which had already been reported as far back as the 1800s, when systematic cannabis research really began to take shape. In 2004, it was discovered that at certain dosages, CBD can increase wakefulness and counteract THC-induced sedation. So if you're feeling a little sleepy after using THC-rich cannabis, a little bit of CBD might wake you back up. However, be careful because CBD exhibits what is known as biphasic activity, meaning it acts differently in low doses versus high doses. At high doses, CBD can actually be sedating. In 2005, it was discovered that CBD interacts with certain serotonin receptors in the body, and in 2006, researchers would go on to discover that CBD also enhances adenosine receptor signaling, which is associated with heart health, blood pressure, and body temperature regulation. It was also in 2006 that researchers discovered that CBD can kill breast cancer cells, bringing significant attention to the compound as a potential anti-cancer drug. In 2007, researchers began to understand why CBD reduced the effects of THC in some of their prior research. It turns out that CBD changes the shape and activity of CB1 receptors, even though it doesn't really exhibit much affinity for CB1 receptors directly. In this way, it changes the way that THC actually binds to the CB1 receptor, modulating its activity. This kind of activity is called allosteric modulation. This is why CBD is able to reduce the high associated with THC. It essentially deforms the CB1 receptor so that THC can't elicit the same reaction from the receptor when it binds to it. In 2008, it was discovered that CBD was a potent antibiotic against MRSA, a powerful infection that's commonly picked up in hospitals and often resists treatment. In 2012, researchers discovered that CBD may be as effective as standard antipsychotics. And in 2014, it was discovered that CBD might be able to effectively treat acne in the skin by reducing inflammation, fighting bacteria on the skin, and changing the way that the skin produces oil. In 2018, in the United States, the Agricultural Improvement Act of 2018, also known as the 2018 Farm Bill, was passed, which effectively legalized hemp across the United States, including all of the cannabinoids and other chemical constituents of all hemp varieties of cannabis that had THC concentrations below 0.3%. And with that, CBD was removed from the controlled substances list, as long as the CBD was hemp-derived. Some may say that the CBD market began at this time, but really, CBD products had already been available in foods, cosmetics, and dietary supplements widely for years prior to the legalization of hemp, operating in somewhat of a regulatory gray area. And then in 2019, Epidiolex would officially become an FDA-approved pharmaceutical for the treatment of certain forms of epilepsy in children. The status of CBD as a pharmaceutical drug presents a real problem for the CBD industry as a whole. The FDA does not allow drugs to be added to foods or supplements unless they've been marketed as foods or supplements previously. This is due to a set of laws in the Food, Drugs, and Cosmetics Act. Of course, the irony is that the CBD industry has been around for quite some time, not considering the exposure that humans have had to CBD throughout history just from their interactions with cannabis. But cannabis in all its forms have been prohibited in the US for almost 90 years. So of course cannabis-derived products have not been openly marketed and sold. And the Food, Drug, and Cosmetics Act was enacted in 1938, right around the exact same time that cannabis prohibition began. Considering that cannabis was included in the United States Pharmacopoeia for many years all the way up until prohibition began, it's clear that cannabis-derived products had been a part of society well into the 1930s and would have persisted had it not been for cannabis prohibition. So in the 1930s, the opportunity for cannabis to mature alongside the food and supplement industries was effectively eliminated, and the only pathway to get federally legal cannabis-derived products to the public was through pharmaceuticals. And now that hemp-derived CBD and other cannabinoids are federally legal, 90 years later, the government argues that it can't be put into food or supplements because it's a drug. It just seems like an awkward argument when you take the full history into account. Another argument that the FDA argues for resisting making any exceptions for CBD and hemp-derived cannabinoids in foods or supplements is that there's not adequate data available to show that CBD is safe. They've argued that CBD could cause liver damage and interact with other drugs, and thus it should be researched longer before it's allowed to be widely available to be consumed. But the study they cite for this concern is a recent rodent study that looked at dosages that were orders of magnitude higher than the highest dosages used in comparable clinical trials for Epidiolex. I should point out that in this study, dosages of 15 milligrams per kilogram of body weight or less were not found to exhibit these toxic effects, and that's approximately 930 milligrams, or just round up to a gram of pure CBD for an average-sized person. I spoke with Dr. Ethan Rousseau about his thoughts on the idea of CBD causing liver damage. I know there's some concern lately too, and there's controversy over some of it, but about the liver toxicity of high doses of CBD as well.
Well, I think that's a blind alley, to be truthful. Obviously, lower dose would be better, but the liver issues are mainly related to elevations of liver function tests. And this is in generally children who are on polypharmacy with a number of drugs, particularly valproic acid, which is well known for being a bad actor in terms of LFT elevation. So my strong suspicion is that's related to polypharmacy, multiple drugs, rather than a specific effect of cannabidiol.
It should also be noted that the World Health Organization issued a report on CBD very recently, attesting to CBD's remarkable safety profile. At the time of this recording, the future of the CBD industry is very uncertain, as hemp farmers, CBD product manufacturers, and legislators plead their cases for changes to allow the CBD industry to continue operating as it has, with CBD foods, dietary supplements, and cosmetics readily available to consumers. And now states are taking matters into their own hands, just as they've had to do with anything related to cannabis, and they're setting their own laws for CBD. So now there's a patchwork of state legislation across the United States in regards to CBD.
A new state law protects a marijuana byproduct that doesn't have mind-altering effects.
Properly inspected CBD products are now completely legal in the state, and that's good news for farmers and companies who make those products, as it essentially creates a new industry here in Ohio.
The greater question lingering around the FDA's involvement in the CBD industry is whether the FDA will actually take action against these CBD companies. To date, they primarily seem concerned with going after companies making medical or health claims about CBD, but that could change in the future. But the FDA is always going to go after companies making unapproved medical claims because that's in violation of the Dietary Supplement Health and Education Act of 1994, which made it illegal to make such claims without FDA approval. You may also hear this rule referred to as DSHEA. Now, this is why you see an FDA statement on every dietary supplement label, which says something to the effect of, these claims have not been evaluated by the FDA and are not intended to diagnose, treat, cure, or prevent any disease. And yet, we see plenty of medical claims being made about CBD products. It really seems as though the only pathway forward to a booming legal CBD industry across the country is through changes to federal law to allow an exception for CBD and other hemp-derived natural products. But any law changes that are proposed should be carefully worded. Even if CBD is allowed in foods and supplements, if a law change does not also determine that CBD is generally recognized as safe, or GRAS, then there could be another set of problems for the CBD industry to tackle. Food additives like plant extracts and essential oils have to have GRAS status to be freely added to foods or formulated into supplements. Until the FDA takes on the role of doing this research and granting GRAS status to CBD and other cannabinoids itself, it's going to be up to private companies to do their own expensive research to achieve what's called self-affirmed GRAS status, which only applies to their specific products and not their competitors, even if their competitors are using essentially the exact same ingredients. This essentially makes a playing field where only the most well-funded CBD companies can survive long-term. To put this into perspective, gathering all the data needed to successfully achieve self-affirmed GRAS status can cost as much as $1 million or more. At a time when the value of CBD as a commodity is rapidly shrinking, along with CBD product margins, this is a difficult task for small or medium-sized hemp companies to pull off without coming together and pooling their resources. So, okay, these CBD products are on the market. We know people are using them despite, the feedback that the FDA has given. So, what are people actually experiencing with CBD? Since the 2018 Farm Bill was passed, CBD shops have popped up across the country, and even large retail chains like Kroger, Fred Meyer, CVS, and Walgreens are starting to carry CBD products. Additionally, specialized hemp and CBD-focused wellness stores have made their way into neighborhoods and cities across the United States. I spoke with Wendy Nguyen, an owner of a premier CBD shop in New York City, about her experience operating a CBD store.
In a sense, I think the neighborhood felt like they were on the journey with us versus having like a huge reveal when we were done. So they knew CBD store was coming. They knew all that. And they embraced it with open arms, so that's something that we are very lucky to have. So in the end, I think for Artemis, we get clients who are very curious about CBD and we're the first stop. So they want all the inside, they want to know everything, or we usually get we're their last stop, where they've tried, like me, where they've tried everything. They've tried going on pain medication, they've tried going on all that. They want to approach in much more of a natural, plant-based approach. And we do get some clients who are in the middle, where they've tried it and it didn't work, and they're coming back for another option. But most likely it's usually the ends that we get, and since we've been around now for a few months, we're getting more of the middle, which is they've tried their CBD in other stores and now they're coming back for a second opinion and they're coming to us for that. When we first opened, it wasn't like that. With that being said, we had people who were so supportive and they're like, oh, we love CBD, want to try it because, my mother tried it or my dog tried it.
Right, yeah.
Or anything. At the other end of the spectrum where they came to challenge, which was, what are you guys doing? This is not FDA approved, safe at all. So we saw the breadth of clients that we were getting. And, and we really honestly appreciated the support and also the criticism, because that helped us grow as a brand. That just meant that we had to read a lot more books. That just meant that we had to provide a lot more educational tools in the store. And we redesigned the store actually twice to meet those demands, right? Before, when we first opened, our education board was very limited, mainly because we didn't know what we needed to say, as in what was helpful for our clients. But we did that education board probably a month after we opened, because we realized this was the need that they were having. And also we designed it to have a section where there's books available now. And as we were developing, we started really working very closely with Dr. Gina Chin. So the education side came much more, I think, full breath later on as we were responding to our clients' needs. And with that being said, too, when we redesigned the wall, titration was something that people didn't understand. Titration was something that I didn't understand when I first started, And we realized, too, that, reading milligrams to volumes to, it was very, very confusing. And a lot of times when clients come in, they'll be like, I'm taking the CBD oil and it's not working. And we go, okay, how much are you taking? A whole dropper. Like, what does that mean?
Right.
Grams? We don't know. What was the bottle? We don't know. So we realized that the math was very important, that there needed to be a little bit of more guideline on intake and all that. So we designed a section of the shop to be very focused on titration, which is that exactly what you're taking, what formulation you're taking, what brand you're taking. And then we started designing little serving guides for our clients. So every time when a client walks away, they're walking away with a serving guide to couple with whatever product that they bought. So all of that was really the feedback that we got from all the clients interaction that we had at the beginning of Artemis.
One question that was on my mind when I was speaking with people about CBD was, what dosages are needed to actually get an effect? CBD products on the market have potencies of anywhere from 100 to thousands of milligram per 1 ounce bottle of oil. When I reviewed the available scientific literature, I found that there wasn't a lot of information available. Epidiolex clinical trials utilized dosages of 5 milligrams per kilogram of body weight up to 20 milligrams per kilogram of body weight, or around 310 milligrams to nearly 1,500 milligrams for an average-sized person. In 2019, there was a review of dosages that were utilized in published CBD studies, and it was found that dosages below around 2.5 milligrams per kilogram of body weight were largely ineffective at treating most of the conditions that were being measured, except for things like sleep disorders and anxiety. Now, that would be around 150 milligrams of CBD for an average person. However, the research on CBD dosaging is complicated by the fact that CBD exhibits unique efficacy when it's administered in isolation versus when it's administered in the presence of other cannabinoids, terpenes, and other phytochemistry from the cannabis plant. Many clinicians that I spoke with commented that they were seeing much better results at lower dosages with broad or full spectrum CBD versus isolate.
It was interesting when we first started out, we thought half of our patients didn't want THC in their product.
This is Dr. James Taylor, a pain physician working in North Carolina. Ever since hemp became federally legal in the United States, he's been working with his patients to understand how hemp extracts, and CBD particularly, might be a tool to help treat chronic pain.
So we gave them just CBD, and the others did want a little THC. And what we found is once again, in the waiting room, the people who were trying the CBD products, the ones that had a little bit of THC and had a full spectrum, were having profound results. Those that were on the isolate weren't having such profound results. So it was in the waiting room that the patients were talking. So when they came back to the office visit, they said, hey, I don't want to take the CBD I'm taking. I want to take the one they're taking.
Yeah.
And so it was the patients that were coming back telling us that this full spectrum was superior over an isolate. So I'm assuming, these large doses that folks need with the Epidiolex and the CBD isolates is because it's just inferior. It's an inferior product, and you can take much less if you're taking a full spectrum product.
I asked Dr. Taylor what dosages he was noticing that his patients were finding relief with, and this is what he had to say.
My patients tend to be the poor and the elderly, so they don't have a lot of money.
Sure.
So we always recommend them to start low and go slow, right?
Yep.
That's kind of in the industry, everybody says that. Well, our patients have to because they can't afford a 1,000 milligram bottle. They've got to, they can afford the 250 milligram bottle. And so a lot of our patients tend to find relief in the 8 to 15 milligram a day range. And I feel like a lot of that is financial pressure that kind of keep them there. Those that seem to be a little bit more successful typically get up to the 30 to 40 milligrams a day. And I'm saying in very general terms because we have patients with all kinds of different pain problems, whether it's a inflammatory component or it's a bone on bone type of pain or a neuropathic type of pain. They're all different. So I'm giving you very generalizations, but we have folks that are taking 2 milligrams a day and some that are taking 200 milligrams a day. So it's very hard for me to say what milligram works for folks. So I do like to start low and go slow and just find really where you're going to settle in. But for me, that's also, we found that also doesn't make sense either because it's the cannabinoid profile that really makes a difference. And we started seeing this in our practice in that we were obtaining a product from one extractor, and then we started obtaining products from another extractor, and our patients were having completely different effects, right?
Yeah.
Boy, it used to make me sleep. Now it makes me awake. And we were thinking, gosh, it's CBD. It's the same. Oh, no. When we looked under the hood and looked at the cannabinoid profile, no, it was a completely different ratio. There was hardly any THC in this product, and there was nearly 0.3% THC in this. So we started realizing, wait, CBD is kind of a misnomer in this industry. Why are we even talking about CBD other than it's easy for the consumer to think like that? But it's really cannabinoids, right? And it's these ratios of cannabinoids that are important. And I think that's what really stimulated us to say, gosh, we have to start looking at this a little differently and a little more scientifically. And it's so much more complex than we realized.
Right.
So we did a lot of retrospective data looking at these thousands of patients we have taking this over the last 2 years. And when we plotted it out, it was not anything that we expected. And I wish I could show you an example where we put positive responders in shades of green and negative responders to a particular, whether we're talking about sleep or pain or anxiety, in shades of red. And it was just a mixture of green and red. So CBD is not this wonderful thing that's going to turn everybody green and it works for everybody. No, half the people it's working positively for, and the other half it's working negatively for, but all on different things. That's when we realized this is very complex, very individualized, and I think that's when we started really paying attention to. We need to start looking at people's genetics and the epigenetics so we understand what they're bringing to the table. And then I think eventually at the end of the day, it's matching those epigenetics with certain cannabinoid profiles in order to modulate the endocannabinoid system to a desired personal effect.
I also asked Wendy what dosages she was using to manage some of her pain and anxiety symptoms.
So I remember I read all the books. I said, I'm going to microdose. And so I started with 5 milligrams first. It was subtherapeutic, so I didn't really feel much on 5 milligrams. And when I was doing New Leaf, I had an episode, a really, really bad pain episode. And I said, okay, if that's not working, so I just took 50. I said, up to 50, which was not a good idea. It worked wonders. 50 was incredible for me. It really helped with my pain. I also had a patch on too as well. So I was taking 50 milligrams twice a day. I was documenting everything. And then I realized that after 3 or 4 days, it stopped working. Like it was perfect. And then it stopped working. And then I went back to Dr. Janella and I said, what's happening? Like 50 was great. And then now it's not working. And she said, potentially you might have capped out on your tolerance. You went up too high. Now your body's just not processing it correctly in that sense. And so we went to another formulation for me. And that one had MCT oil, which I didn't know myself.
Right.
So my own journey with CBD, I've recorded everything. And I've realized someone needs to at least give me much more of a helping hand when I first started. And that's why we're so much more careful when it comes to our clients at Artemis. Like we really want to make sure that we're with them the whole time. But now I know what my therapeutic dose is. Whenever I have an episode, I know what that is. And then I would just go back to my, my microdosing periods after that, because 50 milligrams for me was perfect. And then when I don't need it, I just don't want to go that high in that sense.
The frequency of dosing is very important because CBD, like THC, lingers in the body and can accumulate over time with repeated dosing. So it may be that low dosages of CBD might be effective when taken regularly, but when acute relief is required in the moment, higher dosages may be needed.
Some people have a very profound effect after taking it initially and within the first couple of days, but the majority of my patients don't feel anything for weeks. And it sometimes takes up to months for them to eventually, things to start change. So it's very subtle. And so medicines typically have a very profound effect, it will lower your blood pressure, lower your blood sugar, do something, very predictable at a predictable dose. And CBD and cannabinoid medicine right now is kind of the opposite. There is no dose. The effects that you're going to get when taking this are not predictable. So I think educating my patients and the community that don't think of this as a medicine, really think it's closer to a nutritional supplement than I feel than it is a medicine at this point, because we don't understand it. We know it's modulating and changing your endocannabinoid system, but modulating and changing it in what ways? I can't answer that question yet. So a lot of this is just hit or miss. And for me, being a physician that's dealing with the opioid crisis, I don't have a lot to lose, right? 60,000 Americans are dying every year. We need a Hail Mary in order for this to, for our country to change. And so for me, it felt good bringing something like this into this practice of medicine because we had nothing to lose. It is positively affecting our patients. We are able to reduce their dependency on narcotics, and we are slowly getting there. But that's only because my organization is set up like that. But for a patient who's on a narcotic that just think they're going to buy this off the shelf and it's going to miraculously work, very hard to make this work without having a healthcare professional or a nurse that you could call or someone to help guide you through this process. You're going to be lost.
So clearly people are having sometimes profound experiences with CBD, but how does CBD actually affect the body? Like all other cannabinoids, CBD is not incredibly bioavailable in the body. Most of the CBD that anyone ingests is simply excreted, either unmetabolized or as what's called a conjugated sugar, meaning that a glucose molecule adhered to the CBD molecule as it passed through the body. Now, some of the CBD that's ingested sticks to other lipophilic or oil-loving tissues in the body, like fat, which keeps it from circulating in the body and reaching sites of action. But for those molecules of CBD that do make it into the bloodstream and get circulated throughout the body, an interesting series of events begins to take place. First of all, it's important to know that CBD has a very, very low affinity for either CB1 or CB2 receptors, which, as you may remember from episode 6 of the podcast, these are the two primary chemical receptors that make up the endocannabinoid system. And Instead of directly affecting cannabinoid receptors, CBD tends to stimulate these receptors indirectly by affecting the production and breakdown of endocannabinoids that the body produces on its own. As mentioned before, CBD stimulates the production of anandamide, which is a partial agonist or stimulator of CB1 and CB2 receptors, much like THC. Additionally, CBD inhibits an enzyme called fatty acid amide hydrolase, also known as FAH or FAAH, which would typically break down anandamide, as well as a lot of other things in the body. This allows the anandamide that the body produces to linger in the body longer, thus stimulating cannabinoid receptors for a longer time, at least theoretically. You could think of this as CBD nudging the endocannabinoid system to do its own thing, rather than completely hijacking the system altogether, which is kind of what THC does. That's not to say that the activity of THC is bad or undesirable, it's just very different. Now, CBD also interacts with a putative cannabinoid receptor called GPR55. The GPR stands for G-protein coupled receptor, which is the type of chemical receptor that cannabinoid receptors are. Just a little technical vocabulary. Now, GPR55 is thought to be responsible for some of CBD's anti-epileptic activity, among other things. In addition to these effects on endocannabinoids and cannabinoid receptors, CBD interacts with a lot of other chemical receptors, including vanilloid receptors like TRPV1 or TRPV1, which are also referred to as capsaicin receptors because capsaicin, the chemical responsible for the spiciness in peppers, also stimulates vanilloid receptors. CBD also interacts with serotonin receptors, commonly associated with mood, sleep, and blood pressure. It also influences the activity of adenosine receptors, commonly associated with heart health. And it also interacts with PPAR gamma receptors, which are linked to insulin resistance and diabetes, among other things. In addition to inhibiting enzymes that break down anandamide, CBD also has potent inhibitory effects on a group of liver enzymes called the cytochrome P450 enzymes, which are responsible for metabolizing many common drugs. This inhibitory effect is commonly referred to as the grapefruit effect, because grapefruits are well known to cause this same enzyme inhibition. In fact, you may have once been prescribed a medication that featured a label on the bottle that cautioned against taking with grapefruit. One of the most well-known drug interactions with CBD is with a blood-thinning drug called warfarin.
Yeah, so as an anesthesiologist and pain physician that does very heavy into interventional procedures, I'm always concerned about Coumadin.
To interject for just a second, in case you don't know, Coumadin is warfarin.
And we know that it's metabolized in the liver by the cytochrome P450 system, and that's what as CBD consumers, you should be thinking about that as well. And there were some studies out there to say that it could affect some bleeding times, but we had not seen that clinically. So our patients who were taking this and that were on a Coumadin and that we got laboratory tests, we could not see that their bleeding times changed. So I think theoretically it is possible, but I'm not seeing it clinically. Mm-hmm. What we do see clinically, which could be worrisome, is that when you are taking a CBD product and you're stimulating your endocannabinoid system, which I like to refer to as your inner physician, it's kind of nature's way of keeping you in balance and healing yourself. As your body is starting to heal, and maybe it is competing with the cytochrome P450 system for certain drugs, plasma levels of these antihypertensives or diabetic medications could theoretically be bolstered a little. And with your health becoming improved, we're finding patients needing to get off these medications. So a patient who's taking a blood pressure medicine, we don't recommend them taking their CBD at the same time they take their blood pressure. We ask them to take that 2 hours after that, so we're not worried about dizziness or dropping of blood pressure. And we really encourage them, every patient that gets on CBD, go to your primary care doctor first and let them know you're taking this and have them start to monitor your blood pressure and diabetics and other, so you can reduce these medications if you're able to under their care. For consumers to go out and try to do that on their own, I feel is very risky.
Yeah.
So, that's we haven't seen any problems in patients, but I feel like problems are just right around the corner if we as physicians aren't monitoring these patients as diligently as we need to.
CBD also has been demonstrated to exacerbate the negative side effects of some epilepsy drugs like valproic acid. Because of these kinds of interactions, it's important that anyone taking CBD with other medications do so under the supervision of a healthcare provider to stay safe. One thing that should be mentioned here is that so far we've been talking about how CBD by itself in isolation interacts with the body. When CBD is present in a complex mixture, like in a cannabis extract with dozens or hundreds of other compounds, or when it's formulated in a food or topical product with other ingredients, effects can be very different. A hemp extract product should be judged by the total formulation, not just the quality of the hemp extract used as a single ingredient in the product. It's also possible to manipulate the absorption and bioavailability of CBD using technologies like nanoemulsion, which is a process of breaking up a CBD extract into these tiny, tiny droplets the size of a nanometer, which is 1/1000th of a meter. And then these tiny droplets are surrounded by a little water-friendly casing. What this does is it allows the oil droplets to remain suspended in an aqueous solution. It keeps the oil droplets from coming back together to one another. And this is how you make what's often termed water-soluble CBD, but it's kind of a misnomer. There's really no such thing as water-soluble CBD. Really, what's being made is kind of what would be referred to as a colloid. It's something that remains suspended in solution that doesn't settle or rejoin. But it's not really soluble in water, but I digress. So far, we've mostly been talking about how CBD affects the body when it's ingested or inhaled, but what about the effects of CBD on the skin? There are all sorts of chemical receptors in the skin, including cannabinoid receptors, just like you have in other parts of your body. In general, when CBD is applied to the skin or topically, it only affects the area where it's applied. The exception is when CBD is applied transdermally, usually with a patch. These are similar to like capsaicin patches or even nicotine patches, and they're specially formulated with ingredients that'll help carry things through the skin that normally would have a hard time penetrating. If cannabinoids like CBD can soak through the outer layer of the skin, the epidermis, and reach the lower layer of the skin, the dermis, then it could end up reaching blood vessels and then getting into the blood and being distributed throughout the body. But will CBD actually help keep your skin healthy?
Right now, currently in the market, there's CBD beauty focused products that are oil based. So it's usually like basically an oil or a beauty serum or whatever it is.
Right.
But not necessarily in like a cream based, right? Like a treatment based.
Gotcha.
In that sense. So I think a lot of times clients, when they have acne, their association with oil means more oil. Like if you
right.
face, it's going to produce more oil, right? So
right.
That's the association. So to break down that association to treat acne with oil it takes some time for people to get used to. You know, if your skin issue, I think, requires much more intensive care, we do suggest you taking it internally. So take it as a tincture and also topical method too as well.
Yeah.
I find that to be, for me personally, the best approach. So as much as we advocate taking it for a period of time and then stop taking it, I did that myself. So I took it for 8 months straight, and then I stopped taking it for 2 months to see what were my symptoms and all that. And the first thing that went was my skin.
Really?
Oh yeah, very that was the first thing I noticed. My skin wasn't as healthy, wasn't as internally glowy. Not talking about product, like internally glowy. As it was when I was on it. That was my, outside of the pain management, of course, that was my biggest motivator. Nowadays, whenever I meet people, that was the first thing they say, like, your skin looks naturally glowy. I'm like, honestly, nothing's changed. But just the incorporation of CBD in my life, to be honest with you.
So you can see that CBD's activity in the body is diverse and complex. We still don't understand the whole picture yet. And don't let anybody tell you otherwise. Yet, despite our lack of knowledge about CBD, evidence does seem to indicate that it's a pretty safe compound, even if some regulatory agencies disagree.
I've seen a lot of people conflate, even in presentations at conferences, conflate the side effect profile of pure CBD at high dosage to CBD in general, and that's not a fair comparison. I would say that cannabidiol, despite its many complex mechanisms of action, is an extremely safe drug with very few adverse events.
The most common adverse effects associated with CBD are things like lethargy, appetite disruptions, and gastrointestinal distress. But everyone reacts to things differently. And in uncommon cases, some people may react unfavorably to CBD, just like they might anything else. But like THC, it's incredibly difficult, if not impossible, to overdose or die from using CBD. At extremely high dosages of 15 milligrams per kilogram of body weight or higher, it is possible to cause some liver damage with CBD, but it's also very uncommon for anyone to ever take dosages that high. To put this into perspective, that equates to a dose of around 1 gram of pure CBD for someone that weighs around 140 pounds, or 62 kilograms. For someone like myself that weighs closer to 200 pounds, that dose would be closer to 1.5 grams, or 1,500 milligrams of CBD. To put this issue into better perspective, consider that most CBD products readily available on the market have serving sizes that feature doses of between 5 and 50 milligrams of CBD. According to the safety data sheet for Epidiolex, CBD is tolerated well in humans orally at dosages up to 1,500 milligrams per day. Based on the history of research that exists, it's clear that CBD has a lot of potential as a medicine. Research indicates it may be effective at treating things like anxiety, depression, sleep, various forms of spasticity, pain, bacterial infections, and inflammation. When it comes to skin treatment, it might be effective in battling acne and regulating inflammation of the skin. It is true that a lot more research is still needed to understand how to best unlock the therapeutic potential of CBD. But it's clear that CBD is certainly not another snake oil. But like many things, there's a lot of nuance around the topic. One of the big issues that needs to be understood is what dosages are needed to elicit therapeutic effects. While we have a pretty good understanding of what dosages not to exceed to stay safe, we don't have a clear picture of what dosages to shoot for to achieve targeted therapeutic effects under different conditions. This is why many consumers of CBD are leaving it up to trial and error to find the dose that works best for them. And then, of course, the other sneaky problem is, at what dosages is CBD actually active, and at which dosages are people mostly just experiencing placebo effects? Now, this is a problem that plagues cannabis research broadly, and we need to understand these issues better. Of course, another side to the puzzle is, if people are experiencing placebo effects, then is that necessarily a bad thing considering the safety profile of CBD? My personal opinion is maybe it's not such a bad thing as long as you're not breaking the bank to get CBD in the first place. And this brings us back around to where we started, in that CBD products currently are heavily inflated in value, although the CBD market is rapidly devaluing, and we should see the prices of a lot of CBD products come much more in line with traditional herbal supplements in years to come. I think it's also critical to acknowledge that CBD is not a wonder drug. It provides relief for some people facing certain conditions, but it doesn't help everyone. In fact, in some research trials, CBD actually exacerbated symptoms like seizures and spasticity in some people. As we've discussed before on this podcast, there's no such thing as a magic bullet drug, natural product, or plant that's going to provide nothing but positive benefits to all people all of the time. That's just not the way things work. However, clearly CBD holds some serious potential. So let's briefly review what we've learned. We've learned that CBD is a common cannabinoid found in hemp varieties of cannabis, but it's found in most varieties of cannabis in general to varying concentrations. CBD is not intoxicating like THC is, however it is psychoactive because it does affect neurons. Research into CBD really took off in the 1970s and 80s, but researchers didn't really begin to understand how CBD affected the body until the early 2000s. CBD doesn't interact with cannabinoid receptors very much directly, but CBD does interact with cannabinoid receptors indirectly by stimulating the production of anandamide and inhibiting the enzyme FAAH, or FAAH, that would typically break anandamide down. CBD interacts with a host of other chemical receptors in the body, including miscellaneous G-protein coupled receptors, vanilloid receptors, serotonin receptors, adenosine receptors, and PPAR gamma receptors. And there are others it interacts with as well. CBD inhibits enzymes in the liver that are responsible for breaking down many common drugs, which can lead to elevated concentrations of those drugs in the body. Because of this, it's important to communicate with your healthcare provider if you're taking CBD along with other medications that may be affected by the grapefruit effect. CBD is generally well tolerated by most people at dosages as high as 1,500 milligrams per day. Common side effects of CBD include lethargy, gastrointestinal distress, and appetite changes. At dosages above 15 milligrams per kilogram of body weight, liver damage could begin to take place. The LD50 of CBD is thought to be somewhere above 200 milligrams per kilogram of body weight, or over 12 grams of pure CBD for an average-sized person. CBD has exhibited promise as a medicine to treat things like epilepsy, anxiety, depression, bacterial infections, pain, inflammation, and acne, among other things. But more research is needed to properly understand exactly what CBD is effective at treating and at what dosages. Currently, the only CBD pharmaceutical approved in the United States is a drug called Epidiolex for the treatment of certain forms of epilepsy in children. In other countries, you could also find CBD in the cannabis-derived pharmaceutical Sativex, which features a standardized cannabis extract with equal parts CBD and THC. CBD seems to be most effective at dosages above 2.5 milligrams per kilogram of body weight, or above around 150 milligrams for an average person, though there is evidence that some people may find relief at much lower dosages. The form of CBD can affect its efficacy, and every clinician I spoke to recommended broad or full-spectrum CBD extracts over isolates, and that it's best to start at a very, very low subclinical dose and slowly titrate your way up until you find your minimum effective dose. So, is CBD a hero or just hype? Well, it certainly seems that for some, CBD is very much a welcome hero. There's no question that it's an effective treatment for some conditions, for some people. It can be quite safe, and it could help treat a wide variety of conditions without getting people high. However, I must point out that research has indicated that CBD tends to be much more effective in the presence of THC. So as THC-free CBD products hit the market, keep in mind that those products might not be as effective as a product that contains at least a little bit of THC. But for all of the promise of CBD, there's still a lot of unfounded hype for consumers to wade through. It's critical that consumers pay attention to the quality of CBD products, as well as the dosages. Many CBD products feature incredibly low concentrations of CBD that are likely subtherapeutic. In addition, CBD products can be quite expensive, leaving consumers paying out fortunes for low-potency subtherapeutic products. And this trend isn't likely to go away anytime soon. New hemp extract products featuring other lesser-known cannabinoids like CBG, CBC, and CBN are already quickly gaining market buzz, and it won't be long before CBD passes the hype torch onto these other cannabinoids. If you've been involved in the cannabis industry for any amount of time or have visited a dispensary, you may be familiar with a company and website called Leafly. Leafly was originally started as a way to collect information on cannabis strains, and it provided kind of an encyclopedia of cannabis strains. Over time, they've evolved, but their core focus on strains has certainly not gone away. Here's some copy from their website describing cannabis strains, and I quote, "Marijuana strains are organized into 3 primary types: sativa, indica, and hybrid. Each type of strain has unique effects on both the mind and the body. For example, sativa strains are uplifting and pair well with activities like social gatherings and being physically active. On the opposite end of the strain spectrum, indica strains are relaxing and can help amplify a deep level of physical sedation, making indica great for those times when you need deep sleep. Lastly, there are hybrid strains, which fall between indicas and sativas, and hybrid strains offer a combination of both energizing and relaxing effects. Hybrid strains are great for those times when it's too late for an energizing sativa or too early for a sedating indica strain." End quote. Is this legit? Or could this be a well-intentioned, yet ill-fated effort that may ultimately be misleading consumers and maybe promoting bias and placebo in the consumer market? In today's episode, we're going to be taking a critical look at the way cannabis is commonly categorized and represented by strain names and indica sativa designations. And to guide our curious quest, we'll be focusing on several key questions. 1. What do these strain names mean? What is a strain? And what is indica versus sativa? 2. How do strain names and indica sativa designations relate to the genetic lineage and the chemical profile of a plant? And 3. How do any of these labels indicate the effects that a product may have on a user? So without further ado, let's get started. If you ask different people in the cannabis industry what they think of the concept of cannabis strains, you're likely to get mixed reactions. Some people think that strains are completely useless and outdated ideas. Some think that they're concepts that are really only reserved for the craft cannabis cultivators and connoisseurs that have an in-depth understanding of the source of genetics, while others think that strain names are vitally important for understanding the effects that a product's going to have on them. So what's really going on here? Well, first, let's talk about the word strain. In biology, the term strain is generally only used when talking about microorganisms. For instance, there are different strains of E. coli. But in botany, the term strain is not usually used to describe different varieties of plants. Instead, the term variety is commonly used. More specifically, the term cultivar, meaning cultivated variety, is often used to refer to different plant types of the same species and subspecies. An additional taxonomical rank used in botany is form, which is a level lower than variety and is often used to distinguish slightly different varieties of a variety, if that makes sense. For instance, let's take the cannabis strain Gorilla Glue, or GG for example. There are different varieties of Gorilla Glue, like Gorilla Glue number 4 and Gorilla Glue number 12, etc. But Gorilla Glue itself is a variety of a subspecies of cannabis, so Gorilla Glue number 4 and number 12 would really be considered forms of the Gorilla Glue variety. So if we want to be botanically correct, we should replace the term strain altogether with the term cultivar. And if there are variations of a particular cultivar, then those variations should be called forms. But beyond the fact that the term strain is not properly used in the realm of cannabis, there are other problems at play when it comes to how cannabis strain names are used, and we'll get into that a little later. But what about these terms indica and sativa? The old colloquial wisdom states that there are 3 species of cannabis plants: sativa, indica, and ruderalis. Indica plants are short, bushy, and produce heavily sedating effects, whereas sativa plants are supposedly tall and airy and produce stimulating effects. And then these ruderalis plants are often either considered wild plants or perhaps wild or autoflowering plants. But where did this idea come from? Let me begin by saying that cannabis researchers have long debated how to categorize cannabis and how many species of cannabis there might be. The terms sativa, indica, and ruderalis are only a few of many terms that have been used throughout time to organize cannabis. These terms have been used inconsistently by different researchers throughout time to describe different types of cannabis plants. So we're dealing with already a kind of muddy playing field. This basic idea of sativa plants being tall and wide-branched and indica plants being short and densely branched comes from a researcher named Richard Schultes in the early 1970s. Schultes suggested that there are 3 species of cannabis: sativa, indica, and ruderalis. Each of these species was associated with basic morphological characteristics, that the tall cannabis plants were cannabis sativa, the short bushier plants were indica, and the very small, sometimes unbranching forms of cannabis plants often seen in the wild were considered ruderalis. However, a few years later, another taxonomical model for cannabis would be presented that focused on the plant's chemical profiles rather than its morphology. This taxonomic model, presented by a group of researchers called Small and Cronquist, suggests that cannabis is one single species, cannabis sativa, with at least 2 subspecies, sativa and indica. Under this model, the sativa subspecies consists of fiber type and low THC varieties of cannabis, while the indica subspecies consisted of high THC and kind of 1-to-1 THC-CBD ratioed plants. Genetic research performed by John McPartland and Jeffrey Guy confirmed that THC-rich varieties of cannabis are in fact one species. So if we accept this model, which I should point out that not everyone believes this model is accurate, we'll save that for later, but if we accept the Small and Cronquist model, then all THC-rich varieties of cannabis should be cannabis sativa subspecies indica. So in this model, it doesn't even make sense to say that different varieties of high THC cannabis are either sativa or indica. They're just one or the other, depending on how you define the words. Some researchers felt it made little sense to organize a plant based on its intoxicating properties, aka its THC content, and so later on in 1980, a researcher named Lauren Anderson would refine Schultes' taxonomical model, taking Schultes' focus on the growth form of cannabis varieties and adding details about leaf characteristics to the picture. Anderson characterized cannabis indica plants as short, broadleaf plants, and cannabis sativa as tall, narrowleaf plants. And then cannabis ruderalis were these small, weedy plants, just like Schultes described. Anderson also pointed out that these distinctions between sativa, indica, and ruderalis have very little to do with chemical profiles. Keep in mind that Anderson was trying to respond to Small and Cronquist's model and really didn't want these taxonomical names to be associated with chemical profiles. So the work of Schultes and Anderson are largely why we refer to cannabis plants as indica or sativa based on how they look. But why do we often use these terms to refer to chemical profiles as well? Well, it's a complicated story, and maybe a little too complicated to dive into too much in this episode, but here's a kind of brief overview. Basically, the term cannabis sativa was originally used by Carl Linnaeus in 1753 to describe a non-intoxicating form of cannabis that was commonly cultivated in Europe, and we would call this hemp. Cannabis indica was originally used by Jean-Baptiste Lamarck 30 years later after Linnaeus to describe cannabis from India that was intoxicating. Now, the plants that Lamarck reviewed actually had narrow leaves, not wide leaves. And the primary difference between these plants was that the plants that Lamarck was looking at were a little bit shorter, they were definitely more aromatic, and they were intoxicating. Later on, the term cannabis sativa would be used by a Russian researcher to describe forms of cannabis that were from Afghanistan and that were used to make hash, a significant departure from Carl Linnaeus. Then later on, the term cannabis indica would be applied to forms of cannabis from Afghanistan that were used to make hash. So already this is getting very confusing. So these uses of the terms cannabis sativa and indica would become confused more and more throughout time and blended in the minds of many with the taxonomical models that Small and Cronquist and Schultes and Anderson put together separately, ultimately resulting in a totally confused vernacular that we've been stuck with to this day.
The thing about the whole species controversy, I think personally, it's much more to do with the culture wars than it is to do with any really serious botanical doubt about it.
This is Angus from the Real Seed Company. Angus has spent years traveling around the world collecting seeds of cannabis varieties often referred to as landrace strains, which are varieties of cannabis which have naturalized to the region in which they grow, and a lot of times these strains are really, really old strains that haven't been crossbred into a lot of modern genetics. And through his travels, Angus has had the opportunity to get to know people from cultures all over the world that have been growing cannabis for millennia. And along the way, he studied the issue of cannabis taxonomy in depth and has become a de facto cannabis historian.
Now, there might be bound to be people who disagree with me, but I think that what we were talking about with the court cases in the 70s, where Schultes, he's suddenly, between 1970 and 1974, well, actually 1970 and about 1972, that was when he started to appear as an expert witness for the defense in these court cases. He suddenly reversed his whole position on the taxonomy of cannabis between one paper, where in 1970 he gave this very coherent, authoritative account of, cannabis is a monotypic genus. It has just the one species. Everyone knows that. It's obvious, and you have different ecotypes and cultivars within that, but it's just one species. And then suddenly, 1972, he's had this huge change of heart, and he's appearing as an expert witness, claiming that there's 3 species, and the legislation only mentions cannabis sativa. How can the prosecution prove that this is not cannabis indica or cannabis ruderalis? And and then he just breaks it all up into this kind of really like counterintuitive. Suddenly you put cannabis sativa is hemp and it's kind of Indian ganja land races, and you just bung them in together. Just create chaos.
But the story gets even more confusing. So far, we've talked about 2 ways of categorizing cannabis. One that categorizes cannabis by morphology, or its shape, and the other that categorizes cannabis by chemotype, or its chemical profile. But there's another way of categorizing cannabis, which we already hinted at a little bit, and that's by the plant's genes. A researcher named Carl Hillig performed several different experiments looking at the genetic and chemical variation among cannabis varieties, and in his genetic research, he made a scatterplot representing differences between samples and then compared the data to different indica sativa taxonomical models, including Schultes' model, Small and Cronquist model, and others. What he found was that of the major taxonomical models that he reviewed, including those by Schultes as well as Small and Cronquist, none of them fit his data. His data showed 2 distinct clusters, seemingly representative of a split in the cannabis gene pool. But do these 2 clusters represent unique species or subspecies? And why don't they fit any of the models that have been presented before on how to categorize cannabis? In their book, Cannabis Evolution and Ethnobotany, Robert Clark and Mark Merlin present a revised taxonomical model that states that all THC-rich cultivars and broad-leafed hemp cultivars are cannabis indica, and all narrow-leaf hemp is cannabis sativa. This model also posits that all cannabis varieties are ultimately derived from a single putative ancestor. And in this model, THC-rich cannabis varieties are separated on the subspecies level by their morphology and named after their presumed origins. So, for instance, narrow-leaf THC-rich varieties of cannabis are cannabis indica subspecies indica, representing their presumed origins of India, while broadleaf THC-rich varieties are cannabis indica subspecies afghanica, referring to their presumed origin of Afghanistan. Broadleaf hemp varieties would be cannabis indica subspecies chinensis, which represents their origins from China, and then narrowleaf hemp varieties would just simply be cannabis sativa subspecies sativa under this model. One of the main things I want to point out is just that under this model, your narrow-leaf THC-rich varieties would be called indica, and your broadleaf THC-rich varieties would be called afghanica. Quite different than the way we use indica and sativa currently in the colloquial sense. Upon careful review, it appears that the colloquial use of indica and sativa is really just a bastardized synthesis of taxonomical systems, and it doesn't accurately represent any single system of organizing cannabis. In short, it's made up. It seems to take elements from each of these systems that we've covered, but it fails to accurately deliver on any of them. And it's really quite a mess that should be abandoned. When I was attending the University of Mississippi and spending time at the NIDA cannabis lab there, I actually asked the researchers how many species of cannabis that they recognized, and I was given a very firm answer that there was only one single species of cannabis, Cannabis sativa, with all other variations underneath that species. When reviewing the Integrated Taxonomical Information System, cannabis is listed as a single species, Cannabis sativa, with all of these other taxonomical systems listed, but identified as not recognized. Perhaps as genomic research into cannabis progresses, the taxonomy of cannabis will evolve. Based on trends in biology, this is very likely to be the case. Genetic research is leading to many changes in how all of life is categorized across the board, and cannabis is not likely to escape this rearrangement. Taking a step back from all of these taxonomical models, let's briefly discuss what terms like sativa and indica and ruderalis mean from a botanical perspective. The term sativa is typically used to refer to cultivated plants. For instance, the common oat is Avena sativa. The term indica technically means from India, and the term ruderalis is derived from the term ruderal, usually used to describe plants that grow easily in disturbed areas. The cannabis researcher John McPartland has argued that we should take the meanings of all of these different terms seriously when deciding how to talk about cannabis. For instance, as far as we can tell, only domesticated varieties of cannabis still exist in the world. Sure, there are plants that have escaped cultivation and renaturalized, but are there really any varieties of cannabis in existence that are untouched by human domestication? It's highly unlikely. Cannabis has been cultivated for thousands upon thousands of years. So does that mean that all cannabis in existence today is technically sativa? Well, maybe, depending on how you want to use the terms. And then what about the use of the term indica? McPartland has argued that we should actually split THC-rich cannabis into two varieties based on their origins, one being indica, those from India, and one being afghanica, those from Afghanistan. Now, this might sound familiar because this is the model that Robert Clark and Mark Merlin used when they came up with their taxonomical system. So regardless of how we want to categorize cannabis, if we want our vocabulary to be consistent, we should use these terms intentionally according to the manner in which these terms have been applied in other plants in botany. In John McPartland's 2018 review of cannabis taxonomy and systematics, he provides a suggestion for fixing these labels in our cultural vernacular to make them more accurate. He states, and I quote, "In summary, reconciling the vernacular and formal nomenclatures, quote-unquote sativa is really indica, quote-unquote indica is actually afghanica, and quote-unquote ruderalis is usually sativa. All three are varieties of one species, Cannabis sativa," end quote. But leaving the taxonomy debate aside for a moment, just how reliable are indica sativa designations or strain names in terms of genetic lineage or chemical profiles? Let's start with genetic lineage. Do strain names and indica sativa designations actually correlate with genetic lineage? The short answer is not really. First, let's look at some basic issues. First of all, strain names are often mislabeled. Now, this happens both intentionally and unintentionally. It's common for cannabis cultivators to cultivate multiple varieties at once, and it makes sense that in the hustle and bustle of harvesting and processing, that some containers of plants may get mislabeled. Additionally, when someone receives clones, they might get a plant that was mislabeled, and so through no fault of their own, even if they're maintaining the cultivar name that they received when getting their propagation materials, they still might be labeling their plants incorrectly. However, on the more nefarious side of things, some cultivators will actually change the cultivar name of a batch of cannabis solely in an attempt to make it more sellable, because some cannabis cultivar names, some strain names, are more popular than others season to season. Second, strain names are often inappropriately applied to plants propagated from seed, where you'd introduce genetic variation. These two issues alone have muddied the playing field so much that the reliability of any one strain name just in terms of genetic lineage, is a real crapshoot. The same issue can be said for indica sativa designations. Even if we were to accept the colloquial definitions of indica and sativa, the fact of the matter is that cultivators and product manufacturers often use these labels to indicate an anticipated effect more so than in any reference to the genetic lineage or even the morphology of the plant. Additionally, there are several online tools that allow you to examine how genetically similar and dissimilar different cannabis samples are. One is called the Galaxy by Phylos Bioscience, and the other is the Cannapedia by Medicinal Genomics. At least these are the ones I'm familiar with. Using these tools, we can examine data related to samples that were labeled as Blue Dream, for instance, which is a really common strain. On the Phylos Galaxy, right away we can see different unique genetic clusters, with some clusters being substantially unique and far apart on the Galaxy. If you go onto the Cannapedia, you can search for all sorts of samples and see a hodgepodge of close relatives, some that are labeled as the same strain and others that are definitely not the same and theoretically should be quite different based on colloquial wisdom. Now, this isn't to say that there's absolutely no consistency behind strain names. I want to point out that there are, in fact, genetic patterns among cannabis varieties. And there are these clusters, so there are large amounts of samples that have the same strain name that are genetically very similar. But we have a lot of clusters. So for instance, going back to the Phylos Galaxy, you'll find that there are distinct genetic clusters of close relatives among any one strain name. But which of these clusters is the true OG or the true Blue Dream? Is it the biggest cluster? If so, why? Who decides what Blue Dream or OG Kush or any other strain actually is genetically? In the Cannapedia database, while you will see a strain name listed, you'll also see a unique identifier that's the true label associated with the genetics that were tested from that sample. From a genetic perspective, the strain name is largely irrelevant. However, if you focus on a sample that was labeled Blue Dream, for example, you'll likely see that it has close relatives that are also labeled as Blue Dream. So there is some consistency, just not enough consistency for consumers to trust these labels. I hope that distinction is being made clear here. There is some consistency, just not enough. So, strain names and indica sativa designations don't mean much in terms of genetic lineage. But what about chemical profiles? To begin to tackle this issue, we need to review a lot of data. So I went to my friends at Confident Cannabis to get their opinions on the issue. Confident Cannabis is a technology company that provides various software solutions to cannabis testing labs, growers, producers, dispensaries, and what they're trying to do is to bring transparency to the supply chain. Their platform captures a lot of data about products moving around in the cannabis industry, and by analyzing this data, they've been able to glean some interesting insights.
The cannabis chemistry is super fascinating, and we think it's really important. The general population isn't educated enough to really know what to do with this information, but we have built tools like Connect.
This is Steve Albaran, the CEO of Confident Cannabis.
If you want to go to our website and click the button at the top that says Connect, it's a free tool. We don't make any money from it. We built it because we thought we kind of had a moral obligation to do that. And really what it is it's a 3D visualization of cannabis chemistry. And so you'll see a number of different dots. Every dot is a particular strain grown by a particular producer in a particular state. And the location of that dot is a function of several different chemicals and their concentration. So THC, CBD, but as well as THCV, CBDV, CBG, and so a number of minor cannabinoids, but then also a number of terpenes, beta-caryophyllene, limonene, pinene, all the usual suspects. And based on the distribution of those various compounds in that particular batch or group of batches, that'll determine how close or far they are from another dot. So the way to read it is if the dots are close together, they're chemically similar. They're far apart, they're chemically distinct. And so what you could do is you can go in and you say, okay, I'm looking for, let's say, OG Kush, right? And if the dots are all over the place and widely spread out, that tells you something very important. It means that it's a highly unreliable strain name. There are lots of strains that you might find in a store that are called OG Kush that have widely different chemical compositions. Conversely, if you type in a strain name and find them fairly clustered together, it's a fairly reliable strain name. But in general, we've obviously looked at all this information. Strain names are very unreliable. They're not bad. They're not evil. They're brand names, but they don't really tell you much about chemical composition. And because cannabis is so diverse, it really does matter, the ratios of these profiles. Some people don't like the effects of high terpinolene strains. Some people do. Some people want high myrcene strains. Some people don't. And not to mention CBD, THC, concentrations being important.
After reviewing this tool myself, I had Brad Bogus from Confident Cannabis go through the Connect platform with me to explain how it works and exactly what I was seeing.
The takeaway from this type of an experience is that strain name is not really the most predictive indicator of chemistry, right?
Right.
Whether they're genetically certified or not, a strain name is how most people are buying cannabis. And we can see that you can't really expect exactly the same thing. You can expect some similarities, but you can also expect a few differences across the board. If I go buy mimosa in California, or if I go buy mimosa in Oregon, I'm going to have probably two very different mimosas. And really, if I buy a few mimosas out of Oregon, I might end up with this one here. I might end up with this one here. Pretty different, right? So that's one thing that's a good takeaway from this, is that like genetics and strain name, not a great predictor. If you want to like actually solve for genetic differences, for instance, mimosa being a really highly circulated strain, you might get an unscrupulous producer calling something mimosa that's not genetically certified as mimosa.
Exactly. Yeah. Just to make it more sellable.
That's right. So we like to use Slimer as a really good example of how even when you solve for the genetics, you still see variants. So Slimer is only available via certified genetic clone from one company. When you see Slimer on the market, you can rest like 99.9% assured that it is genetically Slimer. You can't really be called it. If it's not, you can't get it anywhere else. And nobody's really asking for Slimer in such a high demand that someone would call something Slimer that's not. It's not a very appetizing sounding strain name. Right?
Yeah.
Right. So what you see is pretty consistent expectation of outcome, but what's this guy doing over here? Right? This is someone in Oregon who's produced Slimer, and it's an extremely different outcome than this Slimer. In fact, almost all Slimer should have terpinolene in it. As you can see, you can produce it differently. I mean, these are, lighting inputs, these are water inputs, these are fertilizer inputs, it's soil, this is climate, this is cure, this is so much that's going into what makes cannabis that you can't expect that you're always going to get the same reaction. Genetics might get you most of the way there, but they're not going to get you all the way there.
But what about indica and sativa designations? How do those associate with chemical profiles? What correlations is this data set showing between what people are classifying as quote-unquote indica and sativa?
So this is actually my favorite thing about Connect. You talk to people in the industry and you'll get a general consensus that most people think indica sativa doesn't mean anything.
Right.
That it's actually kind of nonsense. That like some sativas actually make me really, really couch locked, and some sativas make me geek out. So if I get this range of feelings, how come all cannabis is expected to live in a binary of upper or downer?
Exactly, yeah.
Nonsense. So one of the ways that you can actually explore that within Connect is to click down here where it says cannabinoid. This is a way to color the dots based on different information. So we can kind of filter for different stuff. Right now we're filtered for cannabinoid class. You can filter for indica sativa. And what that does is it colors the sativas red, colors the indicas blue.
Okay.
We picked pretty divergent colors here so that you can really see, them stand out. And all the hybrids are gray because they're hybrids, right? They kind of are all the same.
Yeah.
What you'll notice is that there's not a space within Connect where red exists and blue doesn't, and vice versa.
Right. Yeah, they're all over, all intermixed. Yeah.
Exactly right. And that's because indica sativa don't have any chemical meaning. They actually never have had any chemical meaning. I don't know why it got ascribed to it.
Okay. So these names don't seem to be strongly correlated with genetic lineage, and they don't seem to mean much in the way of chemical profiles. So what gives? Well, in short, we need a new system of categorizing and talking about cannabis. If we're interested in how something's going to affect the body, then we care about chemical profile, and we need a better vocabulary for talking about patterns of chemical profiles in cannabis products. If we're interested in discussing plant morphology, we need a vocabulary to talk about that, which is consistent, accurate, and separate from the vocabulary we would use to talk about chemical profiles. It doesn't really make sense to intertwine these two things. And if we're interested in discussing genetic lineage, we need assistance from genetic mapping tools and some standardized naming conventions for cannabis cultivars, which are based on genetic data. Several researchers and companies, like Leafly, have proposed alternative methods to address these distinct problems. But so far, none of these solutions have really taken a strong hold in the cannabis industry, at least yet. Going back to where we started, with Leafly, they have attempted to produce a visual guide to understanding a strain's chemical profile. And this visual guide is represented by a series of shapes and colors with unique meanings. Like in the center of this picture, there'll be a shape, and one particular shape represents a THC-rich cultivar, a different shape represents CBD, for instance, and then all around this shape in the center, you have these other shapes and colors that represent terpenes and their relative concentrations. And the attributes that are associated with each strain are based on numerous lab tests, which is certainly a step in the right direction, seemingly, but the website then goes on to associate each strain with effects like sleepy, relaxing, uplifting, energetic. But this is all potentially flawed in a number of ways. First, it assumes that a strain name is represented by any one particular chemical profile, which, as we've talked about before in this episode, chemical profiles among strains are not consistent. Even when basing the findings on aggregates of terpene data, you're still left with an average chemical profile that doesn't necessarily represent anything that someone will find in a dispensary. And concerning predicting effects, if you dive deeper into Leafly's data, you often find that even consumers don't agree on the effects of a cannabis variety. For many strains that are on Leafly's website, close to 50% of people report the most commonly reported effects. What that means is that nearly half of people that tried any particular strain actually do not feel those same effects. So this isn't just some intellectual or academic exercise. Actual consumers of cannabis are even saying, without realizing it, that the effects associated with cannabis strains are inconsistent. Another issue that we haven't really gotten into at all in this episode is, even if you know the chemical profile of a cannabis variety or a particular cannabis product, can you actually predict the effects it'll have on somebody? The way that the cannabis industry talks about strains and chemical profiles and indica sativa designations, you would assume the answer is yes, but it's not so straightforward, and we're going to save that question for another time. So, as a consumer trying to find cannabis products that work best for you, what do you do after you learn that all of these names, whether they be strain names or indica sativa designations, are unreliable? My takeaway is this: stop relying on strain names, stop relying on indica sativa designations, and start journaling. Pay attention to the chemical profiles and the organoleptic characteristics of what you consume, and keep track of how you respond. You may find that a single chemical profile affects you differently at different times of the day or in different settings. You may find that the cannabis that your bud tender told you would put you to sleep actually makes your heart race and wakes you up. You may find that a small toke produces very different effects than consuming a larger dose. There are so many variables at play that will influence how a person will respond to cannabis. To dilute all of those variables down into a simplified model of cannabis strains or indica sativa designations is really a fool's errand. There is also the hidden and impossible to quantify variable, which is you. The chemistry of the product is only part of the picture, and the biochemistry that your own body brings to the table is the other part of that picture. No one can tell you what's going to work for you, or how something's going to affect you, and there's no surefire way to predict it. It comes down to trial and error. If you're looking for a good journal designed for this purpose of tracking how cannabis affects you, I recommend checking out Gold Leaf's Patient Journal. I'll be doing a review on Gold Leaf's journals and other educational materials that I'll be posting on the Curious About Cannabis YouTube channel soon. So let's review what we've learned so far. The cannabis industry uses a common colloquial vocabulary to talk about cannabis varieties, where sativa is used to describe tall, wide-branching plants which cause stimulating effects in users, and indica is used to describe short, dense plants which cause sedating effects. Researchers currently don't agree on the best way to categorize cannabis, but they do agree that all THC-rich varieties of cannabis are a single species. And even among most proposed taxonomical systems, the terms indica and sativa are used in inconsistent ways compared to how they're used colloquially. The current colloquial indica-sativa model is not grounded in any scientifically recognized taxonomical model of cannabis. Research indicates that strain names and indica-sativa designations do not strongly relate to genetic lineage. Although there are distinct groups of chemical profiles among cannabis varieties, research also indicates that strain names and indica sativa designations do not strongly correlate to these chemical profiles. It's important for the industry to define new vocabularies and systems of categorizing cannabis which are more accurate and precise and less confusing to consumers. In the meantime, the best thing you can do to find cannabis products that work best for you is to keep a journal and track what chemical profiles, smells, tastes, dosages, etc. that you've tried and what the experience was like. And in this way, you can begin to transcend strain names.